Bike Chat. Welcome everybody to MC Tune, where it's always Tunes Day night. How about that? Tonight, I will be having a discussion with Jeran from Jeranism. If you didn't know that he's from Jeranism, he thinks the Earth is flat, and we did have a conversation with him. I did a few weeks back. We had two particular things that we were going to revisit. We're going to talk about them, and then we're going to probably bring up a couple other things. He has kind of a format. He likes to have a format and then run the clock, but then it didn't happen last time. So anyway, we'll try again. We'll see if that works. So the two things we're going to be talking about: when you compress something horizontally, does a diagonal line become curved? And the other is he said that he was going to have a look at the parallax measurements of the ISS. So I'm going to join him in a couple minutes at about 8:10 my time, 6:10 his time. So I got a couple minutes before that happens. So I have a super chat from PhD Tony that says, "I look forward to being called a malicious liar or staggering incompetent by your guest, who will then turn around and insist that he should be treated with dignity and respect." Well, you may have just predicted the future. How is it? If you did, how is it that you know the future so well? But so I have prepared. I have a folder of 34 photographs and things that I did to go with the horizontal compression and stuff. I used the P1000, the flat earther camera of choice, to do some photographs, and I did just some straight Photoshop work. So, which he seemed to think that for some reason that a diagonal line in a computer screen would curve when you compress it. So, does it? I've already done the work and I know, but can you guess? Of course you know. Why would it compress? I don't understand it. But he has actually he has another thing where he thinks, for some reason, that things, if you're viewing something from a high angle, doesn't matter top, bottom, middle of frame, it will do something, or versus different, if you're below something looking up, it will cause the image to the photograph to distort differently based on the angle that you're viewing something at. So I got some samples of that as well. That's with the P1000, the flat earther camera of choice. So PhD Tony says it's Friday for me. I am in the future. Well, welcome to the future. I, by the way, am a time traveler. I came from the past. I just did it again. So, have Robert H. IUS. Robert Hughes says, have they upgraded from the P900? Yeah, generally it's the P1000 now. They actually, Nikon actually created a P950, which is a P900 optics, like everything is the optics from the P900 with the actual like computer and software from the P1000. So I've only used the P1000. It does appear to be a little better than some of the options on the P900, but it doesn't give you some basic things like exposure control is difficult to do. Exposure locking is like you need to know tricks to do it. Is it just a kind of a quick, easy thing? So the UI is a little sloppy on it. I don't know why, because I've used my previous camera was a Pentax from quite a while ago, and the UI on that was a little easier. So I don't know. So anyway, Daniel Pratt is demanding that NASA put a P900 on the moon. I always find that weird because flat earthers have demanded that, put a camera on the moon doing a 24-hour live stream of the Earth. There are multiple cameras pointed at the Earth giving 24-hour live streams. Why would one being on the moon make any difference? I would think, right, you wouldn't see the moon, right? It'd be pointed up. So you would never see the moon. So you wouldn't know that it's on the moon. I suppose you could have a camera on the moon pointing towards the Earth, and then a camera sending a live stream of the camera recording the, right? But of course, then how do you know that that camera is real? So you have to have another camera recording the camera, recording the camera, recording the Earth. And then you just get into this point where it's cameras all the way down. So yeah, there's unlimited cameras. It would just be everybody doing their own mission, sending up cameras to record the other cameras to make sure that the one camera is actually pointed at the Earth. So anyway, that would be ridiculous. Jeep Journey says that's how black holes are created. Yeah. Jeep Journey, I like that name. I rebuilt the differential in a Jeep. Yes, the Dana 35. So anyway, all right. Let's see. I'm in the Zoom call with Jeran, and he has me like really. He has this weird. If you saw the thumbnail, this thumbnail he created that we're using right now, and so he has him and me in really small. So I'll have to set up the scene and everything, but I think he's still greeting his fans, his people. I hope this is good. So people, I said it last time. I'll say it again. Be respectful. If you do go over to his stream, don't be a jerk. Let the flurfs be the jerks, and we can be the decent people. In the chat, which I'll have on the screen in a second here. In the chat, mods, don't just blanket block people. If they're being stupid, let them be stupid. That's funny, right? It's a permanent record of their stupidity. So when their children happen on this in 20 years, they're like, "Oh, Daddy, why were you so dumb?" Hopefully they don't reproduce, but anyway. So there it is. Let's see here. Here we have. I'll show you. There he is there, and he's we're coming up on the time. So all right, my 2 cents is Gary Wybenga. So nobody. There you go, Clive Wells. You gotta time him out. That's the rule. Sorry, Gary. I just make the rules. So all right. I'm gonna pop into Jeran here, see how it's going. I hear a little clipping. There's some people. There's some sort of audio something with Jeran. He fixed something, but it was still a little weird.
Still weird, beyond.
I don't know. Technical difficulties.
Let me check what you can hear me though.
Yeah, but it's bad.
Oh, still.
It's. I mean, you.
Well, okay, see if I can figure it out.
Dude, you should live stream sometimes and get good at
Yeah,
it.
cool. You could get good at it if I tried it a couple times a week or something. Let me check audio, advanced audio properties. If there's something in there. What?
That's a good. Well, while you're thinking about that, try to fix it, Jeran. Thinking about Cake says, I still can't get over why they think every picture of the Earth is fake. Please ask him if this is true for him.
Every picture of the Earth is fake. Yes, from space. Yes.
There you go. There you go. Thinking about Cake.
Thinking about Cake, huh? All right. Let me see real quick. Can you do that setting? Oops. Sorry, I turned off studio mode, but I came back. Check stabilizer.
And are you getting background noise from me?
Not hear anything.
No. Okay.
Sounds good here.
I have an air conditioner on the floor, or not in the window behind me. So.
Okay. Yeah, that at all. Um,
Yeah, Zoom is pretty good about that, and I have in OBS I have a something a noise suppressor. So all right, have you tried turning it off and back on again?
Yep, I'll do that. I'll try my mixer real quick and turn it off and see if that fixes anything. Be right back.
All right, he's coming back. I'll mute him and so. Anyway, any questions, people? Any questions that you might have for me or for Jeran? As he's working on it, I guess I can hear him. So if he talks, I'll hear him. He's got kind of a confused look on his face there. So I'll tell you, I don't know. It. Everybody says fix. Okay. Yes. I'm glad you see it that way. Yeah, there's globe technology in toothpicks, I guess. Yeah. You'd be diagonal. As well, the Vsauce video from way back, remember that? Where you'd be diagonal till you got to the to the edge of the disc. Yeah.
Description of the video, but I did change a little bit of the layout just to make things shorter. We don't need to go as long as the intro. Should we do a coin flip again to see who goes first?
Sure. But we have
and then we have two things we have to do from last time, right?
Yeah.
Okay. And I wanted to talk about the celestial navigation anyway, because that's what I got the most shit about. So hate to have to teach other flat earthers to not be dumb, but sometimes you have to do that. So what are you gonna do?
I've been trying for years.
It's a little different than that, but let me see if we can get this over here. Let's see. Let's go coin flip. Coin flip. And we'll get that on the screen so people can see that. Which is called come on, where you at? This one? That'll be good enough. Coin flip. All right. You can go first if you want. Go ahead and call it. I'll flip it. Oh, that didn't count. Here we go. Flip again. Ready?
Okay.
Go. You call.
Heads.
It is heads.
Awesome.
You can go first or whatever you like.
I'll pull first.
You what?
I was talking Ultimate Frisbee.
No, we don't know about that. No, come on. Stick the nerd stuff to your audience, all right, would you? Please.
Seriously.
Ultimate Frisbee, is that the cool kid doing that nowadays?
No, it's definitely the nerd sport. Yeah. The tall, lanky kids. Which I am not. The tall, lanky kid. Right. But I do my best.
So I have down intro for 5 minutes. It's up to you if you want to go through 5 minutes, but go ahead.
Yeah. Hello, I'm MC Toon, and the Earth is a globe. It's been measured. Glad to be able to talk to you, Jeran. I think it'll be good. There you go.
That was great.
Thanks.
And I don't have one either much other than I really do have this dream of conversating with some globers to a certain extent and getting some ideas across and getting a better idea of their understand or their beliefs. But also sometimes maybe that's not going to work when, we're just at like a impasse or where people are being too stubborn or won't concede points. So we'll see if that goes that direction tonight or if we can do this again we will find out, I think, soon enough. So what did I see? The complaints and the arguments about last time, people saying that I didn't put your feet to the fire as far as the observation of the ISS going across the moon and the measurements taken by the two people. And they said, you didn't hang him on the fact that they did it from a flat baseline, therefore you can only do celestial navigation on a flat Earth. Let me just start with this point and hopefully people get it. Let's pretend, we're just pretending for a second that we live on a globe. Okay? Pretending for a second that we live on a globe.
I don't have to pretend, but yeah, go ahead.
So you can just keep your same beliefs. I'll pretend. Could we use the GP of a star and its location from us to get a circle on a globe? Meaning, can we take the angle to a star and its GP location and get the distance from that GP, draw a circle, do that 3 times, and then wherever the circle crosses, each one crosses identically, that is the spot where you're at. So I don't understand what they mean by you can only do it on a flat Earth, because you could do it if you lived on a globe, correct?
Yeah, the geometry, that would be how you do celestial navigation on a globe. And it would it'd be a bit different if the Earth were flat. You'd have to have a different process.
Well, you could have the same process, but it's not going to work by the numbers that they give you, because you're going to use the reduction tables and everything else, and you're going to get off what the true angle would be. But I guess where I can confuse is they're really pushing this real hard, right? They keep pushing this whole thing of if you're doing a flat baseline, then you must be on a flat Earth. But I don't think what they understood is you were talking about them being 1 kilometer apart, correct?
Yes.
Okay, which is
I think it's 1.1 or something, yeah.
Okay, which is like 0.6 miles. So if you look at the curvature involved in that, it's like 4 inches. Okay?
Yeah.
So I don't really understand what they're getting at. So if I called you out and said, haha, you're using a curved baseline. Well, yeah, but the curve is 4 inches. And McTim made a point of saying he wasn't going to use the curvature in that formula or in that description of that observation.
Now for reference, those people that say, you used a flat baseline, they definitely could go do the geometry using a curved baseline as well for that 1.11 kilometers. And then get the numbers. And what you will find is that you won't actually have a difference in the elevation of the ISS that you measure. And REDS and Astronomy Live did a second transit parallax measurement. And in that one, in the video, they went through the process using a curved baseline. So the people that are like, you can't use a flat baseline, well, you can go look at the curved baseline and use the curved baseline. Now, you know what they would have said if we used a curved baseline, if I'd used that one last time? They would have said, you can't presume. Right? And then I'd be like, oh, well then you can go to look at the flat baseline. So you can use either one, and what happens is that it is just a part of the error that it introduces to it, but the error will be so many digits deep that it's not going to make a difference.
I can't see it making a difference. And if I'm wrong about that, then they can show that. They can show, well, look at here, this is the difference, and you'd be off by this much. I mean, I think you're off more in the fact that 1 degree is 60 nautical miles. So to me, that alone, I mean, you're not going to get within 1 degree of your estimation of what angle a star's at. You might be able to get within, a couple degrees, but if you're off by just 1 degree, you're 60 miles off.
When you're measuring with the sextant?
Yeah,
I mean the ISS one, they weren't using a sextant; they were using a telescope.
Right, he just looked at his telescope and said it was 56 or something.
Well, with celestial navigation, the reality is that people are within 5 miles of their actual location pretty commonly.
So how close do you have to be then to your angle to be within 5 miles?
A 1 degree is 60 nautical miles. 1 arc minute is 1 nautical mile. Okay. And a sextant measures in typically tenths of a minute. So that'd be it'd be a tenth of a nautical mile, right?
Yeah, I'd have to see that. I mean,
and so that's the precision that it's able to do. Now, whether or not somebody is actually getting it that good is that's up to the operator. And a higher quality sextant versus a lower quality sextant can make that difference too.
So let me ask this again, just because for my own knowledge. So you do believe, yes, that if there were a flat Earth, let's say there's a flat Earth, and somebody wanted to deceive the people on said flat Earth, could they not then project that flat Earth onto a sphere? And then from there, couldn't they do some clever mathematics, come up with the GP, drop it down to what they want it to be, and then because you're not really getting that distance, they're telling you the distance. You don't know the distance from the GP of that star because they're giving it to you.
Yeah, the angle. No, the angle outputs that.
Then you wouldn't need reduction tables.
No, the reduction tables are so that you can draw the intersects. That's why. There's other ways.
The line.
Yeah.
Right.
Yeah. If you watch the video,
circle.
If you watch the video that I have that Protothad did, he did it in a very visual way. He used a compass. On an actual globe with a dry erase marker, and the globe was like a dry erase globe, and he drew this actual circle on it. But when you're in a boat, you're not doing that, and that's not very precise anyway. So when you're actually doing celestial navigation, I have the book. Oh, here it is. When you're doing actual celestial navigation, this is you're drawing the intersects on this. So and this represents a very small area. So in order to get
the line is then part of a circle.
This is part of a circle, yes.
Okay.
Right. And of course you're so zoomed in that line you can't it doesn't matter. It's a manifold. The manifold is something when you're so close to it you can't distinguish between a curve and a straight line. That's what a manifold is. So they don't use that terminology in here, but that's what they do. So that's
and you're saying it can't be used on a flat Earth because if you were to draw circles, they wouldn't be circle?
No, the reason why you couldn't, if it were a flat Earth, it would be different, is because you couldn't use that the very first step wouldn't work, because the very first step is the angle multiplied by 60. That's it. You take the angle or the co-angle. It's the departure from zenith, right? So if the star is 10 degrees from
minus
zenith,
it from 90, right?
Yeah, well, yeah. You measure it and it's 80, and you subtract from 90. That's rough, right? There's more precision that you can do in that, but simplifying it. So hold on. I want to be clear. Hey, Oakley crew, I'm simplifying things. All right, so yeah, that's why I started with if your departure from zenith is 10. So if you're sitting at 10, then you know you're 10 times 60 nautical miles away. So that's the thing right there. That's completely based on the globe geometry. If it were a different shape, that would have to be done differently. You couldn't just multiply by 60 nautical miles because you'd have to be doing arctangents to get the distance.
I guess I'm still confused as to if it was a deception that people originally had a flat plane, they then projected it onto a sphere, they then created a celestial sphere, they then were able to locate where the GP of every star would be on said sphere. And then somebody could do celestial navigation by looking at their angle to a star. Let's say it's, like you said, 80. And then you do that reduction. You get the 10, you get the 600, whatever. And then you're drawing a circle around. So I could see where it still would work on a globe. It's still how you would, but I don't understand why
you wouldn't. The part where you multiply by 60 nautical miles, that's the part that would have to be different. You'd have to do an arctangent function.
Okay, but the difference between a flat Earth and a globe when talking about a GP is only then the curvature, which you're then looking at the chord length of, the chord length of 2,500 miles is probably, the difference between a curved 2,500 miles and a flat 2,500 miles is barely anything, right? Well, 2,500 might be a lot.
That's a good amount there. Yeah, that chord length.
How much? I mean, not much.
No, I can't do trig in my head, dude.
Why not?
Hold on, I got my slide rule.
Yeah,
hold on.
Call Red's Rhetoric. He actually told me he can do the 76 moons of Saturn. He can do the more than a 3-body problem. He can do 76 moons of Saturn. He'll do it right now if you want. Just call him. I'm going to look up that up real quick. I just want to see what that is.
Call Red's Rhetoric. I don't have his phone number.
So is that what I'm talking about? Is it the chord that we're looking for, or what?
No. It's because you're looking at you have the angle to the star, and we know the GP of the star because that's published in the nautical almanac.
So let's just say, for example, we're doing Polaris or whatever. Okay, so there's Polaris, there's the one star. We know where the GP is down to the North Pole. Okay, so then let's look at Sirius. We know where that GP would be. It's above whatever, Australia. It doesn't matter. So then once you have those points, of course, you're only going to do the star that's close to you. So you're not going to be that far away, right? What do you think the most distance you are away from a star that you're observing when doing celestial navigation? You're going to try and do stars that are 1,000.
So actually, there's more of a sweet spot. Then you don't want them super close.
Okay.
You want them, and you don't want them really close to the horizon. You want them kind of mid-range. Right. So I don't know the number. I mean, it's going to be a big distance. But here's the thing. Tell me. Let's if you have the angle to the north sure. Star. Mm-hmm. How far are you on flat Earth from the GP?
Your angle minus 90.
No, that's you just used the globe. But do the math.
Well, you're saying,
and then use flat Earth. The problem is you don't really have a map.
But if it was a deception, you guys always want to argue from the point of there's no deception going on, which is not our position. Our position is there is a deception going on. So therefore, you just saying, well, yeah, you're using the globe. Well, yeah, I have to. What are my options?
If the Earth is flat, you would use flat.
Well, yeah, but they've hidden that. So how am I supposed to get that? You think I have the money to go out?
Don't use their stuff. Use geometry based on flat.
Okay.
How far are you from the North Star or from the GP of the North Star? If the angle is
so my angle is like 35 degrees, so then 90 minus 35. Why can't I do that?
Because that's based on the geometry of the globe, actually.
No, it's not. I'm telling you that's the angle that I am to the star. Right? And 90 degrees would be if I was underneath it.
Yeah.
I guess I'm confused what we're missing here. Go ahead, what? I'm trying to see it. So that's called a segment.
What's called a segment?
Well, the difference between the arc length and the chord, right? That's what we're looking for. Because I'm just trying to see. Because if the difference is
no, you're not. Because if it's flat, then it's not a chord. It's just the arc length and the chord. There isn't a difference.
No, it is a chord because it's a straight line between me and the person. Let's say I'm doing it with two people.
Yeah.
But granted, with this case, it's doing it with the GP of the star. But I'm saying.
But for flat Earth, there's no chord. The chord on the globe, the chord goes straight through the Earth underneath the
correct. Wouldn't a chord be the ground length on a flat Earth?
But there's no concept of a chord if it's
right. Well, but I'm trying to show you that the difference in distance. Like, let's say that the United States was flat and it's 2,500 miles across. Okay, great. If then we add the curvature of the United States, the distance is like 2,540. It's not even that much, I bet. It's not even 40 miles. It's probably way less. But I'm trying to ask you, how do I figure that out? I think you would have to know the arc length of that segment of a circle.
Yeah, and the chord length.
You get the chord. Yeah. Right. That's what I was asking. Okay.
Yeah, I don't know.
Somebody have to check that out. I don't think it's much. I don't think that the
So just for reference,
3959. So radius. Hold on, real quick. Enter distance. I'm just going to do 2,000 miles. Length of chord is length of chord. Wait, what? Well, that can't be right. I put radius 3959. Enter distance 2,000. It says length of chord is 6833. Yeah, that's not. I don't know what I'm doing there. All right. Well, we can get past that one. I think that we could come back to that. I do think.
Let me see. Just if I can just one thing on that. That's Brian Leakey tried to do that. He tried to use, and the way he did it was he said at 89 degrees, the angle is this, and then he used that number as if it was consistent for flat geometry, but it's not. So that was one of the globe things that he used when he tried to do the challenge. So okay, what were you saying?
No, that's it. I mean, that's okay. So we got through our intros, and now we're going to the section of reply we kind of did. So we'll do the short topic discussion, 5 minutes each topic. And you go first. You name the topic, and I'll start the clock.
Uh,
We'll go from there.
is this where we come back around to what we talked about last time?
Oh, I thought okay. So we covered the first. I thought the first one was what we talked about.
No, we have no, the ISS height, the actual parallax measurements, the trigonometry of it.
Okay, go ahead. You want to do that one?
Yeah.
Okay.
So
You're
but
5 minutes. Go ahead.
okay, but did you review it? Oh, it sounds like you
Well, yeah. I
didn't.
mean, I reviewed it enough to say that I don't disagree with it. I mean, I saw the ISS or whatever it is go in front of the moon myself. I saw it go in front of the sun. And if you, I mean, I guess where I get confused is that we kind of arbitrarily, like if it works out, we use it. And if it doesn't, we don't. Because you can't do that same method to get the distance to the stars or the distance to the sun or the distance to the moon, correct?
Yeah, because we can't. Well, you can get the seriously parallax. People do parallax to stars. That's one of the ways of several that they measure the distance to stars. So yeah, you can get parallax distance to measure the distance to stars.
But they don't do that.
Yes, they do.
Who does?
Who does? The astronomers, when they're measuring the distances to stars.
Wait, you're talking about the parallax of using the baseline as being the orbit of the Earth?
Yes.
Okay, I'm more talking about when we're doing celestial navigation, we're basically triangulating.
Oh, well, hold on. The distance to the ISS was not celestial navigation.
Okay, but was it two people creating a baseline, creating a triangle, using triangles in the Pythagorean theorem to get up the distance?
Yeah. Which
Okay,
is not.
so-
There's no triangles in celestial navigation, so it's there's not really an analog to it.
Well, there is a triangle if you're talking about the angle of the GP is 90 degrees, correct? Always, right? That's a 90-degree angle. And then there's the angle of the star to you, which is just going to be the opposite of you to the star. Or
Yeah,
not the opposite,
but there's
90 minus.
but there's no triangles.
I just described a triangle, didn't I?
No. All right, hold on. I can. Can you make it so I can share?
I can.
I'll pull up the diagram because there are some books that are simplified, right? But this one doesn't. But there are some books that kind of get it wrong. I'll show you.
Where are we at here? Oh, it's on the wrong properties. You're not sharing it, I don't think, right?
No, not yet.
Okay, just make sure.
Did I get? Let's see. Is this the right one? There it is.
Okay, I think I got that. What?
All right. There is that, and then I need to change it on my screen so people can see it. All right, so are you seeing that?
Yes, it'll be on the screen in a second. But yes, we can see it.
Okay, so there you have the height of I, and then that line A at the top. The top line is the angle to the star, right?
Which line?
A, the one that's labeled A, the one at the very top.
Okay, got you.
And then the star is not on there yet, so I'll put that on there. So there is. Do you see the difference? I'll flip back and forth. Let's see.
Yeah, please, because I was not. Okay.
All right. So there's that line that's popping in and out. That's the GP of the star line.
Okay.
So you see line A and the GP to the star are parallel, or very, very nearly parallel. So where is the triangle in this? There's no triangle that's being used.
So that's the angle to the star, and then the line that you have there is going from the star to the center of the Earth?
Yeah.
Okay. And you're saying that the triangle would be, we can't really see it, but there would be a baseline that's the tangent, right?
Well, the tangent is that one there that says
Okay, so the tangent is the dot.
parallel to actual horizon. That's the one, not the dotted one. The
Okay,
one that's
same.
parallel to actual horizon. That's the tangent.
Why wouldn't it be the dotted one? It's just because you made an eye height of somebody who's taller than the ISS distance. But
it's not to scale.
Thank you.
So yeah, and then in reality, to scale, the dashed line and the non-dashed line would be so close that you couldn't see to scale.
Okay. When I'm saying 90 degrees is because if we drew a tangent where the line is coming from the star to the center of the Earth, that would be 90 degrees.
Yep.
Right. Okay. So I guess you're saying it's not a triangle. That's good because that's going to fix that issue that many people have. Yeah,
there's no triangle, and so some of the pictures that people have found, like have like this kind of simplified version of it where they're trying to show like from the observer to the star GP is some sort of a straight line, but it's not. So it's
right, it'd be curving. Okay.
Yeah, they're parallel. So it and I Jeran, thank you for at least trying to understand this and be honest about it, because you don't establish the shape of the Earth by misinterpreting and misapplying how somebody else is doing things.
No, and I think that I can just simply ask the question, because if the statement you can only do celestial navigation from a flat Earth was true, then that would mean that I could not envision a globe Earth that could use celestial navigation. You just told me that it only can be done on a flat Earth. However, I can envision a globe to where somebody could get their distance 3 times from 3 different stars, and you would be able to use trilateration, not triangulation, but trilateration to get your location. So I don't see a problem with that. I see many problems with the globe, but that's not one of them. So, and just to have people so staunch, I've had like 8 people message me saying like, "Oh, you didn't hang him when you had the chance. You didn't." I'm like, "About what?" And they're like, "Well, you did that observation of the ISS, and he was using a flat baseline, and like the one that was 0.6 miles away." I'm like, "Okay, well, let's look up the curve. I mean, you're talking 4 inches. So now we're saying that I should have called him out and hung his feet to the fire over 4 inches of distance. 4 inches of curve. It doesn't make sense to me."
Yeah.
So anyway, no, it's not a matter of, I just have an issue myself personally with that group, because I don't think, here's the problem. They can never admit they were wrong. That would be
it's
catastrophic.
It's their thing. It's their shtick.
Right. So they're always right, never wrong. And so, I know you know about that. Yourself kind of plays into that role a little bit. But for them,
come on.
But for them,
tough. You're so tough, Jeran.
I have a problem with other flat earthers doing that, because I don't think it's good for the collective, because what it does is it puts me in a position where I'm forced to believe something that's not true, and I don't see it being a good argument, or to state that I don't think it's a good argument and then have it be attacked by this group of other flat earthers because they're never wrong. And so that's why I say it's a little bit of a scam. And because if you're just going to sit on one thought and just say, "I'll never get off this thought," and you're wrong, well, then you're scamming people, because they'll never be able to see that you're scamming unless I point it out. So anyway, it's neither here nor there. Sometimes they do decent stuff over there. Sometimes they do atrocious work. So what are you going to do? What are you going to do? So we got through that one. So again, I'm not going to, now this is different because I wasn't talking about this. I was talking about for the ISS.
Yeah.
When they were getting the distance using triangulation, correct?
Parallax.
A parallax. Okay.
Parallax. So
is there triangles involved in parallax?
Yes.
Okay. So if they're able, there you go. Thank you. Is that good? So those people there that have this, you have this setup here, we cannot use the same setup to get the distance to the moon or the distance to the sun.
You could, but the precision is the challenge, right? Okay. Because the size of the base impacts the amount of how far away you can create a parallax that's measurable, dependent on your instruments. So if you could have infinite precision, then yeah, you could do that. But we're limited by the instruments that we have. So you could have somebody on either edge of the Earth, both, so one at day, dusk, and one at dawn, and measure parallax to the moon based on the stars behind it. And, if you could be accurate enough, you potentially could. Yeah.
Sure, but the moon's going to move in that time, and you're going to have a lot of issues with that. Doesn't seem like it would be a good way to get the answer.
Well, you just take a snapshot of it, right? So if you do them simultaneously, then
I thought you said one morning, one night.
no, one person is at dusk and one person is at
gotcha,
dawn.
Okay.
Yeah,
Sorry,
two
sorry.
people at the same time,
Gotcha.
able to see the moon simultaneously.
I've never seen anybody actually do that. I don't think they would come very close to the.
Yeah, and I mean, there's other ways to measure the distance to the moon, too.
Like what?
EME from ham radio. Ham radio operators do it. So.
Yeah, I have to see that one myself. All right, so my turn now. We'll go to another one. And what was the other item we had to cover?
The other item was all of the curved line stuff. I mean, we didn't. I gotta say, we didn't quite cover this because.
No, I couldn't. Let me make sure I didn't even check if my actual editor worked today. Yes, I did. We can come up. Oops, sorry about that. Let me get this over here. All right, so this is going to be a big one for. Oops, you can stop sharing if you want. There you go. Okay. This is a big one for me because I don't quite get it from your guys' perspective. So tell me this: if I can show a known horizontal line when compressed shows curvature, does that not negate anybody using any kind of a compressed image to show curvature? And if not, then I have arguments about that and we can work it out.
If you have a known straight, like in a photograph, you mean?
Yes.
So if you have a known straight edge in a photograph, you can use it as a reference next to something to see if that thing is curved or not. By looking at the distance between them. And the farther away they are, the less precision you have. So you want them very close to each other.
But we're talking about the horizon.
Yes. So within the photograph, you want to have them proximate, adjacent to each other within the photograph.
Yes, but the horizon is not a physical place, is it?
It's the edge of the sphere.
Oh, so the horizon that we do see is the edge of the sphere.
Yeah.
Okay. It's not an apparent position. It's not, the definition says apparent position.
Well, everything you see is apparent, right? Because it's what you see, but it's not a. You couldn't. I mean, you could be in a boat if it's on water. You could be in a boat at the horizon point for somebody else, or the horizon line for somebody else. So, in that sense, it is a location.
Okay, so let me show you. If we went to this, let me see what you think about this, and you tell me this picture here. Oops. No. Yeah, that'll work. Okay. So when we see boats that are suspended in air, what's going on there?
That is typically from refraction, some crazy refraction conditions. Sometimes it's ducting.
Refraction conditions that are causing boats to float in the air.
Well, they're not actually floating in the air. We know that, right?
They appear to be floating.
They appear to, yeah, because it's apparent.
Okay.
Yeah.
Okay. So what is the actual thing going on? What is the mechanism causing the boats to float as seen here?
It's refractive. It's complicated refractive conditions. And Andrew Thomas Young has some pretty good treatment of this on his website from, if you know him, from San Diego State University.
Yeah, I emailed him and I asked him what these boats were, and I said what I thought they were, and he agreed. So what I think that they are, what I know that they are, is that these boats are all on water. They all are sitting on water.
Yeah, nobody thinks they're actually floating in the air.
Okay, but do you think that line that we see is the horizon then, the edge of the sphere?
That one, yeah, it's messed up. It's all complicated.
So okay, so let's now erase this boat right here. Let's say it's not there. Well, now you're going to tell me that you're measuring the line that we see, comparing it to some straight edge, or you're doing some math, but it's not even the real horizon line. It's a what they call a false horizon.
Yeah.
Right. So that being said, why would you ever feel like you can measure anything against a horizon that's an apparent position? That could be a false horizon. How would you know?
Yeah, it's a good point. Especially if you're in conditions where it can be possible and is likely, right? So if you're at if it's a cloudless day, and I think you'll see right in those pictures there, a lot of them are cloudless, then you have more heating coming from the sun, heating the water, and then that water coming up and creating those conditions in the air.
Okay, so, and I don't even think that's I'm just
Yeah.
pointing
But
out that
at-
you see
at-
the horizon line move.
Sure. And at higher elevation, you're going to reduce those things.
Okay. Well,
But
I
hey,
still see, yeah.
if you know, I don't prefer looking at the horizon.
Okay, so
Right? There's definitely other better ways that we can establish the shape of the Earth. But
would you agree that
you know, all the time, you know what flat earthers ask for? Show me a picture of the curve of the horizon all the time. So for you
Well, I think
then,
you mean
Jeran,
measured
and
curve,
so
but-
for you, Jeran, you would not want a picture of the curve of the horizon. You would never ask for that. You would want something else, right? Because
yeah, I don't
you
think that the curve
distrust,
of the horizon is.
yeah, you distrust that. But
Well, it's not
many
distrusted. It's just I know what
many
it
flat
is.
earthers, you go on Facebook all day. Oh, where's the picture of the curve? They all want the left to right curve of the horizon, right?
Okay. Which doesn't even make sense to me. Left, right, curvature of the horizon. Because if you had a curve of the horizon, then if you started to turn, how would that circle complete?
The geometry is a little complicated, and sometimes people
Okay.
don't get that. But well, it's not that complicated.
Well, what makes more sense to me is that we are the radius of a circle. That's our view. That's
Yeah.
our.
Well, I can answer
line
your
of sight.
question though. I can answer your
Okay.
question. Okay. Take a hula hoop.
Right.
And put that hula hoop about neck high around you. Right?
Correct.
And then when you look at the edge of that hula hoop, the part in front of you is going to be higher than the parts to the side. They're going to be coming down. Right?
Right.
And if that hula hoop stays put and then you rotate 90 degrees, what's going to happen?
You'll see the same thing.
You see the same thing. And that's what you'll see on the surface of a curving Earth. Right?
Okay.
So,
And would
so,
you
the,
also see
so
the
you
same
would
thing
not...
on a
you
flat
would-
Earth?
No.
Well, yes. Why wouldn't you? If we can only see us, if you're saying no, then that would be the equivalent of saying I can see further in one direction than the other. Because if I can't, then I'm a radius of a circle, and therefore, no matter where I turn, I can always see the same distance, which means that view circle would be a circle. And if not, why not? I mean,
Yeah.
I'm
So
not saying anything difficult here.
so the hula hoop stops, right? There isn't any hula hoop past the edge of the hoop.
Correct.
But on a flat surface, it keeps going. And Robotham talked about this, and he was correct in this, that on a flat Earth, the horizon should rise to eye level.
Which
now,
does, well, I mean, it
he-
doesn't rise to eye level, but
he-
it does rise with you.
He thought that it was a disc. I mean, we've seen his map. It was an AE map.
Mhm.
And he was not an infinite planar, which is much more common now. But even if it's an infinite plane, then it should be zero dip of the horizon. If it's not, then it should be a tiny. It's like 0.001 degrees, depending on the direction you
Again, we
look.
just showed you where there's a lot of horizon dip going on over here that has nothing to do with the shape of the Earth, right? It's just a optical illusion. So to say, oh well, we would see
Oh,
no.
hold on. We didn't establish if that was a dip or not, right? The horizon might be there, and the boat might have been raised, or the horizon could have been raised or dipped, and the boat was where it was. Probably all of them are not where they actually are if there was no refraction.
When have
right?
we ever seen the water above your or raised?
Skunk Bay.
Okay, so again,
right?
moving.
Yeah.
Yeah, it's
Yeah,
all growth.
all right. Now, a lot of people in the audience might not know what we're talking about, right? There's
I could find it, yeah, but
it's not Skunk. What's that? It's not Skunk Bay.
It is Skunk Bay.
Skunk Bay. Okay, so Skunk
Makes sense.
Bay. It was there's a time lapse video where you can see the horizon moving up and down throughout the day.
Yeah, I meant like, so for instance, if these boats are floating, we never see water up that high.
You
Right.
just might, but you wouldn't know it because you wouldn't have the boat floating.
I think it would look a little bit weird if water was above your eye line from the beach. I think we would see like, oh, that's weird. Water's way up high. It looks like it's ramping up to the sky. But it doesn't do that, right?
Well, we aren't very good with our eyes at measuring eye level,
True.
right? You look out an airplane window and you're like, oh, does it? But when you actually measure it, no, it dips about 3 degrees or 3.5 degrees, depending on how high you are. So when you actually measure it. But people look out a plane window and they think that it's all the way, it's totally there. All right, yeah, there's Skunk Bay.
Right. So what I'm saying is we see videos of the boat floating like up here. It looks like it's up here, right?
Yeah.
But we never see water go up there and be like, whoa, that's weird. The whole water's being refracted up or loomed up or anything like that. But seems like everything.
Well, you can't say that because you don't have anything to compare to. Because the horizon is the only thing that we can compare to. So you don't know if the horizon has been up that far because you don't have anything to say, well, what else was it there?
I don't know if I've ever been to the beach and seen the water above my eyes. Right.
Okay. Did you measure it? That's what you'd want to do, right? To really do that, you'd want to measure that and say, well,
so right. So do you think anyone's ever measured the ocean water to be at 10 degrees off the horizon?
I've never seen it.
Right. Neither have I.
Yeah.
So.
And that's not 10 degrees. I mean, these boats are not 10 degrees.
Well, I mean, in all these cases, and you can go to, I mean, you trust Mick West, I take it?
He's pretty good.
Okay. So if you go to his Metabunk site, they've got a whole thread on this.
Yeah.
And they go through and they show how in every case the horizon is behind the boat, right? The horizon is in every case. It's not one that they didn't find and they even go as far as to show like people walking down, like here, I think it's this picture here. Well, it's a little bit further down, but you can see these people standing on this port walk. Well, you can't really see.
No, I can't see what you're doing.
Oh yeah, I'm not doing a very good job here. Let me go over this way. Well, we go this one, left side. So these people here, you can't see them, but they're standing right here. Their heads are like here, right? And so away.
I don't see anything. What you're talking about?
Hold on, let me transfer this over here.
I just see 4.
Oh, this is better. This is better. Here we go. So these people walking on. I mean, you can kind of guess
by
looking where he is, where the horizon should be. The horizon would not be down here.
Oh, because
how tall is it? What is this ramp to throw on?
Okay.
2,000 feet.
Yeah. Okay.
No.
So yeah. So if the photographer or if the camera's at the same height as that guy's eyes,
it's about that.
Yeah. Okay.
It's not too bad, but I mean, they go through and show. They go to like Google Earth and show where the person's standing, and in every case, it's always just. And it's funny because on every, here we go. Like here's a website telling us that it's a large ghost ship. They call this a Fata Morgana, which is not. A Fata Morgana is an upside down boat, reflection, mirage, if you will. And these are none of these are Fata Morganas, but they're all called that because this is how confused everybody is because of what science has done, is just destroyed real observations and telling people the real truth of what's going on. They don't want people to know that in these cases, it's because the horizon's being lowered. It's a false horizon, right? Here, the same thing. The water is back here, right? In every one of these cases. So anyway, to me, let's get back to the point. The point was, I don't think personally you can ever take a photograph of a horizon and then condense it and say it has curve, because we can take known items. So let me get one here we can look at. We can take known horizontal items and we can condense them and show curve. Remember you did it on your table that one time? You did it on a kitchen table and it showed your light above your table.
I have 34 pictures ready to go for this discussion.
And so before you show me the picture, I just want to know, you still stand behind that as evidence.
Behind what?
Behind
a left to right curving horizon, or a horizontally compressed.
Taking an image and horizontally compressing it. Let me ask you this.
Wait, so
do all images have distortion? Do all lenses have distortion?
Yeah, nothing in meat space is perfect.
Okay. So even though you're using a rectilinear lens or whatever the excuse might be, still going to be distortion.
It's not an excuse, but there is some distortion, and so you want to control for that. And there are ways to control for that. You can, one way that's kind of easy is you can take a photograph of a checkerboard.
Right.
Because there's lots of, lines, and you can see then if it's adding curves either way. So if you take a lens, photograph a checkerboard and see very small distortions, and then you take a photograph of something and it's curving, and the curve is more than the distortions that the lens adds, well, then you have controlled for the curve that's added by the lens.
Okay, I think I see what you're saying. So like in this image here, you're talking about this. So I took a picture today of like this, right? So let me get a little bigger here. Let's go here. Okay, so I took a picture of these.
This with
these
your phone?
Yeah.
Okay.
And you can use different cameras. I mean, I'm not saying
Yeah.
it's just, but and then if you, okay, and then if I look over here, how am I going to zoom in over there? Like that? Oh, yeah. And then over here is the corresponding lines. Okay. So you can see that we're seeing curvature in these lines, and there is none present. We know that. Okay. And then we can keep doing that. And I always get the same results. I never get well, let me put
okay.
this.
So let's look at the top one there. The top one. That's okay. I don't see a lot of curve there, but there's a little, right?
There's tiny.
Okay. So now
so that alone,
if you took a picture of something and it had more curve than that, then you would know that there is some curve. But if you took a picture of something and it had less curve than that, right, then it would potentially be curving the other direction.
Well, it's going to always be, there's pincushion distortion, there's barrel distortion.
Yeah, it's usually barrel distortion. That's the most common.
For me, I've kind of seen that it's kind of mostly pincushion, because the reason I say that is pincushion is like you pushed a pin into the middle of the screen, right? And when you do that, you would get the Earth curve on the bottom and you would get the U curve on the top.
GoPros are the opposite, and those are the ones that are most common in the high altitude.
Those are fisheye, right? Those are
no. Hold on. To be clear, and people say fisheye a lot. They're not fisheye. Fisheye is 180 degrees, and it's
widescreen, wide.
There you go. Yeah, it's wide, right? But even the P1000 has barrel distortion, not pincushion. It's not much, but there is a little.
So I just did different ones of these, same thing. I just was taking pictures of the screen and putting it up there, and sorry, moved you instead of this. Let's get you back over there. Sorry. Great. I was like, oh, there it goes. All right. So we have this one, same thing. So you have 37 pictures that you took, and they all conform perfectly to whatever you expect. Guess I'm kind of confused.
Oh no. It gives us a lot of different information.
Okay, so then why can't we say, this is the concession I'm looking for, why can't we say that, oh yeah, condensing images is never sufficient evidence? Because, and this is where I get baffled as to why this is so difficult. If I can show a horizontal line curve, meaning that a known horizontal line is then condensed and shows curve, at that point, we as a society, we as a group of people should say, oh, if horizontal lines can be shown to curve when condensed, then we can never use that as evidence, because anytime we say, hey, this line is curved, the response can always be, well, how do you know it wasn't horizontal? So I don't understand why we can't just as a group say, you're right, let's not use that anymore. It's not good evidence for the globe. It's not evidence that would ever be allowed the other way. We would never be able to allow, imagine if I could show an image, and in the image I said, look, this shows that the Earth is flat, and you said, well, wait a second, here's a sphere, and when I take a picture of it, I can get it to look flat too. So therefore, you can't say, what if I just kept arguing with you and saying, no, sometimes we can see, and you'd be like, no, Jeran, if you're taking an image and saying, look, it's flat, but I'm showing you I can take the same image of a globe and it's flat, then can't we not? And I would go, oh, you're right, we can't use that as evidence anymore, because you're able to show the opposite of it. It's like a
So I'll
okay.
I don't know. I said it before, but you need to control for that. And if you do control for that, then you can potentially use that. So what I did, so let me say what I did. The one that Tommy Gronwald did. Remember that one? Did you look at that one?
I think so. You're talking about the one that has the straight edge, or wait, which one is that? Actually, the one with the rocks table? No,
not the rock table. That was Rory.
Okay.
It's the other one that was so Rory was at 600 some feet up. Tommy Gronwald was not very high up. He was just a little bit above the water, and he had a straight edge. It was pretty wide straight edge, and What I did on that one was I actually counted the pixels between the straight edge and the horizon.
I remember that.
Yeah. And then I put it in a spreadsheet and I graphed it, and there was a
Okay,
curve.
but how do we
in the
know?
graph.
Did you check to make sure that the straight edge was level?
It doesn't need to be level, it just needs to be straight.
Okay, so what you're
So
saying there then is if you condense a straight
there was no
horizontal,
compression on that one though. I didn't do a horizontal compression. I just counted pixels and graphed it.
okay, you're talking about this image. Here, I'm taking it, right? This one.
Yes.
Okay, but couldn't I lower the right side of this even more? If we're not leveling it, then I can just lower the right side of the straight edge even more and show even more curve.
No, it wouldn't show curve, it would just show a line. If the horizon was straight instead of a curve, then lowering that side when you graph those distances between the horizon and the straight edge, it would not show a curve, it would show a straight line. So we went through this before, and so I have some pictures, and so maybe it'd be good for me to show.
So one more time, but just because right here I want to make one more point is if you were to take, so you're saying you didn't use this for condensing, so you don't agree we can condense this image and show anything.
You could.
What evidence would that be?
It would. There is, when you do it, there is some curve. It's very slight though.
Okay, but if a horizontal line shows curve, then we can't say that this shows curve.
A straight line. That's not a horizontal line. That's a straight line.
Yes, a straight line. I guess I'm confused as to why you think this is evidence of anything. Because I can go out and put this board and I could line the board up with the horizon and then say it's flat.
No, you couldn't.
Clearly
not if you counted pixels.
What do you mean? So see how this? What if I put a rock underneath this right here
and raised that edge? Yeah.
Then it would be perfectly even with the horizon.
No, there's a bulge in the middle.
What do you mean in the middle? The right side is higher than the middle.
Yeah, I mean Jeran, you're still mixing between, perfectly horizontal and straight, right? This is the test for straight or curve, not a test for perfectly horizontal or not perfectly horizontal.
Correct, but I know that if we take, for instance, if we zoom in here and we go to the uppermost corner right here, right? So this spot right here.
Yeah, you count those pixels.
It's 273 down, okay? So if we go over here and we go to 273 down, it's going to be nowhere near that. 273 down is here.
Yeah.
Okay. So that's 273 versus 273. So right away, I can tell you.
But that's not what I'm counting.
Okay, but I'm just saying, let's go to what I'm saying for a second. In this image, this is proof why you can't condense images. Because if I did condense this and it showed any kind of curve, it's because the item is higher on one side than it is the other. For instance, if it was the same, so for instance, if I were to draw a line right here, let's take this blue line and we draw a line here. We're going from this spot here and straight across, okay? If we take that line and go straight across, which is there. No, maybe there. I can't really tell where straight is. Wait, where's that? B 273 there. Okay, so I think it's right there. No, it still looks not straight. I'll use a box instead. Box is easier. At least we get a straight edge there. Okay, so we can go here, rectangle, and now we'll see that this line, because it's, oops, let me do this real quick. What are we doing here? We got to get rid of the outline. No, I just want an outline. Fill and outline, and then outline I want to be 1 pixel. Okay, and then we're going to go with a color blue. All right, so that's lined up with the top there.
Yep.
Now we can take it all the way across.
Yeah, and you'll find that it's diagonal. But remember, we're not testing for diagonal or we're not diagonal. We're testing for straight or curved.
Right. What I'm saying is that this known straight line is the only line that would ever maintain if I squish this. If I condense this now, we know that the blue line will remain the same. The blue line will be fine because it's a straight line that is on the, see, there's nowhere else it can go. But then
is that diagonal straight? Here,
which one? This one?
Is the diagonal, is the straight edge, is the whole thing in frame there?
Yep, that's the whole thing.
Okay. So now, I mean, it's compressed an awful lot, but is the...
You want to do less?
Brown? No, it's okay. Yeah, whatever. There you go.
Okay.
That's a little easier to see. Okay. So now that we know that in reality, the brown line is straight. Right?
Correct.
Because it's a straight edge. Assuming that it's not somehow
Okay.
you
Right.
know,
Right.
out of straight. And then
Correct.
we're testing by counting the pixels between the edge of the horizon and the edge of the board. So that blue box that you did, it doesn't factor into it. So we count those
okay, so I see
pixels.
what you're saying. So let's get past that. But then you're talking about, but what I'm saying is, why wouldn't you? You're saying we can check and see that this deviates, right? Because you counted the pixels here versus here. But what
Yeah.
if I put a rock under here?
Yep.
Right. Well, then it's going to raise this edge up, which is
Yep.
going to then eliminate any pixel change.
No.
What do you mean? If I raise this end up, then this end's going to be, this brown end's going to come up to maybe, I don't know, here-ish. Okay. So now the brown end comes up to there, then that means the whole thing is going to be the same height all the way across compared to the water. So it's just, to me, here's the thing, and I see this with Globers all the time, is that I understand that you're making observations, but you guys are going with the intent of improving curve. You try and claim that that's what flat earthers do. Even on your webpage, it says something like,
The anti-scientific method?
yeah, which is totally what you guys do.
Oh,
which is
come
weird.
on. You're,
Come on. I mean, it's like
I
blatant.
understand you. I understand you think we're doing that.
You don't ever see that with globe earthers. You're gonna actually claim that?
I understand that you think we're doing that, and I will say that many people have a tendency to want to do that.
Okay.
I saw on Facebook. You want to stop sharing for a second?
Yeah. I just think we should get to the point where we eliminate things that shouldn't be used as evidence anymore, and condensing of images is one of them. So is comparing anything to the horizon, because the horizon isn't a known spot, and even you guys don't claim it's the edge of the Earth. Or if it is, then why do we see?
Oh, I see.
Far?
It's the edge, but
it's the physical edge of the.
So Jeran, all right, can you then? I mean, I would be happy.
Tell me what's going on here then. If this is the physical edge of the Earth, then there's boats floating higher than the physical edge of the Earth. No,
I'm saying that that's a bad observation. I would never use that observation because there's too much refraction happening.
You wouldn't know. If the boat wasn't here, you would go out to the beach, you would see a horizon, you would say that's the edge of the Earth.
Well, if I ever do use a something like that, you can call me out on that. But if I'm the problem is that we're testing for curve.
Right, but we can't use the horizon since it's not an actual thing.
But are you saying that that type of refractive conditions will induce a curve when there's no curve there?
I'm saying that refractive conditions do all kinds of things.
Yeah, but are you saying that it will add a curve when there's no curve?
Am I saying it will add a curve when there's no?
Okay, then so
you mean when condensed?
I want. Jeran, I think if you want to say never should somebody use the left to right curve of the horizon, then you're going to have to go to all the flat earthers and you're going to have to tell them that's not what you're looking for, right? But like I said, I see it every day on Facebook. They're like, show me the curve of the horizon, and you show them, and
well, I mean,
but
my complaint to them would be that do they understand that we can only see in a circle? So I actually think
hey, you got to rally your troops behind your.
My thing
your
is
stuff
that
here,
I can't. Yeah,
I know you
can't.
can't. You can't. Yeah, you can't control them. I get it. You don't speak for them. I wouldn't expect you to.
So like this image here that's showing this boat. Oh, you can't see it. Sorry. They show a boat a mountain being lifted up in the sky. But we don't ever actually see that. I mean, you're going to claim like Canagoo is that. I mean, obviously that's what you have to claim. But they show all these, Fata Morgana. This is not a Fata Morgana. There's no upside down mountain here. These are just, so what do you say about things like this that are just wrong? I mean, you guys claim that science has figured all these things out, but every explanation of this anywhere is wrong. So, and Andrew Young admits it, and he says, that they've done a bad job teaching it. Yeah. They've done a bad job.
Just because something's wrong doesn't mean that you still can't
I'm not
use
using
evidence.
that as evidence of anything other than for the fact of, I do think that the reason that they have to be wrong about this is because the correct answer will lead people down a path they don't want people to go down. It's easier to say, oh, refract, because if things aren't being lifted up, then how do you explain things being seen too far? Like your explanation for Canigou has to be that it's being lifted up due to some sort of horizon, or due to some sort of refraction, or due to looming or super looming, and placed on the horizon for all to see, right? Is that what? Because you did a show one time, and it was like called "We Don't See Too Far." You actually challenge people to come on, and then you're like, "I'll prove that we don't see too far." And every time you just went to Walter Bislin's calculator and moved the dial up, and you call that science.
Yes, that is. And I sent you the page on refraction, right, on my website, mc2.net/refraction. And I sent you one specific thing, right? You actually read it. And Jeran, you know, I've sent that exact same thing to a whole bunch of people, and none read it but you. So, okay. So I appreciate that.
Let me ask you this real quick. Just real quick, I want to ask you this one thing. Do you think that I believe what I say?
Yeah. So I used to, I gave you crap. I thought you didn't believe what you said, but I do think that you believe what you say.
Okay. Because I get that most of the time from people that are, you know, he's just lying, he's making it up, and it's like ridiculous. Like, of all things to lie about and make up, like I would do the one that's going to get me hated and get me, you know, death threats and all that. It's just stupid. And then I do things like show a video of the ISS crossing the moon, and then everybody's like, oh, he took it down because it's like, why did I put it up? I mean, it's just like the things they say are just dumb. It's like, if I was trying to hide the fact that I saw the ISS, I just wouldn't post it.
Yeah. Like, you covered this last time. You don't have to, we don't have to go back to that.
Okay.
All right. So let me share what I did.
Ahead.
Okay.
Sure. Let me start so we're going to go on to your next one. This is your 5 minutes, and we will continue. Go ahead.
Okay.
And okay.
All right. Do you see what I'm sharing there?
Yes.
All right. So this is a line I made in Photoshop. It's diagonal. Right. And then I compressed it horizontally. It's not.
But you didn't take a photograph of it.
No, hold on. I'm building up to something. Don't get ahead of me here. All right.
Nobody's disputing that you can draw lines on it.
All right. So here's two lines. Are they both straight?
This has nothing to do with but we're talking about taking photos, not.
But hold on, I got photos, right. Man. Are they both straight?
Yes.
There's the compressed. Are they both straight?
No,
they're not. This is the same one, right? The top one is still straight. The bottom one has a little curve to it. Right. So
wait, that's not even photographs. That's just done in Paint.
This is just Photoshop. Yeah. So hold on. So
wow.
All right. No, Jeran, you had mentioned last time that you were gonna do it. You couldn't get your Paint program to work. You were saying that diagonal stuff, when you compress them, just in a Paint program will curve. So if it's diagonal.
No, if you take a photo of it,
dude. People, did you read? You should have read the comments.
I'll have to go back and check. But
yeah, because everybody's impression was that you thought that diagonal lines in a computer, when compressed horizontally, would get curved.
No, they would, because again, if it's a diagonal line that goes from pixel 25 to 29, then when you condense it, you're going to have the same ratio. It's still going to be a diagonal.
Yeah. All right. Well, here is the.
That is really weird. I wouldn't even expect that.
All right. Well.
Now you just.
This is my time to present. Come on, buddy.
Oh, sorry, my bad. Real quick, but doesn't this prove what I said right? You said, hold on, you just said that I thought that diagonal lines would curve, and you just showed that diagonal lines curve.
No. On this one. Or this one here. Which one is straight and which one is curved?
Oh, I don't know how I would know that.
You can't tell. When you compress it, you can tell which one's straight, which is curved.
Right. The bottom one was not straight. Okay.
Yeah. All right. Same with this. And of course this, because people talk about, well, it's not level. I've had people complain that Rory's stuff was not perfectly horizontal. Like, oh, that's fine, because straight edges remain straight when you compress them, and curved edges become more apparent. The curve just becomes more apparent.
That's incorrect. You're basing that off of images that you've drawn on a Paint program, not photographs.
Yeah.
Okay.
We're not there yet.
Okay, gotcha. Good.
All right, so that's just the review from last time. So all right, I'm people. I think that we have a better understanding. Jeran does not think that diagonal lines, when compressed within a Photoshop, straight diagonal lines will receive a curve. But definitely, if you read the comments, that was people's impression.
And I might have gotten it wrong. I might have said it wrong. But what I was trying to do is take a photograph, and then I was going to show that diagonal line curved. But I couldn't get the paint program to open, so I couldn't take a photo.
All
anyway.
Right. So I used a P1000.
Okay.
To take a photograph of that previous picture. Now,
okay.
For some reason, I think I screwed up the color stuff in the settings in the P1000. So that's a white screen, but it looks blue to me. Is it blue?
Yes, or purple.
Okay. So for some reason, the color cast is all goofy. So ignore that. But all right. So there is those same 3 lines, and that's the center of frame. And here it is with them compressed horizontally. Now 2 lines are straight and 1 line is curved in this, right? See that?
So it looks like but you're claiming that all 3 lines are
No, in reality, the top line and the bottom line are straight and the middle line is curved. Okay. So now that's with the P1000. And now
did you try to take pictures from above that or below it?
Hold on.
Okay.
What is that? That's below it.
Well, you're kind of angled up, but okay. I mean, you really, let's think that you're in a drone taking a picture of the horizon of the beach. You would be
So the point of this wasn't above or below, and I'll get to the above or below later because I did that as well. This is actually not above or below. This is meant to be about the same height. So I angled the camera up.
Okay.
So that we could test the curve that the lens adds to the bottom of the frame. Because if it's got barrel distortion, what are we going to see?
Yeah, it's barrel
We're going to see a U, kind of a U shape, right?
Correct.
So here is...
Right, so it's got barrel distortion.
And there you go. But you still see the upward curve on the middle one.
Correct.
Even though, and I don't know if I really see much curve added.
I don't think I do on the top one.
On top and bottom are straight in reality.
But the bottom's now definitely got a U bend to it.
So I don't know if it does.
Try put blocking. A straight edge to it.
Yeah, block that. Yeah, straight edge would help. Yeah.
It's slight.
See, if you block the top 2 so that your eye isn't fooled by the proximity to the curved line. I don't know if I see a curve there, but anyway, I know that the P1000. This is at the zoomed all the way out. It does add a little barrel distortion. It's not a lot, but it adds a little. All right, so then I did the same thing, top of frame, right here. Right, and then I compressed it right there. I'll zoom in all the way so that we can see it. There it is. So I would say that has probably enhanced the amount of curve that you see in the middle one there. And here is with center frame of the P1000, and here is top of frame of the P1000. So
okay.
I don't know. I don't see.
I don't see how we don't get to the point where we say that this is not conclusive of anything, and nor could it ever be, simply because we can take a known horizontal line and we can make it curved based on the angle of the photograph, based on the the angle looking down, based on the left right. If you've got the camera tilted, it's not perfectly straight, and you're tilted a little bit to the left, you would also introduce curve due to the distortion of the photograph. So to me, I just don't see
this is. You've seen the GoPros of the horizon at 120,000 feet where it's hugely distorted above the center frame. Right?
Okay.
This is above center frame, and it's not hugely distorted. The P1000 did okay and not making it drastically curved.
Is that the whole frame of your photograph, or is there more?
Yeah, right there. That's the photograph.
Close?
Let's see. Hold on. There it is. This is the top of frame. So here's the original. Here's the compressed.
Okay.
I mean, I think it did add a little, but it certainly wasn't a GoPro amount. But
No, but it's still.
But here's what we can do. Here's what we can
Okay.
do. We can say, well, we know that top line is straight, and we know that the bottom line is straight in reality. So we can just do a comparison between the top line and the middle line, and a comparison between the bottom line and the middle line. Because we know they're straight in reality, we can do things like we could count the pixels between them.
Okay.
And even if it added a little more distortion, that you could still count the pixels and say, all right, well, we can use that in as a control. So anyway, there's more though. So
even okay.
All right. So that was in my office here, in the kitchen. Now you'll see that the incredibly weird color cast, even though I'm colorblind. High center frame. All right. So mid center of frame. There it is. Okay. So there's my kitchen. Does that look red?
Yes.
It looks red. All right. So for some reason,
you have an infrared P1000.
Yeah, I have no idea why. All right. So I need to close some tabs here. Too many tabs. You know Red Pill Philosophy?
Yeah. Where's he been?
Him and his open tabs. I don't know. he built a house out of shipping containers and did video of it.
Does he still do shows on, like, I think he's on different Odyssey or Rumble or something?
I don't know. I never was a fan. All right.
I couldn't have guessed that.
So, but I do enjoy the open tabs myself. So, all right. So here is same one compressed, right? And I actually cropped so that I don't have to zoom in or anything. So that's the same picture compressed. So you can see, to our eyes at least, that's remains straight. Now this is at the same elevation. Right, and then these are just some requests from you. So then I did the same thing.
Yeah, but you took out the pictures, like the things on the ceiling, things everywhere else. Like if you took this whole picture and condensed it, we would see everything move around. We would see that straight edge at the bottom gets curved.
And that's why I did this one.
Okay.
So I tipped the camera down, so we have the known straight edge.
Okay.
In the top part of the frame, and then we can compress it like this, and oh look, there's a little curve.
Mm-hmm.
So this is top of frame. It added a little curve, and so now we'll do the same thing to mid bottom of frame right there. So I tipped the camera up so that the straight edge is in the middle of the frame. Then I compressed it, and you see a little bit of a U, not much, but there's a little bit of a U there.
Mm-hmm.
Right. So now you asked about what if you're above it or below it.
Yeah, I guess there's also other kinds of distortion that do different things at different parts of the image. So I've heard. So that's probably not necessarily true. It might be true with some cameras.
Okay.
But
all right. But you had some other thing you mentioned that you think light all just bends in certain ways. But you asked it earlier today. What about if I was below it and taking a picture up, or above it and taking a picture down?
Right.
Right. So I did all of that for you.
Correct. And you showed that
I haven't shown it yet.
The lines.
I haven't shown it yet.
Oh, what?
Yeah. So all right, low center
No, but
frame.
I'm saying, as of right now, could we
So-
come to the conclusion that known horizontal lines show curve when condensed?
When photographed.
Yes.
Now, whether it's condensed or not, the condensing just makes it more apparent to our eyes. You could put a straight edge against it and still verify that it's curved or not curved.
Say again, what?
You could put a straight edge against. Let me get this one here. All right, so this is near the top of the frame, and we compress it. There is a curve. With this here, you could in in Photoshop or whatever, you could draw a straight line across, and then you could compare that straight line without doing a compression. just compare that straight line, that known straight line that you just draw in Photoshop, and compare it to the straight edge, and see, did the lens add any curve? And you could definitely see it. But this is so that our eyes can see it. It's the only reason why we do this horizontal compression is so it's easy to see.
Yeah, I know, but there's no curve in that item.
Exactly. The lens added it.
Okay. So therefore, why can't we get to the point where we say, yeah, condensing images and using them as proof of curvature can no longer be allowed?
Because you can quantify how much curve it adds.
Okay, but that doesn't make a difference. That has never been the case. Nobody in the history of using condensed images has ever gone to the next step and said, oh, now we can compare the... No, everybody who uses it simply states, when we condense this horizon, it shows curve, therefore the Earth's curved. I can go show you Red's Rhetoric's tape. I can show you our video. I can show you Sean Hufford's video. I can show you Brenda talking about it. I can show you...
All right, but now, Jeran, if...
Michael Sartain.
If there was something next to this known straight edge that was curving more than this straight edge, what could we conclude from it?
I don't think much, because it's going to it changes based on where the item puts itself in the photo.
But if it's right next to, like directly adjacent to the straight edge, and there's more curve than the straight edge, what can we...
I guess I don't really understand the thought process here, because you would be able to see it. What good would taking an image do, or what good would condensing it do? For instance, you could just measure...
The point of compression, horizontal compression, is just to make it visible to the observer, just so that we can see it more easily. But okay, like I said,
you're telling me, you're telling me that there's a horizon behind this straight right here. Let's say there's a horizon of the ocean behind that straight edge right at the top. Yeah. We would be able to tell by looking at it whether the horizon stayed with that straight edge or not.
You could, yes. And if you could zoom in Photoshop and then, move left and right, and you could see. Images. Yeah. But when you're showing it in a video, or you make videos.
As long as you show the comparison.
There's the audience for the videos, and that's why with the Tommy Gronwald video, the Tommy Gronwald one, I measured it instead of doing a left to right compression. So. All right, I'm almost there though. I want to because you asked for this, and I want to give you this, because you said, well, what if you're looking? So
what I mean is, like, if you were to condense this image right now, that top shelf that has all those little dishes on there is going to show curve. The straight edge is going to show curve.
But it's in the center frame, or sorry, that's in the top of the frame. So like I did on these others, I took 3 pictures, and I compressed each of them. So I'll just go through it.
Yes, look.
All right, so this is low, center of frame, compressed. So same one, compressed, quite straight. And we've got low, bottom of frame right here. So I tipped the camera so that the straight edge is at the bottom of the frame. And there we see the same U compression, right? And then I'll show you low, top of frame, and then compressed. So we see the same bow to the top, right?
So go back one image. Okay. Oh, sorry. I just want to point something out. So if you were to do this entire image, not just the little section that you want to show us, if you actually took this whole image and condensed it, you could make no comparison by saying, oh, that straight edge on top is straight, and we can tell how much more the bottom curve, because I'll tell you, if you do it right now, if you condense that, you're going to get different curves for the bottom piece of wood, for the bench behind there, for the table.
And that's what I'm showing. That's what I'm showing. That's why, right? So there's that one, right? So we have different parts of the frame have different amounts of and directions of curve. Mm-hmm. So what you need to do though is you can use that as a control, because we know in reality that that's straight, and so if you use that and that known straight, and then you can compare it to something next to it in the photo, right? You wouldn't compare it to something in a different portion of the photo. This is above the center frame. So even better, you could use the top of the straight edge and the bottom of the straight edge, and then put something in the middle of it and say, all right, well, the top of the straight edge we know is straight in reality, and the bottom of the straight edge we know is straight in reality. So let's put something in the middle, and let's see how that compares to the known straight above and the known straight below. And we know that since it's adjacent to it in the frame, that the amount of added distortion is very similar. And and even more, if we put one above and one below, then we know that the middle part is getting an average of sorts of the amount of distortion above and the amount of distortion below.
Okay, I'm pretty sure you would see that already. You wouldn't need to condense. For instance, if you had a straight edge and you had the ocean behind it and the horizon, and you were able to take a picture of it, you would be able to see right away whether or not it conformed to the top and bottom of the straight edge. There would be no need to condense. You're saying, oh, it would show it more pronounced or whatever, but I just don't see that.
Yeah, well,
I just would never use this as evidence. As a glober, I would find this to be embarrassing that this is what we have to go to.
I would definitely. You like I said, you don't need to. You're the one that doesn't like this, and so rally the troops, or But as long as flat earthers are out there saying, "Show me the curve," then. Well,
then you're
going to show the curve
that aren't really curves.
But there's certainly better ways to do it. So all right, let me have just one more.
You rally the troops and say stop using this as evidence?
No, because like I said, we can control for it. But there's other ways.
Nobody's ever done that. But nobody's ever done that. So you're making something up now.
I did. I did with the Tommy Grunwald one.
Okay.
And Rory did by putting a straight edge above and below the horizon.
Wait, what? You mean the one with the rocks?
Yeah.
Okay.
So he did. I mean, we did that anyway. So I mean, here's the thing. You're asking for these things that
I'm not asking.
I'm glad to not use this for you. But let me finish. I just have these because this is your request. I did it just for you, Jeran.
I'm very
Jeran, out of it because I love you so much, Jeran. I did this for you.
Mm-hmm. Believable, yeah, believable.
I mean, I'm sitting in my kitchen last night. Doing these. Fortunately, my wife wasn't there saying, "What the crap are you doing?" She was already in bed. All right, so
tell you to go to you need to go to a mental hospital or something. I've heard some wives say that to people.
She's like those. I asked her, do you want to watch this video? She's like, no. Why do you those crazy flat earthers? Anyway, all right. So let me finish.
Oh no,
this is from above. I'll just show quickly the same thing. Straight edge is straight when it's in the middle of frame. We've got bottom of frame.
Not straight.
And compress, then there's a little bit of a U. And then when we do top of the frame and top of the frame compress, there's a bow. So to your question of whether or not
hold on, real quick. The bottom of that table. Hold on, the bottom of that table, is that the same curve that you see on the top of the straight edge?
The bottom of what table?
So the table. No, go back. You were just on the right one.
This.
There. Okay, so let's say the straight edge is the control.
Yes.
Now, how would you determine whether the table that it's sitting on, based on that bottom line, is straight or not, based on the curve that you see on the straight edge?
Well, one way would be to count pixels between them, for sure. Yeah.
Yes.
Thank you.
Yes.
What was that? Was that Alex Jones?
Yes. Yes.
What?
Yes.
What?
Yes. Oh, by the way, guys, if you send in super chats for questions, we'll answer those at the end.
What? Seriously, did you do that, or was it a super chat?
That was a super chat. That was the sound effect that comes on.
Oh, okay.
You've
only got one super chat so far?
I think.
Oh my gosh, the slackers.
Well, they're flat earthers. Come on.
Get your butt in gear, flat earthers.
Hey, for one time, I'm telling you, listen to McToon.
All right.
We asked Alex Jones what he thought about the globe too. I don't know if you know that, and he said it was all fake.
No, he didn't.
No, I'm just kidding. No, he believes. He believes Buzz Aldrin. So I mean, come on. What does that tell you?
All right. I think did I show them? All right. Anyway, my point is, I'll stop sharing.
Okay.
My point was, you had asked in the past, what if the camera's above versus below? Does it change anything? So I took all those for you. I'll send them to you. I don't think that whether the camera was above the straight edge or below the straight edge, I don't think that it made a difference.
Okay.
So
I can't really say that.
That went long. So anyway.
Yeah, it went a little long, but all right. We'll come back to that one. I mean, I really think that I'm shocked that we can't get to this point, but we'll go to the next one and we'll see, because if there's more of these,
I'll give you this, Jeran. For you, when I talk to you, I won't use
thank you
the curve of the horizon.
I'm so excited.
But
All
do
right.
you know who asks for the curve of the horizon?
You said flat earthers, yes, but I don't ask for that.
Do you know which flat earther? You are going to be speaking at a convention where he is also a speaker. I'll
Who's
just
that?
say that. I'll leave it as a riddle.
Oh, okay. I don't know who that is. Did I script the sound? No, we're still right. Okay. Let me go to whose turn is it? Yours
It's yours.
or mine? Okay. We'll go to the next one. So we did condensing images. So let me ask you this. If I'll set the clock 5 minutes. Do you remember, I don't know if you've ever seen the video I did where I clearly proved without any shadow of a doubt that SpaceX was able to change their live stream, something that you can't do, something that I can't do. It's actually physically impossible for you to do it. You cannot do a live stream at the end, realize, oops, I meant to put in this one scene. I didn't do it. Therefore, I'm going to put it in after the fact. You could delete your video, or let's say you leave it up. You could download your video. You could change it. Then you have to re-upload it. If you do that, you lose your likes, you lose your views, you lose everything. What you cannot do, which is impossible, is to change your live stream. So when I proved that SpaceX did, do you see a problem with letting some private space company do something on YouTube that no one else is allowed to do, which is effectively changing history?
Do I see a problem with that? All right, so I'll say I did not when I watched it. So what we're talking about is the first time that Falcon Heavy launched.
The test, right?
And when that first launched, I remember clearly when it's showing the view of the the camera on the actual rocket,
right,
pointing down, right? Both of them were the same camera. So somebody in the production didn't put, Rocket 1 on the left and Rocket 2 on the right. They put Rocket 1 and Rocket 1. I remember seeing that and thinking when it went out, I'm like, oh, somebody in production made a mistake. It happens. It's live video.
Right.
And then you said, and I hadn't watched the video again, but you said, oh, it's changed. And I said, I'll go look at that. So I got the video. I downloaded the original, or not the original. I downloaded the video that I could download on YouTube. Right. And then I looked at it, and you can actually see, you're correct, they add in Rocket 2 overlaid on top of Rocket 1, and it's not a perfect overlay.
No, but
they could have done a better job if they wanted.
Sure.
Right. I would have.
Well, I don't know how you
I would have wanted to be a
insert
little more. I would have wanted to be a little more OCD about it and say, okay, well, you were 4 pixels off here and 3 pixels off here, and you misdid the frame change by a few frames.
The reason I'm a little bit skeptical about you saying that it was just a mistake or whatever is because yes, they're both the same image, but they were 1 frame off. And then also, so they weren't synced. So to the observer, it kind of looked like, well, it kind of looks the same, it kind of doesn't. If you paused it, sometimes you would get lucky and it would be on the same scene. Sometimes you would pause it and it would be off one, meaning the next, right. And then the other thing is it's cropped different. There's more shown on the video on the left than there's on the right. Okay. So
and I mean, the video I'm sending out right now to my YouTube channel has 2 different croppings of you and me.
Sure. But it is admitted that if you wanted to go back and let's say there's a scene where you accidentally didn't put my picture on your screen, you could not, after the live stream is done, insert me on top of anything. There's not even a mechanism to do so.
Yeah, correct.
Okay.
Yeah. So do I see a problem with that? Well, YouTube can do whatever the hell they want because YouTube is an independent company.
So they can change live streams.
They say you don't get to do that, Jeran, and they say I don't get to do that. But if a friend of the guy that owns or runs Google calls up and says, hey, I'd like to change this, the guy who runs Google could say, I run Google, so I can say yes or no. So right. Should they be allowed to do that? I don't know. Maybe that's not a good precedent.
What do you mean maybe? What do you mean changing live stream? It's not like it says on there edited on. It's not like it says changed on this date. It literally says the exact same thing any video that's a live stream says.
Yeah. Now,
so I don't understand why we can't get to the point where you're like, oh, I'm not sure if that. This is like how I don't know, like how addicted you are to the globe that you're now able. You're like, oh well, it's okay if they change live streams.
Tell
It's
you what,
okay.
I'll do this. I can't believe they did that, Jeran. That's terrible. But I don't see how this helps you, though. Because two things.
It helps me
about
because
this.
why would I ever watch space footage again, looking for mistakes, looking for errors? Because now I realize that if there ever is any error in any kind of spacewalk and any kind of launch, they can adjust it after the fact, and it's their word against mine. Even if I have it downloaded, they could easily say, "No, he changed that. He edited that video and added it in."
Yeah. Well, I
Right, that's
guess
the problem.
I guess
You
you
can't
you
let
are
people-
free to not use anything from SpaceX when you are evaluating whether or not you want to hire SpaceX to launch a satellite for you.
True. I also think that it's a dangerous precedent because what it means is that YouTube has certain people that it allows to change live streams.
Yeah. But
And
now,
now
PhD Tony has a good point. Does YouTube claim to be a primary historical source?
sure. I think that
No, they
would
don't.
definitely. I would think definitely people think that if something is streamed live,
But does YouTube claim that?
does YouTube claim to be a historical source?
Primary
so if-
historical source.
well, if what about if I go to their rules and regulations and whatever, and it doesn't say anywhere, it says you cannot change live streams.
Because you can't.
It says yeah, I'm
But
talking to the users.
because the guy that's in charge of the company can at his discretion change the agreement with somebody else.
I mean, that's like you guys don't even think of like if this was going on and it was the opposite way, if they allowed flat earthers for whatever reasons, because we're friends with them to change our live streams, you would be up in, I mean, you would be so livid. But because it's your little space agencies, it's your little space toys and your
You know,
little
they
wars,
used to do that. You used to be able to do some post editing, right?
you can still, they say you can chop off the beginning or the end and
Yeah.
only until you have 100,000 views. SpaceX had
Okay.
millions
So all right, so they
And yet they
modified
did
the
that.
contract,
for just them.
which is completely within their purview. If YouTube says we are going to allow you to do that, then that's within their purview, right? If you
It's
own a
embarrassing that you would
website,
have a problem with that.
but Jared, if you own a website and you put something on that website and you had a terms of service with the people that use your website, and somebody came to you personally and said, "Hey, Jeran, I'd like to change something on there.
Right.
It's not the agreement that we agreed to, but will you make an exception?" You could choose to do that. It's your
Sure,
purview.
but
right?
I would have enough respect and enough knowledge about what we are basically facilitating that I would say to them, sure, we can do that, but if we do, I have to change the text to say edited, or I have to change the text to say, streamed live and edited or re-uploaded or whatever. You
Yeah,
can't just it can't be the same as every other live video.
Yeah. All
It
right.
can't
Well,
be, because if
certainly
we're going to allow space agencies to do that, then just think of how many mistakes they could
we
have made
aren't.
that they've covered
We
up.
aren't. You and I aren't. YouTube is.
Yeah, but the problem I'm saying is
there-
I'm not
YouTube
trying to
isn't
prove that
we.
you're faking. I'm not trying to prove you fake space.
Yeah.
So
Sorry. So, but
If
let
I'm-
me say the couple things here that
this
I
is,
think
like,
the
so
one big
bothersome to
thing.
me.
All right.
Because just there was everybody in the comments of that video. People were saying like, "Oh well, I don't see a problem with it. They just changed the record. They just corrected the record." It's like people are that stupid that they don't
All right.
realize that that's
All
a
right.
slippery slope. If you're
All
going to
right.
give
So-
anybody
all right.
permission to change live streams,
Let me
Crazy.
say this, Jay. Do you think that those rockets actually went to space? Do you think that was real video of those rockets?
I'm trying to remember that whole entire launch. I think that the ones that go up and come back could be real, but I don't think they're like what they say that they are. I mean, as far as like the weight and stuff, I think it's lighter. But I'm not sure that one. How high did it go? Do you remember? That wasn't the one with the car, right? That was the
The one with
flight.
the car. Yeah. And those were the boosters. The boosters don't
Wait, it was the
go
one with
as
the car.
high.
Wasn't the test flight?
Yep, the car was the test flight.
Oh, I thought that it was. Oh, yeah, it was the stuff. Okay. So do I
So-
think it was real? No, I don't. Certainly, I don't think there's a
Okay.
car in space.
So if you don't think that video is real,
Mhm.
but you do think that they made a mistake during the live presentation of it,
Again, what are we talking about? The car in space, or are we talking about the rockets landing?
well, the whole video, right?
Not
What-
the whole video.
What
It's all
what
not
part
one
of the
piece.
video do you think was faked, and what part of the video do you think was real?
Everything in space. There's no Tesla in space. There's no camera with a Starman. It doesn't even make sense. I mean, you've seen the problems with it, right? I mean, you can see through the wheel well. You can. I mean, it's a cardboard cutout. It's not even close to being.
No,
real.
I haven't seen any problems with it, but that's a different thing.
Have you ever looked?
I will, if you have done some analysis. I haven't looked at any analysis from flat earthers of that. No, but I'd be, if you have some, send it to me. I'll do it on. We can talk about it. I'll do it. We can talk about it at a future time.
Okay.
But so you must think that the video, at least that section of the video, was faked somehow. So what portions of that video were not live, and what portions of it were live?
And I've said in my video, I never claimed that what I'm saying claims SpaceX is faking space, anything like that. I happen to be looking for that, and what I found was that they can alter live streams, which is it's hugely
okay. But this is my point is, and I want to
Sure.
get your opinion on this.
Okay.
Do you think that the whole video that SpaceX sent to YouTube, do you think the whole thing was faked? And then they're like later, oh, oops, we accidentally faked the wrong portion of the booster. We need to fix the faking with a different faking. Is that what you think? Or is it something else? No. Okay.
No, I think something. I just think that they didn't like the fact that there was a couple things they didn't like. Number one, that they had the whole scene of the doors opening in space, and then spaceman, the whole song and everything. They had that at the wrong time, so they interjected it at the correct time.
What was it?
So they showed the part where the fairing opens.
Yes.
And the car is inside of it, and they played the song by Billy Joel, and the crowd goes crazy.
Well,
sorry.
All right. I'm not a fan of Billy Joel.
Okay.
And I'm not a fan of the actual.
I hate that song.
Crap. What's
Am I getting the name wrong?
It's not Billy Joel. All right, Billy Joel lovers. Billy Joel lovers. You can David Bowie.
Hate me.
Billy Joel lovers. Billy Joel lovers and David Bowie lovers.
David Bowie.
Sorry.
Thank you.
I'm sorry.
Yep.
I don't like either of them much, but I'll take Bowie over Joel any day. But anyway,
I think you're more guilty because you actually like rock and stuff like that. I don't like that kind of.
I like metal.
That's weird. That is weird. Oh boy, here we go.
Hold on. I saw this band this weekend, Deliverance. Super awesome. Love them. I got this CD from the singer from Deliverance, Jimmy P. Brown. The problem is
that is horrible music.
I bought this CD at the concert, and our vehicle doesn't even have a CD player. And it's on Spotify. I already had it.
Well,
but
you supported the band.
I supported the band. I bought their sticker. I also saw this band right here.
Oh boy.
I saw them live this weekend.
Tell us right now, do you have any guys' names tattooed on you?
No. Why?
Anywhere on your entire body, you have any men's names?
I have a pig named Kosher on me.
Okay. Just make sure you have no men's names tattooed on you. I think that's strange. Personally.
But my daughter put in an earring while we were on the vacation. What do you think?
Not a fan.
Not a fan. Oh, come on.
No,
Aren't you a child of the 80s?
No, I did have a tongue ring once, but that's gone.
Come on, you had a mullet. Tell me you had a mullet.
No, flat top, really weird flat top.
Did you wear a pink tux to the prom?
No, blue.
No.
Like electric counts. Blue.
That counts.
Yeah,
that counts.
It's like electric blue.
Did you have the little mustache that you worked on all summer?
No, I was pretty clean shaven through high school.
Oh my gosh.
No,
seriously, no earring, but you had a tongue ring.
Tongue ring, no earring, and
did you put black eye makeup on? I've not done that, but did you with the tongue ring, the black eye makeup's required?
No, it's not required. It might be, encouraged, but not required. Do you remember how long ago that test flight was? By the way, I can't.
2018?
So would that be 5 years ago? Starship Iridium, CRS. I'm just trying to find that. I don't know why. Did they take it down? I'd actually be happy if they did.
I'd be surprised if they took it down. How old are you, Jeran? Do you say? I mean, I don't.
43.
Okay. All right. So yeah, you weren't
Like
a child of the 80s that much, huh?
Yeah, I was born in '80s. I was
Yeah.
born in '80s.
Yes. Okay.
Why can't I find this?
So yeah, Professor Phil Bell is asking, "Is this real?" Yes. Here, I'll take it out. Hold on. Take it out. There it is.
Your daughter did that to you?
Well, it's been pierced for years, and I
Oh,
thought it was I thought it might have closed up, but I'm sitting there. We're on vacation. I'm sitting there on the chair, and she's messing with my ear. I'm like, "What are you doing?" And then she's like, "I just put an earring in." I'm like, "Oh, great."
why did YouTube make the change that now when we are on home or videos, it doesn't show live streams? That's why I couldn't find it.
There's a second tab.
So
They're
stupid.
not mingled anymore. I wish that I could have the choose which tab is the default tab.
Right. Let's put in a request. I think we should be able to.
They don't listen to me.
You would think that their views are down because of it.
Because of
I would
what?
think- Because of moving like live streams. Like if people actually have to go look for your latest live stream now. So I think people would find something.
Well,
else to
yeah,
watch.
they get notifications. They watch my live
Oh,
streams.
your guys get notifications?
No.
You get recommended? You get put
No.
up next?
No.
Oh, that's right. You guys
No,
do.
I don't. I get that same thing. That same underneath the video where it says Flat Earth, the Wikipedia page. I get the same thing as you do.
But if somebody searches for one of your videos, they could probably find it. You're not outlawed or what do you call it?
If they search for me,
Shadow banned. Sorry, I couldn't.
if they search for me, they find it. But if they type in Flat Earth, they don't find me.
Right. I don't even think they find me when they search.
Well, if they type Jeran, I just did it today. I typed Jeran, I found you.
I don't know. You typed in like Jeran or Jeranism? What did you type in?
Jeran. Right to your
Jeran.
page. Right to your. Yeah.
Oh, and sorry, I saw some other videos about me. I don't watch on purpose. Yeah, I mean, there's videos you can type in the exact title of the video, it won't come up.
I've never seen that. I do that pretty often. Yeah, so like if I'm making a video and I will document, I keep notes and I'll put in notes. I'll put the name of the video and sometimes the URL of the video and then like some part of it that I'm at, like at 13 minutes and 42 seconds, there's something. I'll just copy paste the title of the video, go to the YouTube search bar, paste it in, and there it is. And I watch a lot of Flat Earth videos, Jared. It's most of what I watch.
Good for you. Okay. So I found it, by the way. All right. So this is the SpaceX one. Now I lost it. Because
So
Nathan anyway,
Cook,
that scene.
Nathan Cook said, I typed Jeran, Witsit, Leo, Dearth, found them all, but he spelled Dearth right. What if he spelled Dearth the way we pronounce it? Go test that, people.
You know what somebody did? It's very brilliant. Is that because on the Flat Earth, Sun, Moon, and Zodiac Clock app, by the way, get that, download that today. If you
don't,
you can be a refer, and you get a referral code, right? Well, somebody went in and made their referral name DIRTH.
Oh, good idea.
And they were like number 3 because of people using the cheater one. It's pretty smart. Pretty smart. All right. So here's the Falcon Heavy test flight, which is now 34 minutes, not as it originally was, like 30. Whoops. Yeah, that's the speed. Okay. So what I'm talking about is that now in this video, when you get to this part, let me see where it launches. There it goes. And right there. So this part right here has been added. So originally in the video, so watch how perfect this is. It's going to cut to the fairing open. The car's there in space. There's music. The crowd's going crazy. This is a beautiful video. Watch.
Category of side engines. $1 also would be.
Okay. So you're saying this was in a different...
Okay. So that was not in the original video. It was accidentally shown way at the end. It was very awkward. It was like, why did you show the fairing open at the end of the video? So they took that somehow and plugged it in. And if you watch the original video has nothing exciting going on at the time. It has all of a sudden just the crowd's going crazy, but it shows a little animation on the screen.
So
It's just a
all right, so I found when I was talking with you about it, I found somebody else that had live restreamed it, so that one wasn't edited, right? So I downloaded that, but I didn't find this discrepancy.
What do you mean? You didn't find this description? I don't know what you mean by that. Of course.
Well,
there's-
you didn't. I don't know if you mentioned this particular part being in the wrong spot.
Okay. Well,
So-
the video that I have is like the three reasons three things that proves that they changed their live stream. So there was three different elements. The other thing was that they SpaceX changed live stream. And here's what I'm talking about. It's like I won't be able to find my own video. I mean, it's just not going to come up. I have to, again, even though that is the name of it, it's like SpaceX changed history, or I forgot what the name of it is, but I can just go to my channel and find
Yeah,
it.
do the exact
Let me find the
title.
name of it. Yes, I will do that.
And sometimes it helps if you put it in quotes.
Okay. Let me get this off real quick so we can get your face off there twice. Nobody wants to see you twice. Believe me.
No kidding. Hey, Siggy Sigwald, thank you very much. You know,
What is
Siggy
it?
Sigwald gifted 50 memberships. And so then
50?
and so then I have to go and like I have well, it's not going now, but a scroll that goes on the bottom where my outro has all the members and patrons, and I update that to say, and if he gifts 50 of them, then I have to go like I do it like once a month usually, but if he does 50, then I have to do it like right away. And then do you know Gary Wybenga?
Mm-hmm.
He gets a membership, and a few flat earthers get memberships because they come in the chat, they talk every once in a while. So
He's giving away Flat Earth memberships to you.
well,
Or
memberships
to your channel
and,
to Flat Earthers.
and because the flat earthers are active, right? And there are a few that are often in there, and you know, we're like, hey, how you doing, buddy? Yeah. So Gary, the last time I did it, Gary had a membership. So,
Okay, so here's this one here. So I'm going to go to this video, open this link. All right, so this is the YouTube video. And we're
How to
gonna go
edit
over
a
here.
live stream archive video.
I'm sorry.
You can trim out parts of your video and enhancements and keep the same URL.
So this is just me explaining what they
But
can and can't do. That
SpaceX.
just me yelling about it.
he already
Or
did
is this-
that today.
I did.
Yeah, just with me right now.
Oh well, I get pissed
Right.
because that to me that does not make any sense. That is
But-
not.
And people in my chat are wondering what does this have to do with the shape of the earth?
So if this is the problem, is that people like that, I mean, literally bother me more than anything. If you can't, as a human being, see the problem that I'm pointing out, the problem that nobody else has ever caught anybody doing. I'm the only one who's caught anybody doing it. And they don't have a problem with it. They're like, man, what's a big deal? So if it was anybody else, if like the news, if we found out CNN was able to put out a live telecast and then the next day they just go in and correct a few things, oh, we'll fix this, and it still said streamed live on YouTube, people would be furious. But because it's Elon Musk and little space cucks love space for whatever reason, they can't get over it. They're like, oh no, what's the big deal? I don't see any problem with that. I mean, it's really bad.
But how does this relate to the
Because
shape of
if
the
we're
earth?
telling you that space is being faked, and now we find out that the only person that in the history of YouTube to change a live stream is a space agency, not even a governmental one, a private one, how is that not a big deal? Then you don't understand the argument. You don't understand the problem between flat Earth and globe Earth. You don't get it. People don't get it. Then they're just completely clueless. I mean, that's so embarrassing to as a human. It shows
But does it change the shape of the earth?
if they're lying about space, they're faking space, and they're able to change live streams, and it might have a huge deal to do with it.
But what part of it? This didn't have anything to do with the video
Wow,
from
you're
space,
really, like-
right?
Say again?
It didn't change the actual video from space, right? The portion of it
they're
that was
making it so you're allowing SpaceX to make basically a movie and call it a live stream, and you're so in bed with them, you're so in love with the idea of space. Look at behind you, that you're like, I'll let them get away with it.
Dude, I do that just to trigger people.
Well, you trigger
You
me.
know that.
So, well,
Dude,
what
don't-
triggers
don't
me more
trigger-
is that you can't be a
Jaron,
human being.
don't let me get to you. We're not like that,
Well,
Jaron. You
it's
and me,
actually
we're not
more-
like that.
your chat and you, if I can't, if I don't feel like you guys are on the same team, like,
Well, I mean,
human
yeah, we're not
beings.
on the same team.
Well, I
You're
believe
on
that we're all
team.
human beings.
You're on team
I believe-
flat. We're on team globe.
sure, but I believe we're all human beings. So to me,
All right,
if
we're
you-
all
if-
yes, we're all on team human.
Okay, well then,
Okay.
if a Glober brings up a point that it doesn't matter who it is, let's say it's Samuel Robotham, he's got a TV show or something, whatever, I don't know, and he is able to change his live stream, something that nobody else has done. If Globers came and said, "Hey, time out. How come a flat earther is the only one that's been able to ever in history change our live stream?" I would, as a human being, said that's a problem. That's a problem. They should not be allowed to do that. You guys can't even say that. That's how in bed you. That's how in love you are with space. That you guys are
I
able to
don't-
throw your morals away. Your
I
morals are just gone.
But Jeran, I don't see this directly as a moral thing because YouTube
What
doesn't
do you
make
mean
it.
changing their?
YouTube
So
doesn't
you
have
no
a
longer-
commitment. But
Okay, then
YouTube
no
doesn't have
longer
that
can you-
commitment. They don't have that as some sort of a moral.
Yes, they do. Look
imperative.
at this. You're like, oh, they don't have anything. If you change your fucking comment, McToon, they put edited on it.
Yeah.
Oh, but a live stream, just no big deal. It's just a live stream, no big deal. They just changed it. I mean, you don't even get it. They make you put edited on your comment, but they don't make you say edited on a live stream. Give me a break. You guys are like it's embarrassing. It's embarrassing.
So now the other thing you did say is that they're the only ones in history to ever do it, and we don't know that. Right?
Well,
They're the only one that you know.
that's ever been found.
Yeah.
I've never seen another video claiming that somebody on YouTube is able to change their live stream and keep it up saying live stream date or whatever. Never seen that. And if you look here, here's the Falcon Heavy launch.
Just Jeran, it's
32 million views.
It's the actual
Right.
the actual true Black Swan argument. Just because you haven't seen it doesn't mean it doesn't exist. Right?
I didn't say it didn't exist. I said I'm the only one who's ever pointed it out about any channel
Yeah.
on YouTube.
Yeah.
Okay.
So
Well,
there could be
right.
others.
I don't know
We
that.
just don't know.
Could be others. Sure. But
Right.
again, here's the thing. It says here streamed live on February 6th, but it was streamed live, but then it was edited after. And
Yeah.
that's never been shown on anybody else. Nobody else can do that.
Yeah.
There's not even a mechanism. I know your mechanism, you say that they're friends. So I guess Elon Musk has special abilities because he runs a space agency that he's able to change live stream and they don't even have to say it's been changed. Like,
Yep.
The fact that,
All right.
yeah, you're okay with that. I mean, if it was anybody that
I
you were
would I would have preferred that they left it as is. How about
I
that?
would hope so.
Yeah.
I mean, why not just tell them like, oh, I'm sorry, that's how live streams work. How hard?
So now, all right. So Peachy Tony's asking a question, and I know I know you have.
Okay.
He said, did you ask YouTube about it?
I did,
know-
and it
I
went
know
back
you
and forth in emails forever and ever, and then they eventually just said, "Sorry, we don't have an answer for you." Because originally, what they told me, McToon, was when I told them what happened, they said, "Oh no, that didn't happen. That's impossible." I said, "That's the point of this email." So I said, "So now that we've come to the conclusion that it's impossible to do, now I'm going to show you a video. Now I'm going to show you the edited video. They both say stream live. Now tell me what happened." "Oh, we'll get back to you. We got to talk to somebody else." Somebody else emails me. "Oh, I'm confused what you're saying." And then eventually they just say, "You know what? We don't have an answer for you."
Yeah.
That was the final answer. So, I mean, again, if people don't have a problem with that, then this is why I don't associate with those people or care that they like me or dislike me, because to me, it's like they're not even on the same team as humans. If you can't see the implications of what I found, then to me, you're just,
But
and I already know that.
But I have to say, Jared, all right. Let's put on the I can't believe that they did it hat. I'll put that on for this conversation.
Okay.
Okay. How does that change the shape of the Earth? How does that affect
if
whether or
space
not the Earth is a
agencies are-
sphere?
Because space agencies might be faking space.
Okay, but Jeran, we can measure the shape of the Earth without asking SpaceX, without asking YouTube, without going to NASA. All of those things we can do without.
How do we
them.
do that?
How do we measure the shape
let
of
me ask
the
you
Earth?
this. Let me ask you this. Do you believe that right now, this moment, that we are flying through space at 1.2 million miles per hour?
Okay, we're definitely moving through space. Yes.
You believe that?
I don't have a belief about it, Jeran.
Okay, so you know it.
I have the evidence and the measurements that people have done, and I've
we
reviewed
see
them.
the evidence?
And I'll say before I joined this conversation 5 years ago or whatever, I had not looked in depth to it. I have since, and the evidence is there. And so yes, the evidence says to me.
What is the evidence?
The evidence says to me that yes, we are in space. We're moving through space.
What does that evidence look like?
The evidence of aberration of starlight, the evidence of parallax of the positions of stars, the evidence of the change in the redshift of stars annual redshift of stars.
That's the evidence to tell you that we're moving 1.2 million miles per hour.
That is the evidence of orbit around the sun specifically.
So
Those three.
I
There's
asked about
others, but
1.2 million miles per hour.
Yeah. So around the galactic center.
I think 1.2 million miles per hour is around the great attractor.
Well, I can. The great attractor.
Or 80,000 miles per hour is the galaxy.
Okay, so the galaxy one I have reviewed several measurements of that. The great attractor one I have not looked at. So the great attractor one I could not say that I've personally looked at, but the others I have examined the evidence, and those things do.
But
There is evidence for it, and I've not seen contradictory evidence. I've not seen errors in their methodology or their anything. I haven't seen contradictory measurements either.
See if I can say this correctly now. So here's my problem with that. What you're calling numbers and math evidence that
No. Don't, Jeran, don't do that.
Okay, so tell me then if
actual measurements, actual people doing things like you did, right? You actually went out. You actually went out to that.
I went and did actual measurements.
Yes, you did. And so if somebody were to say to you, all you did was math, that'd be an insult, wouldn't it?
It would, because I was actually out there measuring.
You were actually out there measuring. So
who's
James
measured
Bradley
distance to the stars?
actually went out and measured the aberration of stars. He actually really did it. He spent
How did he
hours
measure
and
the
hours and
distance?
hours. What's that?
How did he measure the distance to the
He
stars?
measured the aberration of the stars. He didn't measure the distance to the stars.
Okay, well, you told me that you figured out speed. How would you figure out speed if we don't know the distance to the things that are
around the velocity of the Earth around the sun. And aberration is one of several. Yes.
Okay, and then from there they're going around the galaxy.
Yeah.
Supposedly.
Right. Different.
I just don't know what that evidence looks like. So that evidence to you is then the aberration of stars is proof that we move 1.2 million miles per hour through space.
No.
Okay, so I'm asking
aberration of stars is evidence that we orbit the sun.
Okay. Even though, if you're talking about aberration or you're talking about parallax, how do you know which one is moving?
Which one is moving?
If you're talking about the star could be moving and cause parallax, or we could be moving and cause parallax. Correct?
Yeah.
So how do you determine which one was true?
Well, because it can't be both, because parallax and aberration could not be both happening based on the star moving. Right? Because if you look at aberration, and I know you probably haven't looked at aberration. And
Wait, was aberration the same thing that was with Aries failure? The starlight coming in? Okay.
I mean, it's related. He was doing an aberration measurement, but no, that's not what James Bradley. Remember when I was mentioning that, and I sent you some pictures of the book that had the F or the S that looks like an F.
Mm-hmm.
Remember that? I was reading the paper from James Bradley.
Okay.
And he published that in 1727.
So in
That's why it had that.
1727, he was measuring the aberration of stars.
Yes.
Okay.
So the aberration of stars is
Explain how he did that.
Yeah. Okay. So, he had a telescope in a chimney in a house, right? And we talked about this when you actually have when you block the sun from the side during the daytime, you can actually see stars. Right. So in the chimney, and I don't know, I'm not saying that he necessarily was doing it during the day or not, but I know that he did a chimney, and I know that when you do that, you can see stars during the day. So he measured the aberration. So he was actually looking for parallax, and that's why aberration and parallax gets confused a lot, and I made that mistake myself.
Mm-hmm.
So he was looking for parallax, but he found aberration. He found this thing. He's like, what is this? And then after a bunch of analysis, he's like, oh, this is what's happening. So it changes it changes throughout the year. And what it is when you look at a star, its position changes a little bit. And actually, when you map out where its position is, it maps out an ellipse throughout the year. And so an ellipse is with
Mhm.
one foci as a circle, and when when they get farther apart, it smooshes it down, and when the foci are very far apart, it's just basically a line. So based
Correct.
on where the star is in the celestial sphere, so the latitude of the star in the celestial sphere changes whether it's a circle or how smushed the ellipse is. And that's because the light coming into us and the speed of the Earth have a relationship. Because light has a finite speed, and as we're moving, it comes in at an angle to our eyes. So the way that people often explain it is if you're in a rainstorm and the rain is coming straight down and you have an umbrella and you're not moving, it blocks the rain. But as soon as you start walking, your feet might get wet because the edge of the umbrella blocks the rain, but you've moved forward between when it blocked the rain and your legs get forward. And if you're running, same thing, like it hits you higher up. So then you need to tip the umbrella more and more the faster you go. And so aberration is the tipping of the umbrella.
Right.
And
But
so
if
the
we
faster you go, the more you have to tip.
But if we weren't able to determine what was moving, the rain or the person, certainly aberration of the rain would not tell
True.
us which one was.
True. Yeah. So it could
Okay.
be that you're standing still all the time and
Yes.
that the rain is changing whether there's wind or not. So in isolation, you can't know for sure which is which.
Okay.
But that's just one of multiple things. So then you add in something like stellar parallax, where you
Which
see
again, you wouldn't know if stars were moving. You would see the same parallax you would.
in isolation, if you had no other measurement that you took with it, then you could potentially make that conclusion. But when you take parallax and aberration together, then then there's no way that you can say, oh, it's the stars moving, because
Why not?
parallax and aberration doesn't work together. So
Right. So
I'll
each
put
one
it
could be a result.
I'll put it to whatever geocentrists or flat earthers to go and put together a way that aberration and parallax could work together. Then add in redshift, and there's an annual redshift.
Well, they say even that redshift may not be what they thought it was now. So
Well,
because redshift is redshift is because you would have to know, how do I explain it? You have to know what, like, the frequency of the light that leaves a star, right? You would have to know what that frequency is.
yeah, and people do,
How would you know what the frequency is leaving the star?
because of
We
the
don't see that
chemical
light.
because of the chemical reactions that are happening.
But we don't see that light. We see the light that gets to us.
Yeah, and the Fraunhofer lines though. So if you look at the Fraunhofer lines, certain compounds in nature emit light and block light at certain frequencies. So
Okay,
if you
but
look
we
at the
only see the light
Fraunhofer,
that's reached us.
let me finish. You
Okay.
look at the Fraunhofer lines and you say, oh, here's a particular pattern, and that pattern matches iron, and here's another pattern, and that pattern matches nickel, and here's another pattern, and it matches unobtainium, whatever it is, right? And you put those together and say, okay, well, that's what our sun does, or that's what this does when we burn it in a lab, or when we whatever. And you put those together, you say, okay, well, we look at this distant star and we see that same pattern, the totally same pattern, but it's shifted. So the pattern's the same, but it's shifted. So if we just move it, we measure that amount of shift, and we know, well, just because it shifted doesn't mean it's a whole different compound that was happening, because there's no known compound that does that. So we know that star, when it emitted the light, was not where we see it. It was actually at the same point that it would have to, because of physics.
But that's part of aberration or part of parallax?
That's redshift.
Okay.
And that's a different part of the redshift than what I'm talking about with the annular redshift.
Mhm.
So you kind of pulled me off to this other topic.
Sorry, I didn't mean to.
Okay. Anyway, so that's how we know about the redshift. So, but the annular redshift, as measured by Vogel and Schneier in 1887, and they wrote a book on it, and it's like a 300-page book, and they detailed all of the ways that they did it. The point, what they did measure was, they said, well, one part of the year when we look at a star here, we see a red shift by this amount. And 6 months later, we look at the same star and we see a redshift by a different amount, right? More or less at different portions of the year.
Correct.
And so when you're moving towards something, it's going to shift it one way. And when you're moving away from it, it's shifting another way. And so that's how they are able to measure that.
Right. But the star could be moving from away from you and closer to you. Well, I don't understand. You can just claim that it's us that's moving. You've got no evidence.
So hold on a second. Hold on. Because you certainly could propose that you could propose that we are not moving and that the star is moving away from us, and then 6 months later it's moving towards us, and then 6 months later it's moving away from us, and this is right. You could propose that. Go ahead, and then do the actual. Do what Feynman said. You have your hypothesis, and then you compare to reality, right? You compute the consequences of your hypothesis. I go ahead. You're not gonna, right? We know that, but just saying
because
it
I'm
could
not
be.
have any funding.
Just saying it could be doesn't actually isn't a refutation, or it's not really that valuable, right?
So if the government got here and the government pays a bunch of people to go out,
it has nothing to do with the government. Jeran, you could do it yourself.
I mean,
if you were motivated. Amateur astronomers do all sorts of stuff without the government paying them.
Measuring aberration and
sure.
Oh, okay.
Sure. So all right. So take those three things then, right? So in isolation, you could hypothesize in isolation that the stars are somehow moving away and towards us in some sort of.
I don't really need to hypothesize anything other than you're not proving what you're claiming.
Right. Well, hold on. Okay. Bring all three of those things together, right? When you bring those three things together, and you put together the hypothesis for could it be this, test it. Could it be this, test it. Could it be this, test it. Right? That's science, right? You have a hypothesis, you compare to observation and compare to reality. Have a hypothesis, compare to reality. You repeatedly do that, and which hypothesis works for those three and which hypotheses do not? Well, you will find that the hypotheses of Earth stationary, star moving, nobody has a hypothesis where that actually works, where you can test it. But if the hypothesis is Earth orbiting sun,
do you think if I asked Robert Genis, he would not have an answer for you?
I do not think he would have a good answer. No.
Okay.
I don't think he has an answer to that. I've not heard him talk about these three things. I'd love to hear his answer to that.
Because he obviously doesn't think we're moving, and he obviously has. I mean, I would have to ask him.
I don't know if he's addressed aberration, parallax, and redshift.
I think he's pretty deep into. Yeah, he's pretty deep into geocentrism. I'm pretty sure he's done it.
But now, just for reference, Jeran, it would not work if whatever answer he might have would not work for flat Earth. You'd have to come up with a different answer.
Why not?
You go get his answer. Try it.
Okay. Because I'm assuming he's going to be looking at stars. He's going to be taking, and he's going to say, this is why it doesn't. And it seems pretty easy to me that you could never determine, especially with relativity. Relativity is basically telling you the answer right in front of you. That you could never determine which item is really moving compared to another item. So you can't be able to. Can't determine
the motion is relative. So
right.
Yeah.
So whether the stars are moving or we're moving, you really can't determine that. But you're telling me that's your evidence that we're moving. So it's kind of weird.
No. What us to one star? Which is moving? Us to one star? No, us to one star and another star. Oh, and another, and thousands of stars. That's what we're talking about. So relative to the center of the galaxy, we're moving relative to the center of the galaxy. Relative to the sun and the solar system, we're definitely moving in relation to the sun and the solar system.
And is the sun moving?
Yes.
In space it moves.
Yes. And so that, let me see. I think I have.
So have you seen any of the articles talking about the possible problem with the Copernican principle, the cosmological principle, the possible problem with redshift, the possible problem with expanding universe? I mean, do you realize that this, because here's what you're going to be surprised at, is in the coming years, science has already cemented itself into a paradigm that they're going to have a hard time getting out of, which is going to result in the fact that we're not expanding Has to, because they've tried everything else. They're done. Now they're out of things to talk about. They're out of things to make up. And they're going to realize that dark matter is not real and dark energy is not real. And they're going to have to bring that all back.
Jeran, dark matter, dark energy, those are hypotheses. That's what
Correct.
they are right now.
But most people think
expansion
that
of the
they are-
universe is pretty well, to my understanding, pretty well established. But this is the thing about science: the door is always open for our understanding to be shown wrong, and to learn more and figure out better how things are actually working. That's always open. So
Right.
you know, the idea, we talked about it before, the idea of proof. There's no real true proof in reality, right? It's
not true proof.
because proof is the door shut. Nothing else can ever contradict it. We're done.
Right.
But
Which would mean you would know all forces and everything that was involved in all
so
parameters.
so
Yeah.
proof, no, but evidence, mountains of evidence that shows us something and not contradictory things. Okay, well that's a lot of stuff that supports one thing. So okay, well that's the current preferred one, but somebody else can show that it's wrong. Go ahead.
Okay. And I remember you saying something about in Dave Weiss's paper on your site where you were talking about the 10 to the 120. So what is your explanation for what Michio Kaku was talking about? You always say we're taking that out of context or something.
Yeah. All right. Let me see.
I just want to know what you think he's talking about.
All right. So I'll put, so if you look at my website, it's right at the top there because I was on a, I forgot, it was Strange Planet podcast, guy that had interviewed Dave and I said, hey, I can come on and I can address his points one by one. Anyway, so on my website, mc2.net, right at the top, I have my point by point claims refuted. So let's see. Oh, right there at the top. Okay, Michio Kaku says that, cosmology is off by 10 to the 200th. So Michio Kaku was, I'm just reading what I wrote here earlier.
Right.
Michio Kaku was not speaking of the entire field of cosmology. Michio was specifically speaking about quantum theory and the instant of the Big Bang, specifically the quantum vacuum energy and the cosmological constant. And
Cosmological constant is correct. So where'd you get the rest of it?
well, I have a link to I think the article is where I got it from.
So what's the cosmological constant?
I don't know right now.
No, I mean, do you know what it's
It's
lambda, right? Is what I don't know what they call. I think it's lambda, whatever the A letter is. It's an A without a cross on it. But I'm saying, do you know what the general idea behind it is?
No.
It's basically that the high percentage of the universe is dark matter, dark energy. That's
the cosmological constant is the idea that the majority of the universe is dark energy and dark matter.
Well, it's what Einstein put in. It was like a placeholder, right? It's a placeholder that Einstein had to put in, and then he took it out and then put it back in.
Okay.
So it's the counterbalance of gravity, isn't it? So
Do you mean the rate of expansion, the Hubble constant?
No, I'm still talking about the cosmological constant, which
Okay.
is, so what do they use that for? Let me see here. I have my notes somewhere. So it's the vacuum energy. It's closely. So it says in cosmology, the cosmological constant. I'm on Wikipedia, by the way. Alternative called Einstein's cosmological constant. It is the constant coefficient of a term that Albert Einstein temporarily added to his field equations of general relativity. He later removed it. Much later, it was revived and reinterpreted as the energy density of space, or vacuum energy, that arises in quantum mechanics. It is closely associated with the concept of dark energy. So Einstein originally introduced the constant, to counterbalance the effect of gravity and achieve a static universe, a notion that was accepted view at the time. His cosmological constant was abandoned after Edwin Hubble's confirmation that the universe was expanding. From the 1930s to 1990s, most physicists agreed with Einstein's choice of setting the cosmological constant to zero. That changed with the discovery in 1998 of the expansion of the universe is accelerating, implying that the cosmological constant may have a positive value. So the reason I bring that up is because they are now saying that that could be incorrect, right? That the cosmological constant could be totally wrong, and that's what he was talking about when he's talking about being off by 10 to the 120. He's saying that the estimate, right? So I'm just saying that.
So it was a hypothesis. So what we're talking about here is the leading edge of science, and so there's always a leading edge of science. There's always something we don't understand, and this is the we're trying to understand this field. So in '98, they're like, it looks like the universe is expanding, and there are certainly people that in '99 were like, I don't think so. Still, I think it's going to do the big bounce, or I think it's going to do this, or I think So that's the leading edge of science.
Right. I don't have a problem with that. My problem is that if you've got a problem as big as, so what they did is they looked at the distant galaxies and said, oh, those aren't moving the way that we think they should. Right. And so they said, there's got to be some sort of dark matter or dark energy that we can't see that's basically.
No, hold on. This wasn't Michio Kaku's 10 to the 200th. That wasn't dark. That wasn't dark matter. That wasn't galaxies rotating at a different rate. It's a very different topic.
Is 10 to the 120 is the cosmological constant.
Which is not related to the galactic. Not directly related to the galactic rotation.
It is. It just said that it's closely related to dark matter, which is what they claim.
It said it's closely related to dark energy, not dark matter.
Dark energy is what's expanding the
Yeah,
universe.
it's about the expansion of the universe, not the rotation of galaxies.
Okay, so I was saying that it may not be expanding because they say the cosmological constant has been a headache for cosmologists because predictions of its value made by particle physics differs from actual observations by 120 orders of magnitude.
Yeah.
Okay, the cosmological constant has therefore been described as the worst prediction in the history of physics.
Yeah, so we discovered that a hypothesis was falsified. That's part of science.
Okay, so the problem that I have with that is you guys are claiming, so you talked about Feynman earlier. What does Feynman say? He says if your observations don't match the
so that hypothesis was wrong.
Right, but it didn't match the predictions, and so they kept it.
Correct.
They talked about
that it was wrong.
Right, so you get rid of the theory.
No,
it's been the theory since 1990.
You don't get rid of all of it. You get rid of the part that's wrong. You don't just say, "Oh, let's just throw away all of physics because one thing in physics was wrong." No, you say, "All right, this hypothesis is something cosmological constant, something
120 orders of magnitude off.
Definitely
the worst prediction ever.
Definitely worded that very sloppily. And then you test it, you compare to observations, and say, "Oh, that was wrong. It was wrong by a large amount." Okay, our understanding of it was incorrect. Let's go back and use our new information to generate a new hypothesis to see.
Their new hypothesis was to put in 95% dark matter and 97% dark energy, and then call it a day.
No, they didn't call it a day.
Well, then that's what. Okay, so what I'm saying
is they did not call it a day.
But there's nowhere else that's allowed in science. Where else could I do that?
This is exactly how science is done. You make a hypothesis, you test it, you say, "Oh crap, that hypothesis was wrong. Let's go back and try to figure out it."
Jeran, what keeps the sun up in the sky in your flat Earth? And I said dark lift, and you're like, "What is that?" And I say, "Well, it's a placeholder for now. I'm not really sure." You'd be okay with that? That's what you guys have done. It's okay with you, but it's not okay with anyone. You see what I'm saying? It's the same thing.
Yeah, I mean, it is kind of an interesting point you make there, but I gotta say,
it's the same thing.
Dark lift.
It's the same. It's dark lift.
Are you serious? Do people say that?
Using.
I've never heard that. You got to do that.
I made that up.
Jeran, you gotta champion that. It's dark lift.
It is dark lift. No, but I mean, this is what you guys get away with, and then you're like, "Oh, that's science." No, science is not applying some name to something and being like, "Oh, we kind of figured it out."
Let me explain how a placeholder, a good example of a placeholder, right? All right, so neutrinos. So that they were examining the energy between interactions that was happening in nuclear reactions, in very and this energy is happening, this energy, and they do all this stuff. They're like, hold on a second. On the one side of the equation, there's this much energy, and on the other side of the equation, there's a different amount of energy. And what's the first law of thermodynamics?
Something in motion?
Nope. That's
you tell me. Oh, I thought you were talking about the laws of motion.
First law of thermodynamics. Can't. destroy or
You can't
create.
Yeah, right. Okay.
Right? You can't destroy or create energy. And so if you look at one side, you look at the other side, you say there's a discrepancy of the amount of energy. Something's got to be the cause of that, right? Maybe a whole bunch of stuff was in error and the measurements were wrong. Well, let's go check that. Okay, well, you check that and say, nope, we really worked on that, and it doesn't look like we made a mistake. So it looks like there's some energy that is missing in this. Well, now let's have a few different hypotheses about what it is. And then some guy says, well, what if there's a particle? Right? What if there's a particle that we haven't yet discovered, and it's in there? Like, okay, well, that's another hypothesis. So then they went and they started
Science
testing.
is now allowed to just say, like, what if there's another particle? Oh, that's a good hypothesis.
Absolutely. That's
All right.
a hypothesis. Feynman said a hypothesis can be a guess.
Right.
You just guess, right? Now that's not a very effective way
But I don't think
to
you
do a
guess
hypothesis.
by saying that something could be like, maybe there's a particle we've never found that's what's causing it.
Well, turns out that was correct. That was the correct guess.
Because they found the boson or something, or the
No,
muon?
they found the neutrino.
Okay.
So neutrinos then, after a time, were discovered, and in Fermilab in Illinois, in Batavia, Illinois. I was actually there a couple weeks ago. I tried to go into Fermilab, and they're like, "Oh, you have to have the license with the real ID," and I don't have that, so I couldn't go. I couldn't do it. I'm like, I'll do it next time. I'm gonna go. I want to go tour. Anyway, so at Fermilab, they had been sending a neutrino beam from Fermilab to a mine in northern Minnesota in the town of Sudan. And I toured the mine actually a couple years ago. My wife and I, we toured the mine in Sudan. They had already disassembled that particular experiment, and they were moving, and they moved it to South Dakota. And I don't think it's quite running yet, but anyway, this is neutrinos. They're doing research on neutrinos. So long ago, several years ago, they confirmed the hypothesis of neutrinos. So that was a great placeholder, and it really worked. But it wasn't a blind guess. It was, there is a reason why we think that there's a particle, because there's some energy missing. So for you to say it's dark lift, well, I don't know if, I mean, it certainly is a valid hypothesis, but I don't know if it was a well-educated hypothesis like the neutrino one.
I'm not claiming that it is. I'm not going to make that claim. I would never make a claim based on my
But you can make
placeholder.
You can make a hypothesis for it, though. It's totally valid to make a hypothesis.
Okay, that's good, because I do a lot of that, but I'm not going to make a claim about it. Whereas science has made the claim of dark energy, dark matter. They're not even calling it a hypothesis. They just basically inserted it. They tell us the percentage of the universe that has never been observed.
Let me read this from Siggy. Now, while we've been talking, Siggy gifted 2 more bunches of 50, so 150 memberships. Thank you very much.
Siggy, you can go to Cash App $Jeranism if you want to support.
Siggy says it's fairly simple. Scientists observe that the rate of expansion of the universe is off. So the hypothesis of dark energy. Then there are gravitational phenomena we can't explain in relation to the matter we can measure. This is for dark matter, right? Then the hypothesis of dark matter is formulated. There's strong evidence for both. It takes a picosecond of research in Google.
Wait. There's strong evidence for something that's never been observed?
Yeah. There's strong evidence, just like there was strong evidence for the neutrino. It had not yet been observed.
Well, the neutrino has mass, right? Dark energy, dark matter.
Probably.
Okay, I'm assuming. Well, it must. I would think.
Yeah. So the mass of the neutrino is not well measured at this point. It's
Imagine that.
Yeah. It doesn't interact with matter very frequently, so measuring its mass is a bigger challenge than measuring the mass of a proton, for example. So.
Okay. Anyway, just if people want to look up, if you look up universe not expanding, the first 20 articles are all and the European Space Agency. The universe might not be expanding.
Yeah.
Futurism. Scientist says universe expansion may be an illusion. Big think. Ask Ethan, the universe expansion accelerating or not? Expansion of the universe may not be what we thought. Okay. So anyway, it's just people
So these
all
are, yeah, so people are having different hypotheses. Awesome.
Sure, but you don't think that they've come across by telling people that the universe is expanding as if it was a fact? Well, that's a problem.
That's so the difference between what actual scientists do and what pop
I totally agree with that. Yes.
pop, somebody writing an article for a magazine who doesn't actually have the detailed understanding of it, put it on them. They're the ones.
Okay, but do you get that, like, enough of these things added together? So let's talk about like the what they call the axis of evil, right? Which is, science is calling it that. Why? Because when they look at the cosmic microwave background, it correlates with the Earth, which is not at all what should happen. They're very confused by it, so they call it the axis of evil, and they've moved on. Okay, so that's a problem.
What do you mean it correlates with the Earth?
The cosmic microwave background, the hot and cold regions, are directly lined up with the plane of orbit of the Earth, which is impossible. It means that we're the center, really, if you want to get down to it. But they couldn't explain it, so they could look up axis of evil.
Yeah.
Which is a hilarious name. I love when science does things like that. Oh, by the way, can you look up CERN's logo and tell me why that would be their logo? You're a Christian. Tell me, what would CERN's logo be that for?
Because they have several circular tubes where they interject things, but it's not 3 6s.
It's not?
No.
Wait. Oh my
It's
goodness,
not.
you're hilarious.
It's a backwards 9
What is going on?
and a 9 and a 6 and an A. It's 4, right? It's 2 circles and there's 4 lines. 1, 2, 3, 4 lines coming off of it. So it can't be 666.
What do you mean?
Yeah. There's how many lines are coming off of it? There's 2 circles, right?
I
2
see.
circles. And how many lines? How many straight lines coming off? 1, 2. It's
Okay, so
actually
tell
5.
me this though.
There's
Tell me
5 lines coming off of it, right?
Hey, tell me this though. If you were a scientist and this was the logo they proposed to you for CERN, would you not say, let's go with anything else?
Dude, there's no accounting for taste. But there, it's absolutely not 3 6s because there's 5 lines coming off of it, not 3 lines coming off of it. So you could say it's 6 9 A B 6 9.
It'd be the equivalent of you telling me that the Disney Store logo, you're like, oh, that's not 3 6s, when clearly it is. Like, there's no reason why Disney has to have 3 6s.
You see boogeymen on everywhere. Come on.
What do you mean? There's a 6, and a 6. So why would Disney? Now, if you say no, Jeran, that's not 666. Let me show you this. Yeah, well, I mean, again, if I'm Disney and anybody even points that out to me, like, hey, why do you have 3 6s in your logo? I would say, oh, let's change it. What do you mean?
They don't. There's not 3
Every
6s
single
in
logo.
there.
Look at 6 6 6.
It's a lowercase b. You could say it's a lowercase b if you really wanted to. Take out the vertical.
666 like
Right. Take out the vertical out of the D, and you have a B then.
Yeah, well, they're not going to just do 666.
But
like right
I mean, Jeran, you're not going to have an argument from me. I'm not a big fan of Disney.
Okay, well, the point of it is I'm saying,
but
these
I don't see
companies do
6s
that.
there. I see a scripty.
You may not see 6s there, but that's the point of the logo, is to hide it in there. So just letting.
So you say, Jeran,
Well, again,
but that's your presumption.
You've seen the word sex in Lion King and all the stuff that's there. Are we dreaming that up? They have I don't know where the picture is, but they have a store at Disneyland.
Jeran, I did a thing when I used to do multimedia. Before I worked where I am now, and we made a kiosk that we put in a mall, and in the mall, or in the kiosk, that they had like a map, and they had a whole bunch of other stuff, and we filled that kiosk with so many Easter eggs. If you on the map, if you touch on where my house was, right, which is a huge area, right, of course, and did a certain thing and then released, right, then the speaker would take the sound from World of Warcraft that said, "I can see my house." I had that in the kiosk, is sitting in the mall.
Okay.
That was an Easter egg, yeah.
All right. Well, anyway, there's a Disney store that's logo. Seriously, though, I just want to say this. There is a logo for the Disney store that is just the D, the I from the top of the I and the Y. So it's the 3 6s only.
But the top of the eye is a circle. It's not a 6 either.
So imagine this though. Imagine this, McKeown. Imagine this. I'm going to make a logo. I'm going to make a shorter logo of Disney. So I take this backwards 6, as you call it, a B.
Yeah.
I take this top of the I, and I
That's
take
just-
this Y, and I put those 3 together and call that a logo.
Okay.
You don't think that's weird?
I think somebody's
find
having
that.
some artistic creativity. Whatever.
Oh, that's real creative. I'm going to put the D and the dot from the I
But-
and the Y.
But now I have looked up. I was unaware of this
Yeah, sure.
until flat earthers started making a thing of it. The number of the beast is actually not 666. You know that?
I've heard 616, but
Yeah.
it's true.
It is, from what I've looked at, it is 616, and that's from earlier numbers, and that's because it's referring to Nero.
Yeah, I guess for me, because I'm not quite as religious, to me, I think this is all done on purpose to get people to be believers, believe it or not. It sounds crazy, but it's not their homage
What?
to.
You think Disney hid a 666 in their logo so that people will be Christians?
That's my opinion.
And
Because-
but Jeran, like all the other flat earthers are like, Disney put 666 in there because they worship Satan.
Oh, I think that they're evil. I think that they're money grubbing kind of. This is so weird to me that I can't find these logos. But anyway, I'm not going to look anymore. It's just the outside of the Disney store, like this picture here.
You know who's gonna have something to say to you about not finding it.
Who?
Mr. Mandela Effect is gonna have words with you.
Oh, I have to be careful about what I'm saying anyway, in case I slip. I don't want to say anything that's going to. I said, what did I say one time that got me in trouble? I forgot.
In case you
what did I
slip.
say? Joel
Dude,
Osteen's name.
What's his I don't know. I like him. What's his name?
Brian Staley?
Stavely, yeah. He's I like him. He's all right. I
He's a
mean,
good guy.
he's good. He's gonna be. You're gonna see him in October.
Yeah,
He'll
he's
be
gonna
there. He'll be there, won't he?
Are you coming?
Karen has not sent me an invite yet.
How dare her?
Hold on. Put me on screen. Yes.
Karen Lou's. Oh, sorry. Karen
Yes.
Lou's McToon's address quickly.
All right.
Go ahead.
Karen.
Is this your appeal?
Karen, send me the invite. I'll go. All that stuff where you were giving me the finger. All that. I don't. It's okay. I know we were just joking.
I don't
But
think
hey,
she was joking.
I'll come there. I'll give a talk. I'll do a debate. Whatever. It'll
Oh,
be
you're
a
gonna
good
present.
time. Whatever.
Oh, goodness.
You send the invite. I'll make it worth your time.
We really want him to come and present that all the good stuff he's been telling us today. Please, that we can condense images. It's really good for us, and it's not a big deal if people change live streams, all that good stuff. All right, I guess
Jared, I'll actually talk about the shape of the earth.
thank you for that. All right, you're next. Go.
Oh my gosh.
Where do you want to get to? We can go to question and answer if you want, real quick.
I think maybe it's time for that.
Okay, let's do it.
Um,
Let's go
I
to
had
question and answer.
just for I had a couple others. So,
We can do one more.
but we've been going for a while. So
Okay.
I think it's
So let's just go with question and answer. Just ask me a question and I'll do my best to answer it or tell you I don't know. And then I've got some for you.
all right.
And then we're going to do super chat. So if anybody has questions, make sure you
okay.
get
Oh,
those.
I have to think them up. Okay. Well, you have to start then.
Okay, I'll go first.
You already. I didn't know I was going to do this, so I have to.
Okay, so I know last time I talked, and I've talked about it many times, behind the curve, but I didn't have the email up from then. I just want to show you the email, and then I want you to tell me why people don't get it. So imagine you're out there and you're doing observations or whatever, and at the end of the movie, they show the one observation where I say, I can't see the light, lift it up. He lifts it up. I see it. I say, oh, interesting. And then the movie ends. Okay. Now, every Glober, that's all they can talk about is interesting. And they have to, oh, Jeran proved curve. Okay, joke. But here's the email from them, from the director of the movie, the head producer. And she says, first of all, I sincerely apologize for the delay. Is this on screen? Yeah. I sincerely apologize for the delay in responding to your email. It has been a busy week. Okay. Then she says, there were alignment attempts where the light was visible at both heights, 17 and 23. So right away, we saw the light at 17 and 23. And neither height, not 17 or 23. There was only one moment where the light appears to be visible at only one height at 23 feet. Okay, number one, at no point when I told him to put it above his head was it at 23 feet. If it's at 17 at your chest and you put it above your head, that's 2.5 feet. So it went to 19 and a half.
Yeah.
So what she's saying is completely untrue, but she's admitting here that there were observations that showed flat earth and observations that showed curve, and that we saw both. She went and reviewed the video and says you saw both. There were alignment attempts where the light was visible at both heights and neither height. There was only one moment where the light appears to be visible at only one height, 17 or 23 feet. Think about what she's saying. So when the light was visible at both heights, 17 and 23, what if I took that scene of the 17 feet, put it on my channel and said I proved the earth was flat? Because guess what? That's one observation where it's showing flat. Now, I'm not
Jared,
that dumb.
I don't. Why are you asking me? I mean, this. I get.
Because
I
you have
get
all
your
these
beef.
audience. Your
I get
entire
your beef with
audience
that.
thinks that I proved curve. Your entire audience. Your entire
Okay.
audience isn't even
So-
smart
so-
enough to realize
so-
that a movie, a hit.
All right,
piece
so
of
hold on,
movie is
hold on,
not
hold on.
evidence of anything.
Then let's do this. Rather than talk about how they didn't do what you wanted them to do. What I'm happy to actually talk about what you did see, right? So did you see through the hole when Enrique was holding the light at 17 feet? Did you see that?
Earlier in the night? Yes.
At any time?
Yes, as she says in
So-
the email. We saw alignment attempts that we saw 17
No,
and
no.
23.
But not as she says, as you were there, right?
Correct.
I don't know about her.
So the thing is for me is I don't remember a lot of it. Like I don't remember details because it was like a 5-hour thing and we were doing a lot of back and forth and nothing was ever shown to be conclusive. We would see it and then we would be like, okay, now do this. And then we'd lose it and we couldn't get it back. And then we'd say, okay, let's go to set 23. No matter what we did, we were seeing evidence of both. And really the reason I said interesting is because the 19 feet, and I was thinking it was more like 20. I was like, oh, interesting. Now we see it at the middle. Because what that essentially was halfway between 17 and 23. Okay. And so I was like, great. What does that do? Now we had observations after that. As I've said before, if that was really happened, then right after that, where was everybody coming around? Where was the retesting? Show it again, confirm it. Oh, I guess we proved curve. Like what do people think happened? Like we saw that and then we're just like, oh, erase that. Nobody, like there was people around. So everybody that was there knew what was going on. Everybody walked away saying nothing was proven. The guy never said anything. The director of the movie never said anything. Like, didn't you just prove curve? Shouldn't we talk? Nothing. Just added it to the end of the movie.
All right.
Okay,
That's,
so
that's
my
a lot.
my
That's a lot
thing
of
is-
question asking.
Well, it's not questioning. It's just pointing out that it's absurd.
But this was the part of the show where you asked me a question.
Okay, sorry. My question is.
It's all right. It's all right.
Well, my question is, do you think that I proved curve in that document?
Okay, so the one thing you can take that off the screen.
Yeah.
So I'll say this.
You really like to be on camera, don't you? You really like to be seen. You want me to make your square bigger or something? I can do
No.
that.
I mean,
Just wondering.
you and I are the same size on my screen. That's all. I just a screen where people are not talking, I think, is less interesting than a screen where people are talking. So all right, I only know what I have information for. So the information I have is from the movie, from the guy that commented. I forgot his name, but he commented again on my video that I put out a couple months ago.
Yeah, and I don't even know who that guy is, but can we even be sure that he was there, or he just said it?
Well, I don't know, and so
Right, okay.
so and I can go on that information, and I've asked you if you can confirm it, and you're a little fuzzy on the details. Okay, it was a couple years ago. So,
At this point, yeah, like 5.
what's the
6
guy's Briganon was? So he said he saw, he said it was a single board at 1.5 miles, and it was you at one end with the camera and no board, and Enrique at the other end at 3 miles with no board.
which makes no sense. You're talking about one board in the middle. You could show that
Yeah.
light to shine anywhere.
No, you can't. Oh, it's there's only one line that light could be on in order for you to see it in your
Wait a
camera.
second. If there's a panel in the middle of a 3-mile stretch, and you zoom the camera into that hole, There's a big area that you'd be able to
it's
do that.
it's very small. So and I did, and I don't. I mean, you said that you looked at my webpage, but I don't think you did.
No, I didn't because
Okay. All right. So
'cause I thought you had the setup wrong.
okay. So if I got it wrong, then you were the one that was in charge of the experiment. You were the one that should have more details
Yeah.
than anybody
Well,
else.
except for the
You
fact
tell
that
me
the original experiment was way different.
Okay,
Right.
I'm not talking about the original. I'm only talking about the what we saw in the movie, right?
Right.
So,
Which was very small. It was just observations on a secondary experiment, and we
Does-
saw all the different observations. Nothing was proven.
to me, it's the primary experiment. It's the only one I saw. I didn't see
Okay.
any other experiments,
Right.
so that's the only
I'm
one I
telling
can.
you-
That's the only experiment that I can address.
Okay.
So, this is. I mean, if this would take a whole show.
Okay.
To go over the math.
We can
of
do that
this.
separate
So,
because I do think it's a good
I think
idea
we should.
to do
I
that
think we should.
experiment. Do you think it's the good experiment?
I think it's. I
Sorry,
think
not
it's
the one that
okay.
we did. Not the one that we did. The one with the laser.
Oh, the one with the laser. I don't know enough details about it actually. So.
Well, the original plan was to have three, well, really four boards, three and then a backboard, and then
Oh yeah,
basically
and then
thread
shine
the
a
needle
laser.
with the laser.
Yeah.
Right.
I think that would potentially be an okay one as well. Yeah, I think
Yeah,
that
because
could be
otherwise,
done
what
well.
you'd have to believe if it, let's say it hit 17 feet or whatever the was decided be that if it did hit that, the only explanation from a globe earther would be that refraction is somehow bending it perfectly through every hole, which would be very, very weird. But from a flat earther's perspective, if the thing is hitting at 28 feet, it's just no that I can see feasible answer.
So I think the way you could do it with multiple boards, with
Mhm.
multiple holes, is you start at one end with the laser and you shine it. You know, you as much as you can, you send it horizontal,
Mhm.
right? And then it hits a board, and then you move that board up or down until it goes through the hole.
Mhm.
And then it hits the next board, and you move that up and down until it goes through the hole. And it hits the
Mhm.
next board, and you move that up and down until it moves through the hole, right? And then you have that line of holes, and you can measure the elevation above your water, right? Because you're using not a stream, like a what was
Canal.
it? A canal, yeah. So you're using the canal as your level measurement, which is fine, right? Level on a globe is a curved surface, and level on flat Earth is a flat surface,
Mhm.
right? And so that's the whole question. When everybody's like, "Water finds its level," like, yeah, but the question is, what is level? Just saying it finds its level doesn't actually change anything. We need to know what level actually is, right?
Okay.
It's been measured. It's a curve, but
And they measured the oceans, everybody, just
well, they have, but
they've never
That's-
measured
that's-
the oceans. How would you measure the ocean?
how would you? There's buoys that are measuring the height changes of the ocean all the time.
Yeah, how does that measure the curvature of the ocean?
Because it uses GPS. GPS uses
There we
WGS84, all that stuff. Anyway, that means you said nobody measured it. Somebody has measured it. You don't like the way the methodology, but people have. So that's
I've never
the
even
point.
seen them claim to measure the ocean. So, not the curvature of the
I
Earth.
I just gave it to you. If you're interested, I can help you. We can look it up together. But anyway,
assigning GPS to things and then saying you're measuring from GPS is not really measuring. But anyway,
of course it is, man.
so
Does
if the
GPS
distance between,
does GPS work?
what do you mean? Does it get you places?
Does it get your accurate location and your accurate elevation?
It gives you your location on the globe.
Okay, perfect.
Yep.
All right. So that's a fine way to do it. So did the producers do you wrong?
Well, that's clear. They
I
promised me footage they never gave
I
me.
think
They
yeah,
were
I think you're not gonna But you bring it up all the time, Jeran, and I know.
No, I actually
I'm
don't bring
like-
it up all the time. This is the problem: is that I stop bringing it up. I want to get away from it, right? But then everybody
Okay.
says you're trying to get away from it, so then I have to go back to it. My thing is that it should be a no-brainer to a globe earther who always cares about all this evidence. They want to know what's the refraction index. They want to know what's the temperature gradient. They want to know all these things until I say the word interesting, at which point that becomes enough evidence for them. That it just really exposes globe earth for what it is. It's you write on
No.
your website something about
Jeran, I think and I get it because I mean you're the subject of this, and it hits your emotions right in the middle, right? I get that.
Well, I guess it hits me because it's, one of those things where I'm actually out there trying to do something and
Yeah.
we didn't get a result, which is part of doing experiments. Part of doing tests is to not get everything right. I know Globers would never show themselves actually getting something wrong. You would never show that you messed up on an experiment because you guys actually would just keep doing the experiment until it showed what you want. And then you go and bring that to YouTube. That's how you guys operate. So I don't expect you to ever.
Joe, hold on. I can't let you just say that.
Well,
Okay. That's not how science is done.
No, but it's
Right.
how YouTube science is done. YouTube Glober science is done. It is.
Tough crowd, Jared. Tough crowd.
Well, I mean, it's just
There was a guy, I don't remember his name, a flat earther who was super mad at you and Bob after the movie came out. And he went on and on about you need to first do the experiment before you let anybody watch you to make sure it gives the right results. It's a flat earther saying that he took his video down and I didn't download it.
because it looks so bad. Him saying that?
Of him saying it?
Yeah.
I mean, that's not the way to do it. But my cousin, have you seen, my ugly identical cousin McFlatty?
No.
No, you haven't seen. He's a flat earther. He loves you.
I don't know who that is.
Jeran. Yeah, McFlatty. Go. He's his channel, McFlatty.
Okay.
Anyway, his most viewed video is basically saying the same thing as that guy did. So.
Okay. Because,
All right.
I mean, you right here, the anti-scientific method is to select the required conclusion,
Yes.
only accept supporting evidence, reject contradicting evidence, and declare pre-selected conclusion undeniably proven.
Yes.
Okay. So just, I mean, that's, you've got Edwin Hubble saw that everything looks like it's moving away from us, which puts us in a favored position. And he said, we have to avoid that at all costs. Right. And we can't disprove the observation that the Earth is at the center. So he rejects all that evidence and says, but we will come up with something. So he came up with something that.
But Jeran, this was after aberration, parallax, and annual Doppler shift of color that was done. So if Earth at preferred
Hold on a
position,
second. That's not true. He said the observations show us that the Earth is at a central location. These observations cannot be disproven. You just said it was disproven.
yeah, it was disproven.
He just said in his quote, cannot be disproven.
Well, I disagree with him then.
Okay, well, that's great. But Edwin Hubble thought it couldn't be disproven. So I don't know what to tell you.
I disagree with him.
Okay.
You know what? He can be wrong. I don't know. I mean, I haven't read this quote or what he was saying or understand the context of it, but people can be wrong. Just because somebody says it doesn't mean I agree with it. Doesn't mean he's right.
But here's the thing is that everything that cosmology has gone through since then is based off of his findings. Right? I mean, so everything that we talked about, the expanding universe, the Big Bang, all has come because of his observation that the universe is expanding, that not the distance ladder, but he's got that the farther and farther you go away, the more faster and faster these things are moving.
Yeah.
Right. Okay. So it was in the book. The name of the book is The Observational Approach to Cosmology. Just, if you ever want to look it up. And he's talking about, let me see if I can find it. The world picture compensated for the minimum possible corrections. All right. So here we go. So he's saying the assumption of uniformity is much to be said in its favor. If the distribution were not uniform, it would either increase or decrease with distance, but we do not expect to find a distribution in which the density increases with distance. Now he says, such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a central Earth. The hypothesis cannot be disproven, but it is unwelcomed and would only be accepted as a last resort in order to save the phenomenon. Therefore, we disregard this possibility and consider the alternative, namely a distribution which thins out with distance. He says a thinning out would be readily explained in either of two ways. Then he names two ways, space of two different things. Then he comes back and says, both explanations seem plausible, but neither is permitted by the observations. The apparent departures from uniformity in the world picture are fully compensated by the minimum possible corrections for redshifts. No margin is left for thinning out. The true distribution must be either uniform or increase outward, leaving the observer in a unique position. But the unwelcomed supposition of a favored location must be avoided at all costs. Therefore, we accept the uniform distribution and assume that space is sensibly transparent. Then the data from the surveys are simply and fully accounted for by the energy corrections alone, without the additional postulate of an expanding universe. It is, in this case, all empirical information we have concerning the observable region as a whole is internally consistent. The region appears to be thoroughly homogeneous, an insignificant sample of the universe which extends indefinitely. The conclusion would probably be accepted without hesitation if it were not for the fact that at the moment, we do not know of any permissible interpretation of redshifts other than the actual motion, actual recession of the nebula. So, and then he says, we have to stay away from the absolute horror of the unique position. We have to avoid it at all costs. So, I mean, what part of
the reason why is because many other things have already confirmed that we're not stationary.
You could disprove the hypothesis then. So I don't know where he
Yeah.
gets that from.
So, yep, I can disprove his hypothesis.
But then so could he. So he's just an idiot then.
No, I don't think he's an idiot.
He's basically.
I think you might be putting a little too much specific interpretation as words. Maybe I don't know, but Hubble certainly Hubble was not ignorant of redshift. It was his thing, right?
Well, what he did is he was able to. Again, this is when they promote people or push people up the ladders, when they do something that allows them to continue on this path. So for him, they were very confused. What do we do if we're the center of the universe? Everything's expanding. How do we explain that? And he's the one that came up with the idea. We could be on a raisin bread. We could be on a balloon.
The hypothesis of Earth stationary and all celestial bodies moving in some manner around us, even though they're drastically distant, is not falsifiable, but it's easily dismissed.
Okay.
Right. So this is an example, and Popper would have, he kind of got down into a rabbit hole of rejecting everything that's about induction. But you can induce that we can dismiss that through induction.
I guess the problem with that is you better be careful, because everything that you have leading up to that point better be correct. That's all.
Yeah.
Because
and the door is open to show that they're wrong.
Okay. How am I going to show that they're wrong about the distance to the stars?
I don't know. That's on you.
Well, again, I'm not
it's not on me to tell you how to falsify something.
Let me ask you.
It's on you to falsify it.
Because it seems so simple to me, and I can't understand why people don't get this. So let's say that we've got just a 3-planet problem. We've got Saturn, we've got Jupiter, and we've got the sun. Okay, and we can figure out their orbit times, whatever, just by observing them. Okay, now we know this one goes around this amount of time, this one goes around. So now tell me how, if we're going to figure out some gravitational equation to where we're going to explain the 3 bodies and how they're moving, what I've never understood is if I'm able to change the mass of any of the planets, because nobody's gone there and actually measured them. Nobody knows the mass of the sun. Nobody knows the mass of Jupiter. Nobody knows the mass of Saturn. Now you're going to tell me that they do, which is a joke.
Yeah, they do. There's ways to measure it without going there.
How do you measure the mass of Jupiter without going there? Tell us, please.
All right. Kepler's laws of motion.
And laws of motion, okay.
Yeah.
All
of science is man-made. Everything in science is man-made, right?
Okay.
We've figured things out.
But there's a difference between when we're on Earth and you tell me the parallax can tell me the height of that tree. I can go to the tree and I can measure it and say, he's right. Parallax does show us the measurement of the tree.
Yeah.
Or I can go weigh a rock or go weigh some element, but I cannot go to Jupiter.
Yeah. But how did you weigh that rock?
Put it on a scale.
And how did you calibrate that scale? It's just like a spring scale, right? You didn't actually weigh it. You put it on a spring scale, and then the spring scale moved down a little bit, and because of the gears in it, the numbers showed up on the little window.
Correct.
Well, so they inferred that, didn't they? That wasn't a direct measurement. That was an inferred measurement.
No, that was direct.
No, it wasn't. It was how much a spring got. It's how much a spring got pressed down. Now the spring scale is calibrated.
Mm-hmm.
But it wasn't a direct measurement.
They put the item on the scale.
Yeah, but it was still an indirect measurement. There was some calculations involved, right?
So how did we put Jupiter on the scale, and then I'll give it to you.
Okay, so you do that through application of Kepler's laws of motion, and application of gravitational law.
Right. That's what
Right?
I'm getting at.
So,
I know
you,
what I'm getting
you
at. is
put
that
those
could
you put
change-
those together, and you can then determine the mass. But now offhand, I can't cover those things.
No,
but
and you wouldn't be
if-
able to
if-
determine anything. That's. I mean, you're.
of course you could. Of course you can.
You're dreaming. You're dreaming. If,
All right.
Because none of it matters. None of it matters. Basically, if you have an equation for gravity that you want to use, you can apply anything to Saturn. And if it doesn't work, then take some mass off of it, put some mass on the sun, do whatever you got to do until it balances. That's not measuring.
When you have something and they all work together, then
Hmm.
you are. Yeah.
But you could be off. How do you know? Like, for instance, what if the sun is 1/10 of the, or 90% of the mass that they thought, and Saturn is more mass?
Okay. So because there's multiple lines of evidence that you come to, and when they're in agreement with each other, then you have extra confirmation, right? That's the mountain of evidence I'm talking about. Lots and lots of different avenues that you come about it. So how do you know the mass of the sun? Well, you measure the distance to the sun of the earth, you measure the mass of the earth, and then you know because of centrifugal force and centripetal force must be in balance,
can't
then
figure
you know
those
the
out
mass
unless
of.
But you can't figure out centripetal force or centrifugal force unless you know the mass of the Earth.
Yes, and we know the mass of the earth
How did we get that?
because we know the radius of the earth, and we know
How did we get that?
well, we measured the radius of the earth. I did it myself 4 times.
Oh, okay.
Right. So all of these things, these aren't just guesses, right? Every time you ask a question, there's a previous way that somebody did these things. So it's not
What
just
I'm trying to
random
explain to you-
guesses.
what I'm trying to explain to you is that you're so in love with it, and I get it. You went to college, so that you got a degree, and you feel like you're smart in computer science.
No,
so you
no,
feel, hold on.
No,
Yeah, that's the only reason you would ever you've given your beliefs away to other men.
no,
Matu.
I haven't. I confirmed them myself, Jeran.
You
I
confirmed
personally
the weight-
measured-
the mass of Jupiter.
Personally measured the radius of the earth 4 times.
I asked you the
Personally,
mass of
myself. Not,
Mass
I
of
did not. I was not involved in the mass of Jupiter. I didn't do all of science,
Jupiter. So
Jeran.
you've given your
I
beliefs away
did
to
not
males.
do all of science.
Right. So
I only did the parts of science I did, and the other parts of science other people did.
right.
So we
Well, I
can
agree with that.
review them. We can see if they made errors in their methodology, if they applied
I'm trying to explain to you
something
the errors
wrong.
in their methodology, and you won't listen to me.
But
So
you didn't identify the errors in methodology.
the errors is it would be impossible to do, and your explanation for how we did it isn't sufficient by saying, oh, we take the Kepler's laws, and then we take the distance of the sun, and then we weigh the Earth, and that none of that explains how Jupiter or Saturn got their mass around the sun.
Yes, it does. Jeran.
No, it doesn't. It's just you
it's
think because what they taught you must have had somebody who went through the scientific method to get there. It didn't.
you can, Jeran. You can test it yourself.
Test what the
You-
mass
you
of
can-
Jupiter?
Yeah,
How?
you by applying doing that same hypothesis they did, and then going through the same process they did. See if they did it right. See if they made an error in the process.
But do you understand that I could take mass away from Jupiter? Let's just take the Earth and the Moon. Very simple system, right?
Okay.
So the Earth and the Moon, that you can give me a value for what you think the mass of the Moon is. But if I want it to be different, I could just add mass or subtract mass from the Earth and then correct it with the Moon.
How would you correct it?
Well, if I take, let's say that there's a certain equation for the gravitational orbits that I want to do, well, then I would just adjust it so that it matches, so that eventually the orbit matches what I see in the sky.
Okay, and then how? But how would that be wrong? What would be wrong?
Because
about
you don't
that?
know that it's right. Just
How do you-
because I mathematically got it to work doesn't mean that those values are right. The values could be anything. Like here's what the biggest
But
joke.
hold on. The values cannot be anything. The values can only be one thing.
Why is that?
Because when you take the mass of the Earth, the distance to the Moon, and the orbital speed of the Moon, there's only one value for the mass of the Moon that works.
If
If you have the mass of the Earth,
okay,
which we previously had measured.
right. So so the mass of the Moon is just a. You're not gonna let me call it math. It's just a number derived from other numbers.
From other measurements.
If you want to,
There's measurements involved, Jared. Just like you were
Think of
in
how
the
ridiculous
field. You were really in the field.
yeah, but
Really
I did not
measure-
the-
really
I didn't
doing
measure
things.
The mass of the Earth. I'm not that
And-
dumb.
and
I would
hold
never
on, hold
claim
on.
that.
And so for you to say somebody just did math is like somebody saying to you, Jeran, that you never went out on that road and actually tried to do an experiment.
You know what? If I was sitting at my house and did it from a telescope and said, okay, from the I can see the canal and I think this and this, then that's a problem. Because I'm just I'm just making shit
That's
up.
not the right analog there, Jeran.
Why not? That's what they did.
Because
They're
that's
looking
not the
through
right
telescopes.
methodology. That's not the
But
right
they're looking through
methodology for the
telescopes.
experiment you were doing. Right?
Okay,
You
so
have
tell
to
me.
apply the right methodology.
Okay, so they have all these moons that go around Saturn, 144 of them or something.
Okay.
So some of them go the backwards way. And I mean, nobody could ever figure that out mathematically. It's a joke. But let's say that somebody wants to try. Do you
people,
realize that?
Jared, people can't. People
Oh,
have.
boy.
Just because you don't see a way doesn't mean other people can't do it.
No, but all they've done is taken the numbers and moved them around until it fit. That's not measuring. You can laugh all you want. It's embarrassing that you don't understand this. It's embarrassing that you can't see. And I tried to give you an easy explanation by saying, let's say there's just these three bodies that I could adjust them until they worked out. Even if the equation is different. I mean,
Sorry.
it doesn't have to be our gravity
So
equation.
so take if you take the distance between the sun and Jupiter, the distance between the sun and Saturn, and the amount and their orbital speed, right? You take those things in isolation, right? And you don't know the mass of any of them. Yeah, you could potentially come to have a whole bunch of different possible solutions for that. Maybe definitely if it's just two. If three, I don't know, but let's say that there are. But that's not how they did it.
So how did they get the mass of all the moons of Saturn?
So, like I
See,
said,
here's the thing. The thing is that
well,
you
you asked a question. Let me answer.
well,
right?
silence. That's why I was. jumping
I was preparing myself, Jared.
in. Okay.
I want to give you a good answer. You're
Mhm.
worth it, Jared.
Thank you.
I
appreciate your.
dude, I like talking to you. All right, it's there's others.
Well,
There's others.
I
There's definitely others that are less fun and less interesting than you, Jared. So,
don't think your audience likes you talking to me, though. By the way,
don't like what?
they don't like you talking to me.
Why?
Oh, I don't know. Go read your comments. I'm sure they tell you in there. I'm a grifter. I'm lying. I don't really believe this. I don't know, whatever else.
Hey, audience, I have been convinced that Jeran is not a grifter. I made a video accusing him of that, and I was wrong. There you go.
Yeah, that one kind of pissed me off. But it's okay.
All right,
but
hold.
I just
You asked. Let me answer
like
the
it.
question.
Go
Let me
ahead,
answer
I'm
the
ready,
question.
I'm ready.
There's a
Okay,
process,
I'm
right?
not talking.
So it's built on previous measurements. So the you need to know the mass of the sun, the orbital speed of Saturn, and the orbital size of Saturn, and
How
that
did you get
gives
the mass
you.
of the sun?
I'm not done answering this question. Then that gives you the mass of Jupiter. When you have the mass of Jupiter, then you can take the orbital size of a moon and the orbital rate of the moon, and there's only one answer that solves for the mass of that moon, and then you can do it for all of the moons. Okay, now you want to do the infinite regression. How do you know the mass of the sun? The same thing. You take, it's not the same thing, but it's similar, right? You take the mass of the Earth, the orbital speed of the Earth, the orbital size of the Earth, and the mass, right? I said the mass of the Earth. And then you know the centripetal force between the Earth and the sun, which then we can figure out the mass of the sun from that. Now you say, well, how do we know the mass of the Earth? Oh, well, we could take the gravitational the downward acceleration on the surface of the Earth and the radius of the Earth, and that will give us the mass of the Earth. And how do we know the radius of the Earth? Well, we measured that as well. I measured it myself by measuring the angle to the sun and knowing the distance between myself and the Tropic of Cancer, Tropic of Capricorn, and the equator. Well, how do we know the distance between where I was and the tropic, right? We can keep going, and I can keep answering those questions.
Okay. Hold on. You measured the radius of the Earth with the sun? Explain that to me real quick.
So the angle to the sun, I did it on 4 different days, the 2 equinoxes and the 2 solstices, just because we know where the sun, the sun goes over the Tropic of Capricorn on the December solstice. So it's easier on those days because people know where the sun is. And I know my distance to it, right? And I know the angle. And if I
How do you know the distance to it?
how do I know the distance between myself and the Tropic of Capricorn?
Oh, I thought you were talking about to the sun. Go ahead.
Yeah, this doesn't require distance to the sun, just that it's very far away. That's the only part of that. And then it's some trigonometry. It's the same method as Eratosthenes used. So that's how I measured myself the radius of the Earth.
Right. But Aristophanes, you would admit that experiment doesn't prove the curvature of the Earth, doesn't prove the Earth.
It measures, Eratosthenes measured the radius or circumference of the Earth.
Well, but if it's a small local sun, you didn't do that. You just measured the.
I wasn't talking about Eratosthenes' measurement. I was talking about my measurement. My measurement could not work for flat Earth because there were 3 of us when we did it on December 21st. Round Thinker is one of the people that was that did it, and he's in Israel, and he's in the live chat right now.
Mhm.
And he has videos on his channel of this application of this exact process. So if anybody's
What's
interested,
that channel name?
Round Thinker.
Round.
Yeah, he's in Israel. A lot of his videos are in Hebrew.
I speak
so-
Hebrew,
No, you don't.
but I did want to get to that. I know. Can I ask one last question?
No, hey, that
What's
was
your
like
turn? Take it
that
out.
was like a 45-minute one question.
Go, and we'll be done.
All right, Jeran, what would convince you that the Earth is a sphere?
At this point, it would take a lot because it just seems like there's too much now that the globe Earth has to overcome. But I do think something as simple as a personal observation would do it. But I know that that's
What do you mean a
Probably not going to happen.
personal observation of?
of the Earth from space. I
So,
think that I would,
and the only person you would accept that from is you.
no, I think there's other people I would accept it from, but I would want to make sure that the windows aren't curved, that I'm not wearing like for instance, you would admit that the guy Baumgartner who went from the space Red Bull jump, right? And you got Neil deGrasse Tyson saying you can't see the curve at that height, but you've got him standing there looking down saying, I see the curvature of the Earth.
Yeah.
Right. Now we know that the picture behind him has probably been a fisheye lens, but also it seems like possibly he did see a curve because his helmet is curved. Now I've seen when there's a video I've done where there's a news guy getting into an astronaut suit and the camera's behind him. And when he puts on the helmet, but he only puts it on halfway, so you can still see it. And you look through the helmet of the astronaut and the entire room is curved. So it's possible that the astronauts think they see a curve, but it's because they're wearing helmets. But anyway, again, I'm just saying that for me, I would need to be just make sure. But it's simple. I could put the helmet on outside the thing and be like, no, there's no curve in there. Because one of the things that you can do is like if a balloon starts taking off, people always, but like right from the ground, you see a curve. Well, we know the lens is curved, right?
Yep.
I mean, obviously,
Yep, definitely not the preferred.
right. So kind of the same thing for
Yeah,
me.
you definitely would. I
make
mean,
sure-
you'd want to use like Dwayne Kellum. He had
Dwayne's awesome. Yeah.
Yeah, he had a rectilinear lens.
Which is still got
The
Distortion.
FE, the Sony 1.5.
Mm-hmm.
Yeah.
But what I'm saying is that if we so we can see that on a low camera
Right.
or we can see that on a low balloon.
So I mean, your only accepted evidence is you personally.
Well,
from
at this
space.
point, because there's too many things that are like when you go back into the history of science, there's too many things that don't work out. The idea that we looked up in the sky and said maybe Venus is the same size of Earth is the most ludicrous belief that any religion has ever believed in, and that's the religion of scientism has bought that hook, line, and sinker. They're like, yeah, what's the big deal? It's like, because look in the sky, we see a bunch of little lights. How would you have gotten correctly that Venus is the same size of Earth? Back when there wasn't even, I mean, a telescope's going to be like 10 times at the most. We had no idea.
What? 10.
What was it? What was the telescope that somebody used in the year 1700? 10 times?
Oh,
4
way
times?
more. Way more.
How many times?
I don't know, but they had
Wasn't
one arc.
Galileo's?
They had one arc
Galileo's-
second precision in the
In what-
1700s.
Wait, 1 arc second. So you're talking about take a degree, 60 degrees of that is 60 minutes of degree. Take that down to 60 seconds of degree.
Yes, 1/3600th of a degree
Oh, I
is the
believe
kind
that.
of precision they had then. Yeah,
Why would you say that?
it's not that difficult to have that kind of precision. Have you seen the theodolite?
Even with an atmosphere?
Have you seen a theodolite? That's just the telescope. We're just talking about the telescope. Have you seen a theodolite? You know how big a
No,
theodolite
I'm
is,
saying,
right?
but if you're looking through a telescope, you're
Right.
looking through the atmosphere.
Hold on.
Okay.
Precision. We're just talking about the precision of the measurement. Have you seen a theodolite? They're like this big. I could hold
I've
it
seen them.
right here, right? The telescope on that, they're, I don't know, 10 inches. I don't know.
Okay.
And I know that Jake will say that this is 10 inches, but that's not 10 inches, Jake.
No comment. None whatsoever.
Jake, send all the hate my way. We're talking about Jake the Jake hole. Anyway, the telescopes on theodolites are able to measure to 1 arc second as well.
Yeah,
So
well,
it doesn't take a very large telescope to be able to measure 1 arc second.
okay, but as small as that little section is of the sky, to me, like even the atmosphere would move things out of that line. I mean, you wouldn't even know. Anyway, that's besides the point. So your question, what would it take to get me? Yeah, I mean, we're not moving. I mean, that to me is very clear. It's if I'm to believe we're moving, then I need some sort of evidence that is. And then when I see the purposeful misdirection, like for you guys to change rotational speed and just refuse to look at things in linear speed and say, oh no, when we're talking about moving in a circle, we are going to talk rotations per minute. It's like, okay, I get why, because if you're talking about rotations per minute and we look at a carousel and it goes 3 rotations per minute, and then you're like, Jeran, what is that? Compared to the Earth is only 0.00035.
When I did a video, and I have on my website the gravity challenge, the $10,000 gravity challenge that I have.
Another joke, yes.
It's not a joke, dude.
It is a joke. I told you
anyway, I use the linear speed when I'm calculating the centrifugal force.
Okay, so what's faster spinning, the Earth or a carousel at Disneyland?
The faster rotational speed or the faster linear speed?
The faster linear speed.
The faster linear speed at the edge of the Earth is at the equator. The Earth is.
Okay.
And at 1 foot away from the north or south geographic pole, the carousel is.
Okay. And so it is incorrect then for somebody to compare the rotations per day of the Earth to the rotations per minute of a carousel.
Yeah, I don't do that.
Okay, there's no connection there. But they always want to say that. They want to say the Earth is very slow.
That is an unfair comparison as well, because when people are talking, when flat earthers talking about the rotational speed, it's going 1,000 miles an hour, right? They're talking about, I think, getting at the centrifugal force that people think you'd feel or that you'd experience or that would happen, right? Is that what people are typically
I've done the math.
suggesting?
And if you take, I took a carousel that was 40 feet in diameter, figured out what the circumference was like 150 or some feet, and then we figured out how fast it was moving, miles per hour, which was moving about 4, and the Earth is going 1,000 miles per hour. So then to figure out what the equivalent speed on the carousel would be, which it turned out to be like 300 and something times as fast the Earth is. So if we apply that to the carousel, you would be moving 11 rotations per second.
To get the equivalent linear speed?
Yes.
Or the equivalent centrifugal force?
No, I was just figuring out the linear speed. To get the equivalent linear speed, you would need to be moving 11 times a second.
Yeah, so a carousel is not the right when you're looking at RPMs, and it's not the right when you're looking at linear speed. It's about centrifugal force. So you can, for any size carousel, figure out, well, if somebody's on the outside of the carousel, what is the centrifugal force compared to the centrifugal force at the equator?
So
that's the correct way to do it. And so I don't see people doing the right comparison on either side for that one.
Okay, but the centrifugal force is the force that's throwing you out?
Yes.
Correct, right?
Yeah.
So if you're moving 11 times in a second, wouldn't you be thrown out quite violently?
Yeah, so that's an incorrect comparison on that carousel.
Why? But why is if it's the same linear speed?
Because the centrifugal force is related to linear speed and the radius, both.
Okay.
Okay, do you know the formula for it?
It's the same as centripetal.
Yeah,
Force equals mass.
it's not force. It's
Or whatever.
well, I mean, it can be a force, but the acceleration one is easier.
I don't know. Mass 1, mass 2 over the radius.
No.
Square?
Centrifugal and centripetal force.
I don't know.
All right, hold on.
Yeah, you look it up. I don't have time to look it up.
Yeah. I do. By the way, I do not think that people should have to memorize formulas.
Good.
Yeah. I always in school I was always irritated by closed book tests. I'm like, dude, when I'm done with this class, I'm not going to have a closed book life. Anyway,
Those teachers knew it was best. Remember, they told us we'd never have a calculator in our pockets. So they knew it was coming. They knew the future.
they were wrong. All right, so centrifugal acceleration. Some people call it force.
Okay.
But this formula gives you force. It's the velocity, the linear velocity squared, divided by the radius. Right.
Okay.
So you take your linear velocity of your carousel at the one that's 40 feet that's moving 11 rotations per second or whatever.
No,
And
that was to equate it to it moves only 3 rotations per minute.
yeah. So, but what was the linear speed, right?
4 miles per hour.
Yeah, 4 miles per hour, and then you square that, so 16 miles per
Okay.
hour. And
Divided by
I
the
feel
radius,
dirty
20.
doing science in miles, but anyway, and then divide by the radius, and the radius is what?
Probably 20 feet.
Tiny,
Yeah.
right?
Right. So that gives it a very small.
No, it gives it a large centrifugal acceleration compared to, right?
So 16 divided by 20.
Well, no, you have to do it in miles. 20 feet is how many miles?
Oh, okay. Got you. Okay, got you. Right. You have to do that. 5280 divided by 20.
That's
Or 20 divided by
that's
5280.
why metric, man, metric or sheep units. Sheep
Yeah,
units.
we should have been taught that. I mean, I agree with you, but we weren't taught it, and I'm not about to learn it now. So,
It's easier, dude. It's so much easier
uh,
to do
yeah, I mean, it
math.
does seem like
to
it'd be
do
easier.
to do science in SI units is so much easier.
let's change time to a 10 too. I like 10 time being.
Oh yeah, metric time. I'm in. There's 10 hours in a day. There's
Right.
100 hours in a minute. 100 seconds in a minute. Did I say that wrong?
Okay, let me ask you one question now.
Okay.
8 inches per mile squared. Is it an okay formula for us to use as far as we can see?
It's very limited in its use for what I've only seen one flat earther ever do an experiment where that was the correct formula.
I could see that because you're not. You're,
Do you know which flat earther that is?
Flat Earth? Me?
Yeah.
Okay, good.
You are the only flat earther I've ever seen do an experiment where that was the correct formula to use.
Oh, because that was the experiment really for the Bedford or for the canal.
Yeah, the canal. That is the right form. I mean, it's an approximation, but it's an
Right.
okay approximation for
Okay,
your
just trying to
thing.
get that.
So,
Right, because you're not taking if that's the baseline, if the laser was the baseline, then you don't need to calculate a observer height. That's the baseline.
yeah, you aren't doing bottom up obstruction. So if you're doing an
Well,
experiment for bottom up obstruction, 8 inches per mile squared is wrong.
Correct, because it could give you an idea of what to expect over a certain distance.
No, not even
Well,
close.
but it's how much
It's-
the Earth curves in a
it's-
certain distance.
No,
What do you mean?
it's not how much the Earth curves. It's linear drop from a horizontal tangent. That's what it is. It's not curve. Curve is measured in degrees, not feet.
Okay, but what
Right. So
What's that on
or
the
inches. So all right. When you are wondering how much bottom up obstruction you should see,
yeah, that's not going to work then.
it's not the right formula. There's a way to make it work, but it's basically never going to be the thing that when you're looking across water, that's not the formula you want to use.
But if somebody says, how much curvature is there in 10 miles, and I say 66 feet, that's
That's
correct.
wrong. That's wrong.
Why?
Because curvature isn't measured in linear units.
Says who? I just hate when we have all these designations that you're just like, we have some human made that designation.
Jared,
we have to
no, this just it's a curve, a curve.
Yeah, I know, but the
Hold on.
curve is a drop from the tangent. That's what a curve is.
Then say drop from tangent. Don't say curve.
Okay,
Curve
much
is
is
not
the
drop
drop
from
the
tangent. Here, let me show you.
10
Here, let me
miles,
show you this.
66 feet.
Let me show you this.
Lord.
All right, here's a curve. How many feet is that curve?
That's not the Earth.
I know, but this is a curve.
Okay.
How many feet is that curve?
I don't know.
It's a malformed question, right?
Okay.
Okay. I'll do another one, right? Now I'm not drawing any additional things without any other designations. How much curve is that?
I don't know. You'd have to figure out what the radius is.
No, I would. Yeah, the amount of curve would be right here. This angle, theta. It'd be the number of degrees in this here. Now, I'll do one more. Straight
Do
edge.
your kids ever tell you you're annoying or no?
I'm their science teacher.
So they say you're annoying. I'm guessing they do. If I could talk to them on the side and just say like, yeah, under your breath, do you ever think like Dad's annoying? They'd be like, yes.
All right.
A lot.
So here is a horizontal tangent right there.
Okay.
This line here is a horizontal tangent
Right.
to this point, right? You could keep drawing
It's a
the
little
curve.
off, but all right, we'll get to
So
it.
yeah, I mean it's not to scale, and I'm just
We get
roughing it. So again, where's the well? There's no. This isn't doing anything. So I do this, then I go, all right. Well, then we'll have this here.
Yeah,
We'll have this. We'll have this. We'll just go to this point. We'll say, all right. What's this? This is this h here. This height. This isn't the curve. This is a linear measure. This is the drop from that horizontal tangent. But that also doesn't help you to know bottom-up obstruction.
yeah, it just tells you how much is dropping from the tangent.
So,
But the globe uses all kinds of different ways of doing this, right?
yeah, you need to use the right thing for the right situation. Okay, so now we're getting closer. My angle
guess
there is
we're
a little goofy. So
That's a little bit weird. Is drop a better description?
drop from horizontal. I mean, you want to be pedantic. Then it's
No, I don't.
linear
like it.
drop from horizontal tangent is the correct term. And so you could use some shortened version of
So
that
if
to
if
say
you're talking to
drop.
somebody on the street and they say, "Hey, you're McToon, right? I've watched your stuff. What is the equation for the curvature of Earth?" What would you say?
I would say it is 69. I'm going to do it in metric, or sorry, not metric, in freedom miles here. 69 miles per degree is the formula for curve of the Earth.
That's the distance.
No, it will give you an answer in degrees. Right, so 300 miles. What's the formula for drop for 300 miles? We just
Well, let's
divide by
do 5 miles.
69.
Something that we could do. 5 miles.
That's going to be a very small number, right? But it's going to give you a number in degrees.
Yeah, but what's
Right.
wrong with doing 25 times? I mean,
It's going to be
5 times 5
0.0
is 25.
0.07 degrees is the curvature in 5 miles.
How does that help anybody?
It doesn't. It's the wrong question. Ask the right question. What's the amount of bottom-up obstruction for an observer 10 feet high and a distant thing that is, 12 miles away? That's a proper question. And I can give you the answer to that. Right?
No, I don't want it.
But I can give you the answer. That's the kind of thing we can answer. But to say, what's the amount of curve in 12 miles? That some portion of number of degrees, right?
No, I think it's very easy to use. I mean, because the globe uses, r minus the square root of, all that, the different, what do they say? 1.35 to the, the square root of the observer's height. There's all these different formulas that they use.
Yeah,
but
for different things. Yeah, the 1.22 times the observer's height, the square root of the observer's height in feet, is the distance to the horizon in
Correct.
imperial units, excluding refraction.
So
So
when we say drop with trigonometry, what are they measuring?
drop with
A
trigonometry.
trigonometric drop would be just basically drawing triangles. The same thing you drew
so
there.
so if the observer height is 0,
Mhm.
then that's where those two actually meet. But so you can, with the two-step process, you can use the 8 inches per mile squared.
Okay.
But
Because
hold
there's a
on,
lot of people out there, a lot of
hold
globers.
on, wait, I can't
Okay.
leave that. I can't.
Okay, go ahead. Finish
I
it off.
can't leave that unfinished. It's a two-step. First, you use, again, this is ignoring refraction, pretending that refraction doesn't exist, which we know it does. You take 1.22 times the observer's height in feet. That gives you the distance to the horizon, right? So you take 10 feet. You're 10 feet up, get the distance to the horizon. Okay, then from there to the, you know the distance, right? So then you know where the other part of it is. So if you're 12 miles away from the observation, then you subtract off that first chunk, and then you use 8 inches per mile squared for that second part. And that will then actually tell you, ignoring refraction, the observers are the bottom-up obstruction. Well, I've never seen a flat earther do that, though.
It's a long way to do it, but yeah,
It is.
most people are
It's-
going to use the calculator.
Yeah, use Walter Bislin's calculator, and then how much for refraction is the question, and you can measure the vertical temperature gradient. That's fine, and then we can get the coefficient of refraction from that.
Okay, I've got one other question for you. So you go ahead, you're next, and then I'll get my last one.
Oh, I get another for you?
Get one more.
Jeez.
You don't have one. Then.
I don't have one ready.
I'm sorry.
Ask me, and then we'll.
Maybe you
we'll
can
go to
finish
the-
off. Okay,
then
so
we'll
this
go to the
one is the one that's I think rather embarrassing for you. Is you actually think that the Bible says the Earth is a sphere?
Let me bring that up. Hold on. Let me close all my tab. I got too
At
many
least
tabs.
some religious people are like, well, no. We figured out it's a sphere in the Bible, but to claim that the Bible actually says that the Earth is a sphere, I went and looked at the Hebrew. I did everything I could to give you the benefit of the doubt.
all right.
It's possible.
I'm gonna share my screen
I'm ready
so
for it.
you can see. All right.
Whoops. Where's the...
So it is all right. First of all, it's a bit tongue in cheek. All right.
Oh, so it is a joke.
I know it's a bit tongue in cheek. All right. All right. Are you
It's a joke.
are you showing? Do you see it?
Yep.
Okay. So I say this statement here, right, is a bit tongue in cheek because you don't go to a non-scientific book to figure out what shape of the Earth is. You just go measure the shape of the Earth. But
Okay.
anyway, so I
don't
was
make
just
that
taking this is a response to the Nathan Roberts's list of whatever, and if you look at Isaiah 40:22.
Mhm.
It says in some English translations it says circle, and in some English translations it says round ball, and some says sphere, and
but
some
hold on.
say globe.
If you go to the Hebrew, there's no way anybody can get that from the Hebrew. The Hebrew is
Okay.
very, very clear.
What word is it in Hebrew?
Chug.
Right there. See that?
Yeah.
Right there.
Okay.
And here is the concordance of Hebrew and Chaldean scriptures. Right there on the right, you see that? And this middle one, I asked Round Thinker, whose first language is Hebrew, which to help me find the proper chug or hug, and it's this middle one here. That's in the Chaldean and Hebrew scripture. What did I say?
So
The
what
concordance,
about
the concordance of Hebrew and Chaldee scriptures. This is the definition of hug. Noun, masculine, circle, comma, sphere. And it gives as an example Isaiah 40:22. You see that?
Well, it's the 3 times it's in the Bible, but none of those work for sphere. So it's not even
Certainly.
true.
Well, I mean, it does right there. This book, at least, the
I don't know where you
Chaldean.
got that from.
Well, it's right. Here's the PDF. The concordance of Hebrew and Chaldee scriptures. There you go. Here's a scan of the book. I didn't just make this up. This is an actual
Yeah, but if you found
right
one,
there.
you found one book that says it, but there's
Okay.
every other one that exists doesn't say that, right?
1876, long before NASA. Right.
Okay.
So
What is it? Isaiah 40:22?
yeah,
Right.
and that's the example that they give right there, Isaiah 40:22. Okay. Now some people will say, and I've heard them say it, oh well, these versions here they're wrong because they were, they're Freemasons or they're Jesuits or they're whatever, right? People say all sorts of things, right?
Yeah, but do you know how many versions of the Bible is there?
Oh, there's a lot. So
okay,
all right. So
if there's only one book you can find that says that it says, which wouldn't even work because
there isn't just one.
Oh, there's more.
That's the one I listed, but there's somebody else had a version that was.
Okay, but
anyway, so hold on. Let me get to this.
Gotcha.
The Latin Vulgate right there, right here, Latin Vulgate. Kid Sedet, Super Girum, Terrae et whatever. I'm not going to keep going here. It is he that sitteth upon the globe of the earth. This is the actual. Somebody a while ago had said, well, the Latin Vulgate says flat, and so I looked it up. It doesn't. This was vulgate.org.
So now that's listed two other places in the Bible. The word "chew" gets used two other places. See if you can insert globe in those two other places. You had them listed. You had them listed on your.
Right. Do you see it? Circle, comma, sphere. It's
okay.
So
it
can be either, right?
Okay.
So it works. You can do either, right? So what that's telling us is it's not evidence for anything, is what it is.
Well, I would agree with you for that, but I mean, if you wouldn't have came out and said the Bible says the Earth is a sphere.
Well, but here's the question: is the Peshitta Holy Bible the Bible? It is the Bible, and does it say that the Earth is a sphere? It does say the Earth is a sphere. So yes, the Peshitta Holy Bible does say that the Earth is a sphere. So you can't. It's a fact that cannot be denied. The Peshitta Holy Bible does say sphere.
But you're just being disingenuous, and I don't know how you feel like as a Christian that's okay to do. It's just not being real. It's not being.
When I ask, Jeran, when I ask you the question, does the Peshitta Holy Bible say that the Earth is a sphere? The answer is what?
But you realize what you're doing, and you realize if somebody was doing that against you,
absolutely cherry picking. Yes, but you can answer the question. It's not proof of anything. I'm not going to write. But does the Peshitta Holy Bible say the Earth is a sphere? What's the answer? There's only one answer.
Yes.
It says, okay.
After the Bible, I don't know if it does.
And Jeran, that is not evidence for anything. Right?
I would agree, but I would agree that.
So now let me give you one more. Some people will say that was changed. They like the King James. I'm like, King James was, the government gave that, but they're like, you got to go to the older ones. Okay, hold on, I'll go to the older ones. Here you got Amos 9:6 in the Geneva Bible from 1560, which came out before the King James. He buildeth his spheres in the heaven and hath laid the foundations of his globe on elements in the earth. So the Geneva Bible and the Bishop's Bible is just another translation that's very similar to the Geneva. It says, again, globe. So when you ask the question, does the Geneva Bible say that the earth is a globe? Then the answer is yes. And it is not, it's still not evidence for anything.
The Geneva Bible, is it taking from the Hebrew as it should?
I don't recall offhand.
Right, because anybody taking from the Hebrew, it could never use that word.
What?
Sphere or spheres, it's not even in there. The word for ball is something completely different.
Yeah, but put it right here.
Yeah, you found it in one spot. I said that. I mean, you could look here. This is the let me show you this one. So this is the Strong's Concordance, which most people go with, or the Bible Hub one, right? And
but that's not.
That's not what.
That's not Hebrew. That's just Strong's Concordance.
I'm
it's
sorry.
It's not a Hebrew dictionary.
No, the Hebrew's down here. The Hebrew is.
All right, I'll stop sharing. So hold on.
Circuit, compass.
If that's not the dictionary. Though.
Let me get the Hebrew here. Hebrew Concordance. Oh shoot, they're not going to list the number for me. I got to go back here and see what the number was. 22 something. Oops, there was 2329. 2329. So I mean, just to me, I would never just say, like, if people were saying, I try to put myself in your position, but I would never feel comfortable in being like, I'm going to go find the one Bible that says what I want it to say, and then I'm going to tell people that nope.
I didn't find the one. I found a bunch.
No, you didn't find a bunch.
I did.
And you didn't double check it. You didn't go look at different.
did
you didn't go
double
look at the
check it.
Hebrew.
I did
Okay,
look
so-
at the Hebrew.
Okay, so Amos 9:6. I'm going to the Hebrew. It says, "He who builds in the sky his layers and his strata in the earth has founded who calls for the waters of the sea and pours them out on the face of the earth. Yahweh is his name." That is nowhere near what you just said. Go back to your Amos thing
Okay.
and tell us what Amos said.
The
You had
J-
Amos
the,
say,
the
"He puts
Bible.
his spheres in the sky,
Thus-
and the
thus
spheres
saith-
rotate, and we're
thus
going
saith
1.2
the
miles
Bible."
per hour."
Hold on. Thus saith the Bible. He buildeth his spheres in the heaven, and
you
hath
actually
laid the
think-
foundations of the globe on the elements of the earth.
Remember, God is watching you right now. Do you actually think that the person who wrote the Bible thought that the earth was a sphere?
Oh, it's just a person.
The person who wrote
That's
the
the
Bible,
thing. Jared, this is the thing. It's a person that wrote it.
right? So do you think Isaiah thought
No.
that the earth was a sphere?
Jared, let me say it very clearly. This is completely cherry picking. Absolutely 100% cherry picking.
Yeah, it's just
So if any flat earther ever tries to cherry pick the Bible to say that it says something that they think it says, I am given
not cherry
permission by them to do
No.
the exact same thing.
no, because if they're cherry picking by going and finding the one time it says that, then that's cherry picking. But if you're talking about the Bible is clearly a flat earth book, let's be honest. I mean, it's just, and it makes sense because that's when it was written in a time that they didn't know that the shape of the earth was a sphere. There's no way they would have known that.
And if you probably didn't read on my page there, mctoon.net/Bible-globe, the different organizations that disagree with your claim about that.
Of course they do. How would they not?
So, but you are, let me say that, I forgot his name. There was an atheist.
Aaron Ra.
No, he's dead now. It's Aaron Ra's not
Aaron's
dead now.
dead? Aaron's
No,
dead?
no,
Oh.
no, that's not Aaron. It's a guy that, so this guy was friends with flat earthers in the 70s and actually like hung out, like, there's a picture.
Leo Johnson or
No,
Leo Ferrari?
not the Canadian. The
Charles
guy-
Johnson.
might be Johnson. So it was friends with him. I'm forgetting his
Oh, he
name.
was-
Anyway, he said he's an atheist. And
Okay.
he said the same thing you did.
Right.
And you know what his motivation was?
Mm-mm.
He's an atheist. And his motivation was to disprove the Bible.
Right.
So he said, in an attempt to disprove the Bible, that the Bible was a flat earth book.
No, I know. And here's the difference between me and everybody else is that I'm not saying things for the point of proving my point. I'm going to the slate and trying to find the truth. And so when I see somebody like you say that the Bible, then I'm like, what? Show me evidence. And then I go look at your evidence and it's very shoddy. And I'm like, this is clearly not true. So to me, the difference is,
here's one thing that my cherry picking expedition has that no flat earther has ever done. The Bible never says the earth is flat. There is no translation I've ever found that says the earth is flat. But there are translations that say the earth is a globe.
Okay, hold on a second. If God placed the heavens like a tent for us to live under, that's a globe?
No, here's what I'm saying. Nowhere does the Bible say that the earth is flat.
No,
Nowhere
because
does it say that. Nowhere.
Well, they've demonized it. They've completely
But-
made it to be the dumbest belief of all time, so that
But-
people are afraid.
hold
to
on,
use
but
it
Jared,
because
but
they're
Jared,
afraid the
but
church will be
Jared,
called stupid.
Does the Bible anywhere say that the earth is flat?
Yeah, I mean, it says that it's like a stamp, like
Okay,
a rubber
but
stamp.
does it actually say that the
The
earth
word's
is flat?
flat? No.
Yeah. Okay. But does the Bible actually ever say that the earth is a globe?
Does man who wrote the Bible say that the earth's a
Okay,
globe?
hold on. Don't. It's not a trick question.
Yes, your version
Okay.
of the Bible. I guess I haven't seen that version. of the
It's
Bible.
not my version. I didn't write
The
one.
version that you choose to go to for your proof. Anyway, I'm just exposing to people so they can see. Most people watching this are going to recognize that you are trying to push things in a direction, which is exactly what you said.
Jaron, what I'm
Hold on.
doing is I'm just showing that it's cherry picking and that it's not an appropriate way to do it.
Okay,
That's what
'cause-
I'm doing. Don't
yes,
cherry pick.
'cause Yeah, don't cherry pick. But then also, if you go to mctoon.net and go to what is it called? Anti-scientific method, and you look at select the required conclusion that the Earth is a sphere. Only accept supporting evidence. This one verse says that the Earth's a sphere. Reject contradicting evidence. Everything else doesn't matter, Jeran. Declare pre-selected conclusion undeniably proven. I
Yeah,
wonder who did that.
and that is my point. That is exactly my point when I do that.
That's my point.
Yeah.
Don't do
so don't do that with the Bible. That's
do
my
it with
point. Don't
Okay.
certainly don't do it with anything, but don't do it with the Bible. And
Okay.
and I mean, I'm on Facebook. I don't know how much you are on Facebook, but
I try to stay away from that.
every day somebody posts Nathan Roberts's 200 verses or whatever, 100 verses or. Hey,
Well, there's
Nathan
a-
Roberts is retired, right? The guy hasn't been around for like
walking
3
his-
years.
I'm walking his dog the other night. Well,
What?
I don't
Hold
know
on.
if you ever saw what he did.
What? Nathan Roberts?
Oh, sorry, I thought you were Nathan Thompson.
No.
Roberts, I don't know what happened to him. The
You know-
preacher?
He's not a preacher. I don't think
Wait,
he's a
what?
preacher. I mean, he was super. He was he's a religious flirt, but
I think he's a preacher.
I don't.
Maybe I'm talking about somebody else.
Yeah,
I
his
remember
good
he-
buddy
he-
Dean Odell.
Oh boy.
Dean's.
Do you know the story about Dean Odell? Let me tell you a story about Dean Odell.
Okay.
Dean Odell says that God came to him 3 days before 9/11 and told him that planes would be crashing into buildings there. And he didn't think it was really important to tell anybody and then told us all after.
Oh.
So, I mean, this guy is, he's talking
Wow.
directly to God.
after
God
the
is-
after the fact predictions are super easy.
They're so amazing. Well, he
Yeah.
actually claims that he said he claims he preached it. Now, we don't have video of evidence of that, but I just think it's amazing that of all the people in the world that God could have come to make a change on that day, he went to Dean Odell and Dean Odell dropped the ball.
Yeah,
He didn't
because
tell anybody.
Dean is the only one. He's the only one that gets messages.
Yeah. And every time he's preaching, he's like, I was thinking of what to preach this weekend. And then God came to me and said, I'm like, oh my goodness. Oh my goodness. God did not come to you and tell you what to preach. Stop lying. Anyway, maybe
All
he
right,
believes
people are still going on about how I responded to Aaron Rod. No, he's alive.
You heard it here first. He's dead. Died yesterday.
Oh my gosh. I can't remember. All right, what was the guy's name in
What are you talking about? Nathan Roberts?
No, not the
Eba. I don't know who you're looking for.
No. The guy that remember, I'm like, there's this guy that's an atheist who says Bible is he claims Bible's flat earth book.
Oh yeah, I don't know.
It was
Is he-
Johnson or Shelton?
Okay, there's Shelton. One of the-
Is it Shelton or Johnson? Charles Johnson?
they both were heads of the Flat Earth Society.
Yeah.
Uh,
Darn it. It's
so
not
anyway, check
it's
out-
not Hitchens. No, it's not Christopher Hitchens.
Hitchens? Oh, yeah, okay. I wanted to show you if I can find it real quick.
I'm
I
not
want to show
gonna.
you funny thing.
Oh, there it is. I found it. Shadowwald.
Good. I don't know the name.
The name of the guy that
Shadow Wall.
Shadowwald.
Hmm.
Darn it. And there. Here, I'll post.
What do you think of Elon Musk taking that guy's screen name? It's a dick move.
What guy's screen name?
There's some guy who's had @X on Twitter forever, and Elon just took it. They sent him an email saying, "Sorry, taking." I just got screwed. They didn't even give him any money. Just took it.
Oh, well.
And
I mean,
their
that would've
excuse
been
for
nice
why
to
they didn't
get-
give him any money is because they said their rules say you're not allowed to pay for screen names. So they just took it.
Aw.
It's a jerk move.
I'd pay.
Maybe he's do something behind closed door. Well, no, he did get offered a trip to tour SpaceX or something, which is, that's worth millions.
Oh yeah. You'd pay millions for it?
No, that was a joke. I'm trying to find is this the
Robert. All right, the guy's name is Robert Shadowwald. And he said as a way of disproving the Bible, he argued that the Bible was a flat Earth book.
one? Yeah, I could see that. I could see people who thought that the Earth was a sphere who would think that's a good argument. And again, you just don't want to add things to the Bible. I wouldn't do that. Let me see if
All
I
right.
can get this. Okay, well, I'm just going to show you two things and we're done. But I wanted to show you the part of the SpaceX thing where they changed that one screen because I told you they didn't. Added, the scene at the end, at the beginning. So is this right here? Oh, let me describe it. All right, we don't have to look at that one. The other one I just was going to say is hilarious that I thought that the one of my early videos, first 3, probably first 4, is I thought it was absurd that the curvature of the Earth was supposed to be 8 inches per mile. So I'm calculating
Squared.
what the but I forgot the squared part. I didn't know that. It's
Oh.
like so it's funny because in the video I'm like, look at this is the distance from New York to Spain or whatever, and I said, let's do the math on it, and it comes out to I said, you're telling me there's supposed to be 1.7 miles of curve in between these. And I'm like pissed about it. I'm like, there's no freaking way. And it's like 700 times that much. I just think it's a funny video to watch when I'm like pissed. I'm like,
It's still up?
it's on Odyssey. Yeah, it's one of my I'm trying to.
Oh, that's
find
right. Yeah, because okay. Hey, and I got to back you on this because people bring it up. And Jeran deleted all of his videos for a reason, not to hide them. They're all still on Odyssey.
Oh, it's just stupid.
Right. So, and give
People think
30 seconds. 30 seconds. Give
Go ahead.
why. Give why.
Oh yeah, so people think that I deleted my video or whatever about seeing the transit of the sun,
ISS,
transit of
yeah.
the moon. Right, but I did not. When Bart Cybrell gave me 14 videos, so I wake up one day, there's 14 videos that have been
Struck.
copyright strike, but only 2 of them were takedowns. 2 of them were takedown strikes, and the other ones were all content ID to where I had like a decision to make. So I tried talking to him.
What was there something in all of your videos that was like an intro or something that was his?
No, it's just I always had like little clips of like either them asking the astronauts to sign the Bible or to put their hand on the Bible. So anything that's from his movie.
Okay.
And he had that. Do you know who Jeran White is? Oh, he's the
Um,
worst. He's a little Brit.
Remind me.
He doesn't believe in the moon landing, but believes everything else in space. He's like a British guy, or
Okay.
I don't know. He's annoying as could be, but he went through all my videos and found all the places that I included Bart Cybrell's film. Anyway, they did a takedown. So my options are, if people don't know YouTube, is if you have a video on private, it can still get a strike. So your options are pretty much to remove all your videos. So that's what I chose to do. I'm not sure if that was the best decision looking back again, because I still have my channel. I'm like, well, it seems like the right decision, but it's because you lose all your views, you lose all your likes, but you keep the channel. So to me, I had a decision to make. Do I want to take a chance that maybe I get a 3rd strike and I lose the channel? Or do I want to take down all my videos
That's
and
the
wait?
longest 30 seconds.
F you. Okay. Go ahead. That's it. It's just,
All right.
It's just stupid because people, they don't even think before they say things. And you got Dave McGowan who,
Yeah. All right.
is that dog alive?
Yes, it's a very precious dog. What are you talking about? Dave McKeegan you're talking about.
What did I call him?
I don't know what your problem with him is so much, but all right.
Go look at go look at his videos, go look at his page, and look how he was getting 1,000, 2,000, or 3,000 views doing camera shit. Then all of a sudden he does a flat Earth video, gets 100,000 views. Now everything's flat Earth, of course.
Well,
Because
yeah.
he realized that's where the money is. Yeah, of course. Okay.
Why
But we're
not?
grifters. I'm a grifter, but
No,
that
you're
guy-
not.
Yeah, but he
Hey.
is.
Jared, don't put that on me.
I didn't say you. I'm telling you he's a grifter. I'm telling you for sure he's a grifter. Because
Not on the globe.
what the
And-
hell was that? Oh, it's my voice.
These are the things I'm
Talking
talking
to myself
about.
in my head now.
Why do all these things not
Stop it.
jive with reality?
What's going on?
Why are the moon phases like the new moon?
There's a loop. Yeah. Is it one of your videos on Odyssey or something playing?
Yeah, but it wouldn't close. It was really weird.
All right.
And now there's no back arrow. That's really weird.
All
All
right.
right. Anyway, we're done. We're good.
Okay.
Okay. Let me check the super chats and see if there's any
Yeah.
questions for you. And we will
I
go
got
from
I
there.
got something for you from
Go
PhD
ahead.
Tony. He says what you're missing, Jared, is an understanding of geometry. The presenting geometry cannot be made consistent with the flat Earth. Your proposed deception is mathematically impossible. I guess it's not a question.
It's not really a question, but it also isn't true. So I don't really get. I mean, again,
You could show the mathematics for how it works. I haven't seen
yeah,
it.
but that's
though.
going to take a long time, right? I mean, if you're
Dude,
talking about,
you've had longer than we have.
what do you mean? You've had 400 years and the best scientists and the top minds
no,
and
no,
government money and monarch
Jared.
money and everything.
What is one of the most common things that people like to talk about in debates? They're like, oh, all ancient cultures.
Right?
What do they say? All ancient cultures.
Believes in a flat Earth.
There you go. So you've had longer than us.
Okay, but if it's a deception, then things are going to be hidden. It's not. This is not.
So
I mean,
all
it's like
you
guys
need
are
to
just
do
like,
is just show how it works. Show how it works. All right.
yeah, just show how it works.
All
I mean,
right,
what if they
do
would
you-
have told Copernicus that? Copernicus, just show us how it works, or else we're not going to. It's just ridiculous.
All right.
It was just
you got
Yes.
somebody from.
First one is from Charlie, who paid me $100. He says, "Oh wow, didn't mean to do that much alcohol percentage over here, but do not send it back. Cheers, mate." Thanks, Charlie.
Thanks, Charlie.
Can you get drunk on every
Dude.
Friday around 3 o'clock? Please come watch my show. I'd love you to do that. Thanks for the stream from Christopher Allen. Thank you very much. $5. Mick MK Ultra from Peyton Longshore. Big fan of yours. $5. Thank you very much. McToon trusts SpaceX. What about the green screen failing during their little space Tesla stunt?
Jeez.
Well,
That
you want to answer that?
all right. So yeah, that green screen was added by flat earthers. There wasn't a green screen. There wasn't an error or anything in the video. There's no green screen there. So
That is true. That there was no green screen there. But let me show you this, and you tell me why this is okay with you. Or remember earlier I was saying that you're like, I don't think there's any problem with the Tesla in space. So this is the Tesla in space here. It's a video. I can press play or whatever. But look at the Earth behind the car. It's coming right about here. Okay. So remember, Elon Musk said the car was not retrofitted for space. The car is exactly as is, sent to space. It was not changed. It was not primered. It was not space readied or anything. But here it goes with the Earth going behind the car, and you'll see that this is the Earth through here. Okay, that's not
wait,
how
through
cars
where?
look. Oh, I'm sorry. You mean here? Look how you can see through it. This,
Oh.
or the front of the car is got nothing in it.
Well, it's not the front.
me
It's
show
through. You mean through the spokes of the wheel?
Yeah, but let me show you what a Tesla actually looks like. That's completely been gutted. It's a piece of cardboard. It's not even real. Let me look up Tesla. What is that thing called? A Roadster
Yeah, it's the. I don't know what.
or sports car? Something. Sportster. Okay.
Elon
There's
did
image-
not send me one, so I don't know.
And send me one here,
Elon,
Joe.
send me one to drive.
Okay, so these are all the Roadsters here, and you can look at any image, and you can see that the tire has brake pads and all kinds of shit behind it. You can never see through it. There's actually pictures of the Tesla Roadster in SpaceX facility or something, and I'll show you that they show a view where you can see that you can't even see through. Come on, give me the side view. There's a side view of one of these where you can see that there's nothing. Okay, here's a good view of this one. You can see that you can't see anything through that. Let me find. There's one that shows it's this view, but it's from the side. It's this view, but from the side. Okay, this is a good view. I mean, you can't even see the ground through the tire from this upper view. You can't even see the ground. Yet in space, we can see the Earth somehow propagating through the bottom of the wheel. It's just not a real car.
Okay,
It's just that
so you're saying they did not prep it for space, or are you saying they did not strip it down?
they did not take a car to space.
No. That wasn't my question. Are you
Oh,
saying
sorry.
that they claimed that they did not strip it down, or they claimed that they did not make it space ready? What was the actual claim?
Elon Musk said that there was nothing done to the car to prepare it for space.
Okay.
The car is exactly as is. He says exactly as. Oh, here's good. This is the picture I was looking for. So you can't even see the white wall behind this thing. Okay. So this car is not the same car, even though this is what they say. This is right here. It says first image of Elon Musk Tesla ready, getting ready to go to Mars. So this car is not the one that they told everybody that went to space. It's fake.
It's getting ready. So I mean, does that mean that was the day before, or they never made changes after that, or?
Well,
I
so
don't-
in order to see what we're seeing here in this picture, which by the way, I've tracked it to make sure that what we see through there is not any kind of reflection. It actually shows up over here on the right when it goes through, right? If I were to press play on this
Yeah.
and watch
Okay.
the Earth go through, you would see
Yeah, you
saw
see the clouds moving behind there. Yeah.
Okay, so it's right. So look how much you're seeing through the car. It's not a real car. I
Jared,
mean, how could it be real?
Jared, do you think that car never existed? Obviously, there's a picture of it.
Yes,
If
this car.
they were gonna fake it, why wouldn't they just fake it with the car that they showed you they were gonna use?
Good question. I don't know. But I think one of the things that they do is they do things so that it's not as easy as what you're looking for. You're looking for something like, oh, I robbed the bank and I just left the money bag on my front doorstep. Like, oh, why didn't you? Of course. I mean, that's not something that I'm going to do. Now with them, they do a bunch of weird things. I can't tell you. I'm not the one deceiving you. But what I can tell you is if you look at this picture that's on the screen now, that this picture would be impossible if the car wasn't gutted.
All right, so
But
they gutted it. Why is that? Why is that a problem?
So after the image that they took in the shed here, then it was space ready. So just Elon's just wrong and
I don't
making things
know.
up.
Why not?
Never mind.
Why is that such a thing?
Because
is
when
that?
I say that I think that they're faking it, and then I'm able to show evidence that clearly this is not a real car that's on the screen right now. That's not a real car.
Why is that not a real car? They could have taken
Because
the
it's
brakes
got
out.
nothing underneath the hood. Everything's gone.
Why could they
pads-
not have done that? Why is that not possible?
Oh, I think that that's what everybody would think would happen, right? If you're going to send a car to space, you would have to primer it with. How do you think that paint would stay on there, McToon? You think the paint on a car
Yes,
could withstand?
100% for the couple hours that you saw it. Yes, no problem at all.
Why not? The radiation, you're telling me the radiation, everything hitting this car, the temperature would be. Now, granted, there's no air, so you're just talking about. But if you go touch it with your hand on the car, it's going to be hot,
No,
right?
no,
Why
no,
not?
no. That's not
Why?
how physics works. There's not enough
Okay.
particles.
In the car.
So in the thermosphere, right? That's where I don't know exactly how far away it is.
But is the sunlight hitting the car? So does sunlight heat up things?
All right, hold on. I have right here. I have the book that my kids use for science.
Really, rather than have these
all right,
conversations
hold
with you, I should just have a conversation with the book. We just could get the book.
But
to
all right,
join
no,
us.
this I was reviewing this. This actually talks about oh crap. Oh, I have stuff in it. Fell out. Hold on.
Money.
No. Receipts. I had all my receipts in my wallet, and then I'm like, I need to empty my wallet. So what do? I put them in this book. Anyway, so bad move. I gotta. So all right, in this book here, right here,
Mhm.
Exploring Creation with Physical Science. This is 8th grade, 7th grade, something like that. It goes over the thermosphere.
Religious book.
Yeah, it's a
wow.
homeschool textbook by Jay Weil, Dr. Jay Weil. He's on. I friended him a while ago on Facebook. You can find him there. Now I'm not a young Earth creationist, and this doesn't talk about it very much. But
So you think the Earth is old?
yeah.
How old?
How old?
are you?
Very old it appears. So that's all. I
Did you see the article that they're changing it from 13.8 billion to 26 billion?
Of the universe or the Earth?
Universe.
Well, we were talking about the Earth.
Oh, sorry. The
Earth.
is-
Earth, as far as it's not my specialty. So, all right, hold on. I got some receipts to pick up. All right. Hopefully the tax man never wants to.
Are you just showing me that the temperature of the car would be just perfectly fine? Everything's fine.
No, the temperature of the car would be actually kind of low. But
Cold.
when it's yeah, it's because the thermosphere, the average temperature of particles is high, but there's so few particles that it doesn't have enough to heat anything up.
What about the stuff it's hitting the surface?
The stuff that's hitting the surface. What stuff?
The sun is hitting the surface of the car, is it not?
Yes. Yeah. Yes.
Does
So
that
that'll
not
warm it
heat
up.
something up?
That'll warm it up. Yep.
And the paint would be fine. I mean, you can't
for the
leave a
amount
car
of time.
outside-
Yeah. Yeah.
You can't leave a car outside, and I mean, a car will start chipping paint at 140, 130. Right? It's not going to get that hot. It's not going to let it get that, or it's not going to be able to withstand.
At
it.
104 degrees of paint will chip off.
140. I said 140.
140. Okay, I don't know.
Well, they say it's like 250 on the sun side up there.
Okay.
How would the paint stay on the car? How would the tires not explode?
Why would the tires explode?
Because there's no pressure in space.
Okay.
Okay.
Jared.
Well, that's why they would explode.
All right.
Oh.
Have you ever put you've put air in a tire, right? So if the tire is rated for 35 psi, have you ever put more than 35 psi in the tire?
Yes.
Have you ever put 40 in a 35 psi tire?
Probably.
How about 50?
Probably not.
Probably not. I have.
Okay. It was fine.
Accidentally. I put a lot more. I'm like, I think I did this for too long, and I got the gauge. I'm like, oh, that's way too much. So I brought it back down. So the pressure differential between 35 and 50 is how many? 15 psi.
Okay.
So the So that a normal tire can maintain a pressure differential of 15 more than what you normally would put on it. So so you could do the same thing. You go to space where it's, rather than having 15 psi pressing on it normally, it's 0, close enough to 0 that it's essentially 0. So it's like putting 15 psi more in a tire. It wouldn't explode.
Oh my goodness. So why don't they just make astronaut suits out of tires then? We'd be all set.
Well, tires are a bit cumbersome and thick.
So you really think that a tire wouldn't pop in space because
There is no question that a tire would not pop in space just because
Oh my
it's
goodness.
in space. That's a simple application of physics, Jared. It's not
the,
that.
the pressure in a tire
Go try.
it has nothing holding it in. There's no pressure holding it in. What
Yeah,
is holding it in?
On the inside of the tire is holding it in.
And
The physical wall of the tire is holding the air in the tire.
so why do balloons pop when we send them up?
Because they expand a lot more, and there's
Well, isn't the balloon holding it in?
but they're not rigid. Tires are rigid. The balloons pop when it gets too big. It's designed to do that usually.
I don't know what's designed to. I just think that's crazy. I think that a tire would pop in space. We're in a vacuum chamber, and that's not even like space. So
All right,
Anyway.
we
all right, we're
Jerry.
good. Oh wait,
we
let me.
Jerry,
Sorry. I'm done.
We Jerry 1SM. We Jeranism. It's not we Jeranism. This is all right. Can you please ex Jeran? Why is so weird about men having tattoos of men's names?
I just think it's very weird. I think that the only people I can think of that have men's names tattooed on them is
No, but
people-
why is it weird?
Right. So because
Why?
the only people who do that are for their savior. I've seen Jesus tattooed on people.
Uh-huh.
It's because that's their savior. So when somebody has Newton and Galileo and Sagan's names on them, number one, if I had men's names on my arms, I doubt my wife would be very attracted to that. I can't picture her being like, "Oh wow, that's sexy." You have Sagan's name on your arm. I love it.
Dan is not married to your wife.
Thank God.
He's married to his
And-
wife.
You sure? I'm sure
Yeah.
she's real pleased about it.
Yeah.
And then you've
Pretty
got yeah, so that's my problem with it. I just don't understand why it's a very religious thing to do more than it is anything else. So it's just a proof of religion, I guess.
To you,
It's
but
like-
but to somebody else, it could be, well, I really admire this guy, right? Do you have
Right,
a
so I asked
person? Do you have
you know
a
anybody
person
else?
that's a hero of yours?
Zero. There's no men are even role models.
No.
Certainly not. Myself,
so
that's hard
for-
to be a
for
role
me-
model.
One of my heroes is William Wilberforce. Now, I would
That's not
not.
a real name.
Yes, it is.
William Wilberforce?
Yes.
Well, his parents are losing it.
Do you know what he did?
No.
He was the guy responsible in England for stopping the slave trade.
The slave trade of the
In
Irish?
England.
Ireland?
England.
Oh, gotcha. Okay, gotcha.
He was the guy that through some things that he did in the government there made it illegal to do slave trade.
All right. So you have
So-
a he's your role model. Anybody else?
So, hero. Yeah. How about
Hero.
that? Steve
I don't
Jobs.
really- All right. I don't know. Will Clark had a great swing for a left-hander. If that's about the level topographical plane. Keep up the great work, Jeran. Thank you very much from Joe Mayer, 66. Jeranism, Google Dark Matter NASA and scroll down to the NASA Science for Kids article. Trust me, bro. And the globe sits on a throne of assumptions, says a nominal. There's a lot of
And I mean, we went over that. You asked me, what about this? What about this? Right? There's always a reason for the next one. It's not an assumption. It's a measurement. It's actual science that was done to get the next level down.
it's not real science. It's not actual. You can't just guess about things in the sky and call it science.
It's not a guess. None of these are guesses.
Okay. They didn't guess that Venus was the same size as Earth.
Well, okay. When you have a hypothesis, as Feynman said, you
he's got it
guess, right? You can guess, right? But then you do the actual work, and then you find out whether or not the guess or the hypothesis is correct or not. So, but when you're doing the next step once you've confirmed a hypothesis and you've done it confirmation, hopefully a bunch of times in different avenues, that's not a guess. So you can guess that the size of Venus is a certain size and use that size to measure the distance to the sun. Okay, that's a hypothesis. You run it, you get the number. You say, okay, well, there's our number to the distance of the sun. Is that right? Well, you use that and then you do a different way, right? So there's other ways that people have measured the distance to the sun, and it fell in line with
in like the distance ladder. You got to believe in these standard candles. Like it's not. It doesn't
there's
like
no
bother-
standard candles to the distance to the sun. That's distant
No, I'm
stars.
saying for the distance to the stars, there's a standard.
Yeah,
there's
we're
the-
talking about the sun.
I don't care what you're talking about. I'm just saying that I think it's embarrassing that you
It's
can
not.
just call that
It's
science.
not guesses, Jeran. It's not
A standard
assumptions.
candle is not a guess.
No, it's based on real work.
But do you understand that you have to actually measure something to get the real measurement?
Yes, there were measurements involved.
So the tape measure, they went to the stars.
No, that's
it's
not
not
the
around
only way to measure things, Jaron. You know that.
It's the only way to confirm measurements.
Don't do that, Jaron. You know that.
The only way to confirm measurements. How would you ever confirm that a measurement is right, or it's just somebody making shit up in their head?
It's not made up. It's based on real work that people did, Jaron. It's not just
So-
guesses.
Let
Don't
me
say
tell you
that.
that.
Just like I keep.
No, I
saying,
will say that.
You didn't.
A neutron star, but a neutron star weighing whatever it is.
You talked about
77
this last time, Jaron.
Yeah, but I'm asking you, there is no way to figure that out. It's just numbers, and they had to place a number on it. So
it's
that the whole
it's
thing
an
worked out.
application of the physics. It's based on other things. It's not guesses.
Oh my goodness, it's so funny to me. It's just embarrassing, really. It's like
But it's Jared. Go look up the actual process that they used, and
will.
tell me where the guesses were.
everywhere.
No.
How would you start
No,
out?
go
with
do it. No,
getting-
you didn't do it. You didn't do it. Go do it. This is assignment. If you want to talk about neutron stars again,
I don't.
I'll be happy. Okay, then don't
Never
look
talk
it up. Then don't talk about it now.
Oh boy. Anyway, yeah, he showed me this. It's just a kid's page from YouTube. I mean, from NASA, basically saying we don't know what anything is. This might be a surprise, but we don't know what most of the universe is made of. Seriously, we don't. You might be thinking, but of course we do,
Okay,
but we
yeah.
don't.
Like we said earlier, pop science articles.
Not fun. All right, and then let me check on Rockfin, and we'll be good. There's no more questions for me. That your crowd's easy.
Is that it? Oh my gosh!
Or
You,
super chats, yes.
Yeah,
Well, how much
you-
did you make? Probably $700 or something.
well,
I got
plus,
$32
I mean, Neil deGrasse Tyson stopped by earlier today and gave me a big fat check.
Neil deGrasse Tyson's not being paid. Come on, the guy's too stupid. Too bad. He helps us out too much. You guys cannot like that guy.
He's wrong about stuff, just like
Okay, I was gonna say,
everybody
it
else.
gives you more headaches than anything, probably. Let's see here. We got may intellectual honesty prevail. Thank you, Hubble's whore. I think that I tried to make it. I didn't want to. I think McToon should a lot today. That's all I'll say. Jason Bowles, thank you very much for 10 bucks.
Wait. Did you not read something?
Where
Don't
at?
pull any punches.
What did I miss?
I don't know. It sounded like you summarized something that was too mean. It's okay.
Oh, that was me talking.
Okay.
May intellectual honesty prevail. That was from Hubble's whore. Thank you very much for the 10 bucks. Jason Bowles, thank you very much for 10 bucks. Luke, thank you very much for the $5.
Okay.
Fishhead Montana, where you been? I haven't seen you in a while. Says, does McToon believe that every one of our observations shows the perfect refraction to negate curvature every single time? Thanks, Sharon.
To negate curvature. No, not at all. But the majority of observations show curvature very easily. Yeah. When I was in Pensacola, super. Yeah.
And you think that it's okay to be like, oh, so we're missing this much from this item. Well, let's go turn Walter Bislin's dial up until we can see it appear, and then that's good.
All right. Go to my website, mc2.net/refraction. Read the different measurements, not guesses. The
Yeah, but let me
measurements.
explain what you did, and you tell
I
me
didn't
if this is what you
finish.
did.
I didn't finish my sentence.
Okay.
The measurements of refraction in different conditions, and the coefficient of refraction that they measured in those conditions, and then find the similar conditions, because if they don't measure the actual lapse rate, you don't know the actual coefficient of refraction. You have to use previous measurements to get it, and then use those and put those into Business Calculator.
So I watched a bit of an episode of you doing it. Somebody came on or called in or something and said, we see too far in this case. And then you went and got an observation of that thing.
Yeah.
And then you went and pulled it up on Walter Bislin's thing. And then you moved the dial until you could see it and then said, see, we don't see too far. That's what you did.
So let me give you an example. At low elevation on a cloudless day, a coefficient of refraction of 0.5 is very possible.
0.5
At
is what?
0.5 coefficient of refraction.
You mean like usually the standard refraction is 7/6?
The one that the standard refraction that you're talking about is
7/6 of the radius. Right?
0.167.
So it'd be about 4 times that amount.
Yeah.
Okay. I mean, it is.
And
but it's
so
point.
so I went to here's a NIST certified thermometer.
Okay.
So it's certified by NIST so that it's accurate within a certain range, right? So, I took that and I measured the vertical temperature gradient on a frozen lake in Minnesota here, and to actually measure the lapse rate, right? And I've only seen that done a couple times, right? At Lake Ballatin, they did that, and so you can actually use that. John D did it again in Brighton, I think.
Okay.
So.
Yeah. All right. I believe that's what we Official Antenna also said McToon was right once. Hashtag McToon was right once. When was that? Tonight?
It's happened more than once. Come on.
And one time, just because I asked this again this week and I still haven't gotten a good answer. So just so I know, if I took a balloon of hydrogen, helium, whatever, and I made it as big as the Earth and I released it up into space, it would never break. The balloon would stay, and then it would pull all the gas to the middle and become a star or planet.
Far from Earth, like nowhere near another mass.
Well, no, I mean,
well,
it's hilarious because you guys
when we say
shown.
In space, do you mean like just above the Earth, or do you mean far from anything?
Let's say we take a helium balloon up, right, and it's got helium and it's as big as a Dwayne Kellum's. We know when it gets to about 120,000 feet, the gas is going to expand so much that it pops the balloon, right?
Okay.
So no matter how much gas we put in, you would think that would mean that it would expand more, trying to get out more. But actually, the belief is that you have that if we make enough gas, that it stops going out and it says, now I want you to come to me and I will be a star and planet and I'll be Jupiter. And
yeah, that's how gravity works.
Okay.
Gravity is empirically confirmed.
It's empirical.
All right, I got Astronut 66 is something for you.
Oh,
he says, how on flat Earth can we have an equatorial radius, which is the distance from the North Pole to the equator, of 6,215 miles, and also an equatorial circumference of 24,901 miles?
I don't know. I would not claim that the equator is that distance. I think it's less, 21 probably, but I don't know. Again, I'm not going to make that claim because I just think it's less. Does that answer his question?
Dude, I mean, you did, but you could do the math. You could do the math.
What do you mean do the math? They could apply a number to the distance around the equator.
No, it's not.
They could. It's impossible. They can't
not
do
applying
that.
a number. It
has to be the distance that they measured. They measured that distance, Jeran, with a plane, and they drove around in a plane and measured the distance of the equator. It's like, I don't know how you people believe these things.
Real people, just like you did out in the field. Real people went out in the field and did real work.
Measured the equator, just went across the water and everything, and just measured it.
No, there's more.
Seems weird.
This isn't like kindergarten measurements. This is,
real world. Right? They measure very close.
It's not the only way to measure thing is not take a tape measure to it. There's other ways to measure things. You know that.
Like what? You mean like triangulation with these?
Certainly one way. That's how surveyors did their work for centuries.
Yeah, from the top of mountains, and then people say there were spherical excess, which is like a joke.
Certainly, there is spherical excess.
How, if they're on top of mountains, that's a straight line between them and the guy that they're lining up to. That's
Yeah.
not a right. And then a straight line from the guy that he's lining up to. That's a triangle. It would never have more than 180 degrees.
But it does, which
In
falsifies
theory, when you draw
which
it on Google Earth.
No, which falsifies your hypothesis. They really did measure more than 180 degrees in those triangles.
How is that possible? If three people are on a mountain,
Yeah.
and they're measuring to each other,
Uh-huh.
how could the triangle have more than 180 degrees?
Because they're not coplanar. That's how.
Right, because you've assumed that. That's
No.
assuming you're-
You asked how. I answered how. So in reality, they measured more than 180 degrees.
How
And
is that
so then you
possible?
say, how is that possible? Well, if they are
How-
not coplanar, it's possible.
What do you mean coplanar?
Coplanar. So that coplanar would mean coplanar would be they're all in the same plane. Not coplanar would mean they're not
Right, but you've
in the same
assumed
plane.
that. You've
No,
assumed
I-
that. Measured that.
No, you asked the question, how is it possible? The answer to the
Right.
question is they're not coplanar. That's
So
one
how do
way
we know that,
that
how do
they
we
could
know that
measure
going
them.
into the measurement
How do they know what?
that it's not coplanar.
Going into it, you don't necessarily know that. You just do the measurement, and then if it adds to 180 degrees, well, that is evidence for planar. If it adds
This
to
is
more
more-
than
more
180
examples
degrees,
of, like-
that's evidence for not coplanar.
That's like I don't think you're like listening or that you think everything's so right. You're like you don't ever have to question any of these things. If you have a circle like this, you have a sphere, right? You can see this, yes.
Uh-huh.
And we've got mountains. Okay, so for instance, here you've got a. Oops, let me get my pencil here. So you've got this is like a little mountain. Come on, give me a color that works. Okay, so this is a little mountain here, and this is a little mountain here, and this is a little mountain here.
Uh-huh.
And you're going to tell me that the three people on top of these are going to measure a spherical excess. But if they're measuring to each other, then they're just going to have three straight lines. And it's impossible that this triangle would ever have more than 180 degrees.
Jared.
It's not on the surface.
Spherical trigonometry has been around for 2,500 years.
If you're talking about the surface, yes.
So not understanding spherical trigonometry is fine. It's not an easy concept. It's typically not
But
taught in high
you're
school.
having to assume that you're
So-
on a
so-
sphere.
so
to do
hold on,
spherical
hold on.
trigonometry. You're not talking about measurements. You were talking about measurements.
Yes, and so you
Okay,
do
so
the
if you
measurement.
factored
You
in-
you know they could not factor it in. It would
then
create
look
all
at my
sorts of
drawing.
errors.
These three people
No,
would do
but you're
straight line
drawing,
observation.
Jared. Your drawing is not good.
Well, it's on mountains. That's why you're used to seeing them draw it on a sphere. These are the little tricks that they give you that you feel like are
right.
like but they're not.
Jared, explain how they actually really measured more than 180 degrees in those triangles.
Because they assumed that they're on a
No,
sphere.
there's
They're-
no assumption. That's just the measurements. So they do
What are
the
you talking
measurements.
about? How would-
You sum the triangles, you get more than 180 degrees.
Okay,
How did
that's-
that
if you're
happen?
on if you're on the surface of a sphere, then if you measured a triangle, you would have more than 180 degrees. But that's not where they were. They were on top of mountains. So the angle, the line that you draw between another person is a straight line. It's not on a sphere. Well, if you think about it, you can laugh all you want. It's just because you've never thought about it, and it's like
Jared,
painful.
Sharon, I've thought about it plenty.
Okay,
Don't
but how,
tell,
how far apart were
don't
they?
tell me I haven't thought about it.
How far apart were these guys who were measuring from mountain to mountain?
Some are more than 100 kilometers.
Okay, so we're talking, let's say 60 miles, right? 60 miles between three peaks of mountains. Think
Yeah.
about three people getting on three mountains, each 60 miles apart.
Yeah.
If they were looking at each other, they would not measure more than 180 degrees.
But
It's
they
impossible.
did. But they actually did in reality.
Oh! I'm gonna go hang myself. That's what I'm going.
Jared, they really did measure
I know
more
you
than
think they really did, but I'm even explaining to you how it's impossible that they did, and you're like, no, but they did. Explain how
All
they
right,
did.
Jared,
That's my
it's not impossible that they did.
if you're on top of a,
It's only impossible if the Earth is flat. It's totally possible if the Earth is a sphere.
no, if three people are on top of mountains observing each other, you can't have a triangle with more than 180 degrees because they're on top of mountains. Where are they measuring the spherical excess?
They're not coplanar. You are presuming
be-
that they're coplanar. They're
You
not
have to be on
coplanar.
you have to be on the surface of a sphere. Correct?
You have to be not coplanar. So
Yeah, but they're
on look at if the Earth were flat, then if you're on different mountains, obviously if you're on different elevations, you're not truly in the same plane, but you're parallel to the same plane. Right?
Okay.
I
guess
if you're on the surface of the sphere, right? This is the same thing as the celestial navigation, right? You should. I don't know.
Not the same thing. Let me show you why.
I guess you can't.
One thing, then we're done. So I'm just showing you. This is Google Earth. This is a little. Let's just pretend we have 3 people on mountaintops, right? So when we draw a line between 2 places on the globe, it includes the curvature. So if I were to draw a triangle, if I go path and I go here to here, hello, and then to here, okay, and then to here or whatever, then draw my 3rd line. Come on, what's going on? Did I do path? Oh boy, this thing's all screwed up now. Let me go like this and put this one over here. It's whatever, it's triangle. Okay, so this one here. Now, if you get down and you're looking at you're on the surface of the Earth, then you would have a spherical excess. But not when if these 3 people are on mountaintops and they're observing each other from 60 miles apart, how would there be spherical excess?
I know you did you see the Brian Leakey video? Is that where you got this?
I don't know. Brian Leakey. Oh, the space audits? I mean,
no, he's a flat earther. He actually got a globe, but he put some sticks on it and he connected it with strings.
Right, okay, so what's wrong with that idea? I think I got it from QNFE, to be honest with you.
Wait a second. This is gonna damage our relationship. You actually
No, I went to QNFE because
oh my gosh. I mean there are flat earthers and there's him.
Wow. you stupid asshole. No, what does he always say? What's his words? He says
pizza sheet. All right.
No, he actually claims that during my Monterey Bay observation, we were on one side and then we had a cameraman on the other side, and the cameraman took a picture of the tripod with the camera on it, and then I put it on the thing and he says it was faked. Why would the cameraman fake the tripod picture?
All right. Jim Smith gave a description that might work for you.
Okay, I'm ready.
He said the theodolites are leveled separately with different zeniths, and so when I say that's much better words than non-coplanar, right? So they don't share a same zenith.
That's the cooking of the books. How do you not understand that? What he's saying is, go ahead.
You didn't let me finish. You just jumped in there, buddy. They all have different zeniths. This is, on the surface of a globe.
Assumed, not measured.
Well, no, but then they do the measurement. And the actual measurements sum to more than 180. So that confirms that
each of them have different one. You're not getting it. They go in with the idea that they're on a sphere, so that they think they have different zeniths, and then they calculate that in, and it gives them excess.
But they don't use the zenith when they're doing the azimuth measurements.
Right, they're measuring to each other.
Yeah, they're doing azimuth measurements, and they're summing to more than 180.
No, what do you mean azimuth measurement?
But they are. An azimuth is a horizontal angle, and a zenith measurement is a vertical angle.
So you're telling me 3 people 60 miles apart each make a triangle, and there's spherical excess, and they're on the top of mountains?
Yes.
You're confused. You don't even know you're on a sphere. How would you know you're on a sphere?
Jeran, dude.
How would you even know you're on a sphere?
Hold on.
So what's wrong with Brian Leakey putting 3 things on a globe and then showing that the lines between them are straight?
Because he didn't get the coplanar, non-coplanar part of it. So hold on. Let me say this, Jeran. Jeran, hold on. Let me say this. You get the celestial. You get the problem with celestial navigation for, the people for this guy. The guy I'm talking. Don't say his name. This guy.
Now I'd like to know how my balls taste.
That guy, right?
Well, hold on a second, real quick. I have to play an advertisement. I didn't know I had to play this, but I was told.
What?
I have to promote. I have to promote his show as often as possible. I was told. So
whose show?
You know whose show? This show.
The guy that wants.
Stop. Scammer time. I am Nathan Oakley, and I am always right. Destroying my opponents, well, cause I'm their mind. So why would I ever stop my simple grit? I'll go after flat earthers when my views could use a lift. Now I can feed my girls from the money that I make. I'm a scammer, no man, it's Nathan Oakley. I don't matter. Every day on flat earth debates. Can't trust this. Yeah, chocolate. I'm a homie. Can't trust this. Hemp man, lift your head up for a second. Boy, you can't trust this. Golem, nice morning show this morning. What is it? 3 viewers? Nice. Gaming zone.
I love this.
Every day at some time in the morning, Flat Earth debates be there. Never the same show. It's always different. It's so crazy.
It's
Now we're back. Sorry, I had to play that ad.
all right. Yes, I appreciate
Contract.
that.
Contractual agreements I've agreed to.
Anyway, so what was this? Okay, so they misunderstand celestial navigation, and you get it. You get how it happens on a sphere.
It can't happen on a sphere.
So I think you can grasp how this
I
works.
understand spherical
on a
axis
sphere.
when we're talking about a sphere. If you draw lines on the surface of the sphere, and long lines, like you have to draw them pretty long to get,
To get a huge amount of spherical axis,
Right,
but
yeah.
but they're certainly within the margin of errors on for the measurements on especially the big ones.
just to me, I can't picture 3 people on a mountain. They're looking at each other. Unless you've assumed that you're on a sphere, you could never have spherical axis because you're just going to have a triangle. It's a sphere as it's not really a triangle, right? If you look at a sphere and there's a triangle on it, you're like, yeah, well, it's got like bowing sides, and okay, it makes sense that there's more than 180
but I mean, spherical trigonometry exists, and
exists
there are
on a sphere.
definitions for how you draw triangles on a sphere.
Correct. So they're
Right.
making the assumption that they're on a sphere.
Well, except when you actually do the measurements and you get more than 180, it tells you something.
But they're just straight lines. How do you have straight lines? 3 straight lines make a triangle that can never have more than 180. Ever.
Yet they have more than 180. There's something
Well, because those
There's-
are curved lines on your globe.
because Jeran, there's something you're not quite getting.
I'm not getting that.
So-
You guys are assuming that you're on a globe, and then you're making all the observations, and then you're calculating it within the globe paradigm.
Hold on, Jared. We just talk about the geometry. I just want to try to help you here. People that really understand geometry way better than either of us are like, oh yeah, there's no problem at all. And you're like, that doesn't work. And so maybe there's
have
something you're not quite getting about how it's happening.
Or maybe
And
there's something
I
else quite-
think
right?
and I think that because I'm just talking geometry, I'm not talking about the measurements yet. And I think that you could probably you can understand it because you got the other one.
I get it. On a surface of
Okay.
a sphere, if you were to draw 3 lines, that triangle will always have more than 180 degrees
Yes.
on the surface of a sphere. Okay.
Yeah.
If you're not on the surface of a sphere, then the 3 lines that you draw are straight, in which case you can never have more than 180
No,
degrees on a
but-
sphere,
but-
on a
but-
triangle. So the difference is, I know that we can't do this when talking. Let's say we have the 3 people, and one's on the North Pole, and one's on the equator, and one's on the equator at the other meridian. I understand that those are not straight
Oh.
lines. They cannot measure straight lines to each other.
See,
So you would have to be on the curve.
PC Tony put different words, and I don't know if it's going to help, but you measure the azimuth angles orthogonal to the zenith. Does that help you?
Again, he is assuming that they're different.
Or we're just talking
Zenith.
about the geometry. Just geometry.
Okay, and he said that we say again. He
You
measures
measure the azimuth angles orthogonal to the zenith.
right. Okay, well, how is so? So now they're at. Why not just do the straight line distance between the 3 people?
With straight line angles.
Sure, you can make a triangle from
That's
3
what-
people
that's
that are
what they're
60
doing.
miles apart.
But they're still the azimuth measurements are still orthogonal to the zenith.
Yeah, I don't really understand. I mean, I told you the same thing about Jesse Kozlowski. This will all be out in probably your guys' lifetime, and you'll all feel bad, and you'll never admit that it was me who told you all these things. But you have to remember that when Jesse Kozlowski measures angles, he is assuming that the zenith angle has changed. He's not measuring that.
What? I don't know what you're talking about.
If Jesse Kozlowski is doing an observation across a mile,
Okay.
he assumes that the item is dropped in the distance and that it's angled away from him. He's not measuring that. He
How is
assumes
how is he not measuring that?
because he's only measuring drop.
Okay. And if it drops, if 2 things are at the same elevation
Mhm.
and there is a drop, then
Right?
what does that mean?
Things in the distance get smaller. They go down. You've
But if
actually
they're
proven- I
if
told
they're
you-
at the same elevation,
no,
then-
I've actually
then the
remember I
same
asked you to
elevation.
Take your camera and zoom into something in the distance, and what happens when you zoom in? Remember, the camera goes above the item.
oh, the
Did
thing
you showed it?
the thing that's in the same straight line stays in the same straight line.
Not true. Sorry, not true. Not true. And I know you want to believe that, and you have to believe that. It's just like you have to tell people that there's no bottom-up obstruction. There's no mechanism for that, which is completely wrong. There's many examples of it. You just have to say it. I get it. It's just it's against your religion. I guess.
Jared, come on.
All right.
That-
I got enough. Let's go. It's getting too late. I gotta go have some fun.
All right. Well, good luck.
Maybe we'll do it again. Maybe not. We'll see how you're. But thank you. I appreciate it. I don't know if we got anywhere. If I were you, I'd take down the Bible page. I'd take down the compressing of images page. I'd take down the anti-flat or anti. What is it? Anti-scientific method, because you do have Michio Kaku who says nobody in my field uses a so-called scientific method. Nobody in his field.
Do you know why he said that?
Because that's, I don't know. It's the
because nobody does use the middle school scientific method that
right.
you know.
And what do you call? What is the definition of pseudoscience?
Non-falsifiable.
No, look it up. The definition of pseudoscience is
Oh,
things
hold on.
purported to be
I've got-
science. Okay, I'll wait for you.
That are not science.
No, that do not adhere to the scientific method.
No, that's not it. Right here,
Look it
read
up.
this. Chapters
I
3
don't
and
care what
4.
Karl Popper says. That's not the defining.
3 and 4. Chapters 3 and 4.
Which book is that?
The logic of scientific discovery.
Let me look up pseudoscience just so I see if I'm right.
Chapters 3 and 4.
Pseudoscience, according to this, a collection of beliefs or practices mistakenly regarded as being based on the scientific method.
Yeah.
So
that's
all-
not where
Wow,
that's
okay.
not really that's not a good
Right,
definition.
of course, because it just proves what you guys are doing. So I get it. Can't do that. It's got to be something else.
But
It's gotta be-
to be clear, the scientific method is hypothesis, test, hypothesis, test,
right.
hypothesis.
So they don't even
test.
do that in string theory and theoretical
String
physics.
theory pretty much is pseudoscience.
Okay,
Yep.
good. I'm glad you admit that. All right, great.
Yeah.
But also, so then many of their other theories are kind of come to the same way.
And all of the zero comments I'll get from the string theory proponents, I look forward to it.
There's not-
Actually, I
Michio Kaku
there's
might show up. And
there's very few people that are. I mean, like
I think it's just
big
Michio
in this.
Kaku.
it's
But,
probably just him. Yep, probably just him.
There's 11 dimensions of strings. You know,
I watched a video trying to go over that. I'm like, oh,
It's so bad.
man, that's
I was going to make fun of it once. and I
that's
was like,
pretty
it's too-
sloppy. But anyway,
It's got no science behind it. All right, thanks, McToon. We'll see if we'll do it again. I don't know. I probably have no energy left after this. It's just frustrating.
all right, Jeran. Well,
All right.
it's
Later.
been real.
Thanks.
Okay,
Appreciate it.
bye.
Peace. All right, everybody.
All right, let me get him out of here. Boy, I got about a bunch of super chats. Yeah, all of his stuff, the things he brought up, none were related to the shape of the Earth. That's what we get with flat earthers. They do not want to make their case for the positive claim about what they think the shape of the Earth is, because there is none. Whenever they go out to try to apply the anti-scientific method, they never get step 2 to work for them. For real, right? When they're like, here's the map. Like, oh, well, that doesn't work. Well, never mind. That's not our map. We don't have a map. What about, what about why does things fall down? Oh, it's this. Well, that doesn't really work. Oh, it just does. That's where it wants to be. It's its natural place. So, I don't know. See, Jeran does get celestial navigation. That's what's frustrating about spherical trigonometry that he did not get. I don't know. I don't know if he can or cannot get it. So, I hope he can. Do you get this? I send all day on Facebook. If somebody asks for something, I'm always sending. They're like, what about measurements of this? Here you go. What about this? Here you go. I give them links to my website. Nobody ever comes back saying, oh, well, I read on page 4 of this, something, something. It doesn't happen. Jeran has. Take that for what you will. Jeran is one of a few have, to be honest. Jeran is one of the only ones that has actually looked at stuff and tried to analyze it. So that's significantly higher than pretty much any other flat earther. And he's still wrong. And it's all interesting. But anyway. How can we have, this is as Astronut 66, how can we have an equatorial radius of 6,215 miles and an equatorial circumference of 24,901 miles? That's a problem. And he's like, oh, I just think it's less. That doesn't work. He's like, well, they didn't dig a tape measure. That's not the only way to measure it. All right. Patrick Butler says, we all know they are sitting on water mountains. Thank you, Patrick, for the water mountains. Chai says he looks at stuff, then completely dismisses it and comes up with some lie he made about it. Or misunderstanding. Yeah. So he thinks, he kind of hinted at it again, he thinks that things just appear lower. Just because that's what happens. Just does. Stringer's one, when are boats not floating? Well, there's a submarine that's, never mind, too soon. PC Tony says a form of evidence is sometimes flawed doesn't mean it's always flawed. Jeran requires all observations be perfect. That's not science. Yes. Well, all observations except the ones for flat Earth, because there are none. Right? What are the two things? There's only really two things that flat earthers ever try to point to for evidence. Finding a non-perfect globe bottom-up obstruction, and finding and sending up a balloon and finding a 15-second clip of the horizon slightly below the center frame. That's their two things that they basically only ever refer to. So he totally dismissed the line compression that you showed. It was right in his face, and he's still stuck with what he believes. Yes. Yeah, he's trying to hand wave dismiss that. So that's the thing. Jeran, if you don't like that, then that's not the evidence for you. Spherical excess would be it. But you don't understand it. Right? And he's going with Austin's just, the claim from Austin that they're claiming that they baked it in. Well, where did they bake it in? Be very specific. Where was it baked in? Because when you look at the actual numbers in the transcontinental triangulation and the American Arc of the Parallel, the survey across the United States, where they had the spherical excess, what they do is they go to, at one point, a station, and then they measure the azimuth angles to multiple different stations from that location. They just give the azimuth. So they're just, here's the angle between these two, this mountain here, mountain 1, mountain 2, right? And then you have mountain 2 and mountain 3, right? Or not actually that. They just give a number. They say mountain 2 is that direction, mountain 3 is that direction, mountain 4 is that direction. That's it. There's no opportunity to bank anything in because there's only 360 degrees in the circle. So when they look at that, the angle between, they then get the angle between 1 and 3, for example, and the angle between 2 and 3, and the angle between 2 and 5. And then they use that and they put that in to the rest of the system. Well, where did they bake it in? They would have had to bake it in before they did these numbers. They would have had to come to the peak of that mountain with the known mandatory numbers already pre-calculated. That's the only way they could have baked it in. And even then, it would not work, because if they weren't doing the right numbers, if the Earth was actually flat and they put the wrong numbers in for the azimuths, then all of the triangles that they used to calculate to measure the lengths would all be wrong, right? This error would propagate through the system, but they didn't come out to the wrong numbers. And the reason why they know that these numbers didn't come out wrong was because at different points along the survey, they did physical measurements of the lengths. So when the survey started out with a physical measurement, sometimes it's a chain. The chain is specially designed to not expand in heat. but some of the others are different. So there's one in California where they used these long 3-meter long bars that are made of a particular metal that doesn't expand much at heat, but also has a thermometer on it, so you can get the expansion. They did it under a shade, and so they actually physically measured the length of a line of the triangle in both directions. Took months to do. And then they used so they did then they did the survey across triangle, 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 triangle. And then they used the result of all of those measurements together to say, well, what this triangle must be. And it's all based on all this, if one measurement's wrong back there, it cascades up. And they get the number correct to within like 2 or 3 centimeters. So if they were baking numbers in, they wouldn't have a correct length for that side that they physically measured with a tape measure, basically. So, so yeah, you could not bake it in because it would create errors everywhere else. It would also be pretty stinking difficult to bake in because they would have had to do all the math for it before doing any measurements. So they would have had to pre-calculate all the mandatory fudging, right? And to a person like Jeran and all flat earthers who don't understand the math, you just say, oh, whatever, wave your hands, math. They could have done that. It doesn't work that way. So. Okay. Let me read a few more here. PhD Tony says he's just preventing you from presenting to. Yeah, he was. His question gets long, and none of the timings did work. Sun Express says, can Jeran please explain how the solar eclipse track of April 8, 2024, cutting diagonally across the United States, is possible with the sun circling overhead? Of course, he cannot. No flat earther has any actual predictions about objects in the sky based on their model. It just doesn't work. None of it works. And I want to write up a challenge. Here's my challenge. My challenge for writing the challenge on the $10,000 challenge for flat earthers to actually produce a prediction of the eclipse is, of course, how do you have a smart person from faking the system, from gaming the system? But how do you measure, right? Everything needs to have a objective measurement. So how do you objectively measure an eclipse prediction and compare it to reality? I suppose you could say, well, a person needs to be in a certain spot, and what time the eclipse will begin and what time the eclipse will end. Well, anyway, if you can think of a way to kind of quantify a objective measurement for a successful way to predict an eclipse, like how do you write that out? Right? I mean, I got the book predicting the eclipse, but how do you actually write that out? I need to write that and put that into the challenge and do it in a fair way so that people can actually, as much as possible, if the earth is flat, this would work. So Serena News 1, quote, "We see too far is a flurf claim. It is not our job to disprove it. It is your job to back the claim with evidence." Well, where's your evidence? And of course, all of the flurf "we see too far" claims is a straw man because they never accurately apply the globe. But the real problem for flat Earth is we don't see far enough. There's no reason from the peak of a high mountain to not see farther. There's no reason to ever have a crisp horizon for flat Earth. So, Melodic Lyric says, can you ask Jeran why he thinks pixels magically change? Oh, for the diagonal. See, he changed that. He really. I'm pretty sure that last time he was saying that because he was going to do it in paint. He was going to draw a line in paint, and then he was going to horizontally compress it. And he was claiming that there was going to be curve. I don't know. Randomly Epic says, first we had $2 Trey, now we have $2 Tony. Oh yeah, because Tony said earlier, and I missed it, for $2 Australian. Jeran did say that his recollection is faulty. So yes, I think that's about the diagonal looking curve. Yeah, I mean it's on video, so maybe somebody will send me the link with the time code already in it so that I can look at it and I can send it. I'll send it to him and say, look, well, this is what you said is, if you did not mean that, okay, revise what you meant. That's fair. Turing Test 2 says surgical deconstruction of every objection. Flurf reset incoming. Yeah. All right. String News 1 says, quote, outlaw everything that proves me wrong. Jeran. He thinks GPS coordinates are wrong. Somehow they were baked in. Like, the amount of baking in that has to happen for Jeran to be right is amazing. The millions of people that it would have to be involved in the baking and faking. And the math necessary for it couldn't happen. But because math is a mystery to him, he's like, oh, well, they just could. So, Baux1 says more intellectual dishonesty. Interesting. PT Tony again says textbook science denialism, cherry pick data, establish impossible standards that you claim science must meet. Yes. Yeah, did you get the book, the science denialism book? I got it on the shelf behind me here. Definitely. Killa Cuts says love ya. Well, thank you. Thank you for that. Let me get the chat on screen here. So there's the chat on screen. Right there. But Jeran's not here. Sorry, Jeran. PhD Tony, YouTube doesn't claim to be a primary historical source. Yeah, he talks about it often. The SpaceX stream that was edited. Okay, so they edited it. Doesn't change the shape of the Earth, right? Is it a bad precedent? Maybe, but it doesn't change the shape of the Earth. This is about the shape of the Earth. So, String News 1, Jeran. Are you resorting to petty name calling because after all these years you still have zero evidence for a flat Earth? Was he doing? Yeah, he did. He said a couple things. He gets a little. He just gets like he's got all these emotions, and then they come out every once in a while. I know he's trying to not have them while I was talking, but yeah, put yourself for a second. Do this, and I've done this. Put yourself in his shoes. Do that experiment, right? Out at night, you did the version 1, it didn't work. You do the backup, you do this, you do all that stuff. He went home like, oh, we didn't figure anything out. And then he watches the movie. So put yourself in his shoes for a second. The ending of that movie to him was brutal. It was brutal, and I can see why, 5 years later, how much it bothers him. It's still there. Yeah, but that was evidence for the globe. So, yeah. Piers 77 Tampa says, according to Jeran, measurements must have psychic powers to give different results based on assumptions. That's a great point. Fantastic point, because yeah, the measurements of spherical excess, measurements don't presume the Earth is a sphere. The measurements could work on a sphere and could not work on flat Earth, but there's no presumption there, right? And he's like, it's not possible. He's talking about the geometry. He thinks the geometry is not possible. The geometry is possible, and it's just that he's not grasping it. I don't know. Work harder. Trying to figure it out. Cinecon says you can stream a pre-recorded video, so I don't get the point. Yeah. See, if that's the thing. Faking. So he says that SpaceX faked at least portions of the video. So wait. They generated some faked up stuff and then live streamed the real stuff with the faked up stuff and made a mistake on the live stream portion of it and fixed it later. If they're just going to fake it all, just fake it all. Here you go, YouTube. Here's the whole faked thing. It's already got everything fixed. It's already in the right order. It doesn't make errors happen in live streams, in real things that happen. If somebody's going to fake it, they're not going to fake in an error and then go back later and somehow get permission from YouTube to do something that is not normally accepted. They would just do it. They would, in their studio, in their video editing software, they would get it right the first time. The budget that they must have and the amount of, people and oversight, all the stuff that they must be doing to get all these things done that way, according to him, there would be no question. It would be all perfect. So, many Karen says, flurfing is one thing, but not liking metal, that's insane. I agree. How could you not like heavy metal? Graybeard says, is it just me, or does Jeran dive into these rat holes as a way of not addressing the copious amounts of evidence proving that the Earth can't possibly be flat? Yes, that is definitely the case. He goes on and on about NASA because it's irrelevant to the shape of the Earth. He doesn't have to discuss the actual failures of flat Earth to do anything. Right, so Siggy's 50 memberships, thank you for that. Then Siggy said, sorry for the long absence, been busy moving to a new apartment. Long live MC Toon. Hail Sagan. Thank you for that, Siggy. PhD Tony, relevance to the shape of the Earth? 0. Siggy Sigwald gave another 50. Thank you for that. 150 total. Siggy, you are a legend. Randomly Epic says, news agencies change live streams all the time. It's not just SpaceX. Yeah, and he's focusing on YouTube. Like, nobody else ever on YouTube has done it. Well, and I did get him to back off on that. Nobody that he knows about. But it doesn't change anything. Right? Whatever part you think was faked, like, he thinks that the part in space was faked. Okay, the other stuff, who cares? It doesn't matter. Because he thinks the rockets actually do exist. How can you think the rocket? Okay, so he thinks that they went up that high and then they came back down and they actually have, those were live cameras, he thinks. But they're lighter? How could they be lighter? How could, because they're obviously burning fuel. There's this big fiery stuff coming out the bottom of it. How could they be lighter? Serena News 1, 2 hours in and nothing to prove flat Earth. Yep, and PhD Tony says space is completely irrelevant to Earth's shape. Well, yeah, in the mind of a flat earther, if they can prove their claim about space being fake and space then being faked by space agencies, then in their shoddy logical thinking, it proves flat Earth. Of course, it doesn't, but it's a non sequitur. If you want to prove flat Earth, or find evidence for flat Earth, you just go find evidence for flat Earth. Go do a measurement, Jeran. No, that didn't work out. Go do it again, Jeran. He didn't do it. I do want to talk to him about, I don't know if he's going to get the math, but I want to talk to him about the measurement he did. And do you think that his imperfect memory of the setup is on purpose or not? Because when I do the analysis, so Jeran did the analysis wrong. He said in the movie, he said if it's at 22 feet or 23 feet, then the Earth is a globe. If it's at 17, then the Earth is flat. He was wrong. The number is not 22 or 23 because he did the math wrong. The number with, as I understood it, was 19 and a half for the globe. And then he's like, well, the panel was in a different spot. Okay, well, it didn't actually change anything for you. So, Siggy says, another 50 for those who couldn't grab one. Hail Sagan. Thank you, Siggy. He says, hey, Jeranism, all 13 episodes of Carl Sagan's Cosmos are available on YouTube. I would suggest that you watch them all and have a talk about them. How about that? We can even debate it episode by episode. I'm nobody. It should be an easy win for you. You know what? I'll send that to him. Is he still streaming? Can somebody check? Is he still streaming? I don't want to send it when he's still streaming. So I'll just take a screenshot of it right now. Siggy says there are 200 or 525 people watching, so let's get as many as possible. Yeah, wow. I think it might have hit 600. Thank you guys. It's very, I don't know. Thank you for watching. I say that. Stringer News 1 says, if the rule is that you must throw the baby out with the bathwater, how come you don't do that with flat earth claims that are proved wrong? That's a great question. Well, they're not proved wrong. They're okay. They're just kind of, they're not so bad. And well, oh, you did it wrong. And yeah, but what about this other topic? Nick N. Does Jeran ever present positive evidence for flat earth? No. No flat earther does. PhD Tony says a theory gets credit for its successful prediction and results, so we allow modification to accord with new data. A theory with zero success gets zero credit. Yes. Yep. To the cosmological constant and how far off it was. It was a hypothesis. It was wrong. Okay. So what? It doesn't mean everything else that was somehow thinly related to it is automatically wrong. That hypothesis was wrong. Okay, this is the edges of science. You're definitely going to have hypotheses that are wrong as you're exploring new parts of science. All right, now Siggy comes in with the 5,000 ARS super chat, and then I'll read it again. I read it to Jeran. It's fairly simple. Scientists observe that the rate of expansion of the universe is off, so the hypothesis of dark energy. Then there are gravitational phenomena that we can't explain in relation to the matter we can measure. The hypothesis of dark matter is formulated. There's strong evidence for both. It takes a picosecond of research in Google. And the thing is, of course, he doesn't quite get the process of science. He's not done science. And he's gotten this kind of weird impression of how science must be because of his flat earth associations. So, yeah. The matter, the rotation of galaxies looks different than we expected based on the matter that we can measure there. So there's something else going on. What is that something else? Could it be that there's particles that have mass that we don't interact with light? Could be. Could it be something else? Yes. Like, could it be that gravity works differently at different distances? Some people have hypothesized that, and to my knowledge, their tests of that don't work. Could it be that there's, I don't know. There's a few other hypotheses for gravitational speed that have been proposed. I don't know. I haven't looked up them. But the thing is, if that's a problem, flat earthers, if the gravitational rotation speed is a problem, there's a whole bunch of stuff that comes before that, right? First, Earth is a globe, and second, it's orbiting the sun, and the sun is orbiting our galaxy, and the galaxies that we're looking at very, very far away, you know, many, many light years. All of these things are like incompatible with flat Earth. So if you're looking at the rotational problem of a galaxy, it doesn't help to bring that up, because all of these other things that are not compatible with flat Earth have already been part of the buildup to that. It doesn't help you. Because, okay, that one thing is a question mark. It doesn't mean that the 7 billion other things all collapse down. No, they're all still there. You want to take them down, okay, go find the flaws in them. But the flaw in the one doesn't bring all the others down. It's the other way around, right? If you find a flaw in the base, then all the things that are built upon it, you need to look at again. He's looking at the wrong end. Jeranism says, I think it's a little concerning that flat Earth and other conspiracy theories seem to be based around paranoia and mistrust. Usual thing of ignorance leading to fear and so on. Yes, it is concerning. Because there's peripheral things to flat Earth that they get brought into, right? Of course, if you think the Earth is flat, then you must think that there is a global conspiracy to hide it, and it must have been around for millennia with no evidence. That's a what is that? Hold on a second. If you think with no evidence that that's the case, then maybe I can ask. Hold on. What is that? What is religion?
What do you mean by religion?
A belief system built upon the doctrine of men void of empirical verifiable evidence.
Okay, so flat Earth is a what is it again? What's it?
What do you mean by religion?
A belief system built upon the doctrine of men void of empirical verifiable evidence.
Yep. So flat Earth is a doctrine of men with no verifiable empirical evidence. That is flat Earth. No verifiable empirical evidence for flat Earth. Yet you believe it. That is a religion. According to Whitsitt. And Jeran and Whitsitt, you know, they're kind of buddies. So String News 1. Is Jeran's point that dark flat makes the Earth dark flat? Or his dark elevation or dark lift? AYPDR Kuiper says, thank you, Siggy, for membership. Jiffy Cone says, this is intriguing. Did I do a thing? No, it's interesting. Kiwi Burb says, axis of evil, more like axis of flurf. The axis of evil is not evidence for Earth being the center of everything. Jiffy Cone says the real number of the beast is 616. Papyrus 115. I don't know what Papyrus 115 is. But yeah, the 616 I have looked into. And it does seem to be the case that the earlier manuscript said 616 and the later ones said 666. So, Factbase says, Jeran talks sex but cannot understand a sextant. He actually, he gets credit for that. He does understand a sextant and does understand how it measures things, and does understand how celestial navigation works on a globe, sort of. But he comes back around to the same thing. Well, magical math is how it was hidden. Well, if it was hidden with magical math, then just go unmagify the math and show how it's actually done. How far are you from, without using the globe, how far are you from from a star if you measure an angle to it? Don't use the globe, right? Unravel the math. The math, it's 60 nautical miles times the angle. How complicated is that math? it's a one-step multiplication. How could something have been hidden in there? Like, again, doctrine of men based on no empirical evidence. Claiming that math was baked into something is a religious position. The Sun Express says, is Jeranism the Antichrist? Yes. Proof 10 times all of 5 times 8 minus 1 minus 14 minus 9. 10 times that plus 19 minus 13 equals 666. Therefore, all flurf are the devil. Oh, I do like that website. It's 1:15. You guys. 421 of you. You're crazy. Siggy Sigwald says, for 5,000 ARSs. Thank you very much, Siggy. Jeranism. The light travels at 300,000 kilometers per second. It reaches us from as far as 13.75 billion light years away. I wonder, which geometrical shape has the center at the same exact distance as its surface? Oh, a sphere. So yeah, that's why it looks like we are at the center of it, because that's as far as we can see. And yes, that's totally what you'd expect. Right? We don't know how much farther it goes, and we don't know if it reaches an edge in any one direction. Maybe we will discover that someday. If it was, we probably already would have. So I don't hold out hope for that. Sorry, I'm yawning. If you're yawning at home, it's because of me. Siggy again says Enrique is the unsung hero of Glow Earth. Press F to pay respect. Hail Sagan. David Wellman says Lou Gehrig died of Lou Gehrig's disease. Coincidence? I think not. I don't know. I thought he was going to have a good year this year, but apparently it didn't work out for him. Streeters won. The point is you failed to prove flat, dumbass. And that's, there's the scientific method. Hypothesis for Jeran's test, right? 17-foot high camera, 17-foot high hole, 17-foot high light. If Earth is flat, then you should see the light through the hole at the camera. That's the hypothesis. A great hypothesis, and the test is pretty good. And it was falsified. That is a falsification of flat Earth. Yet another. Right? And you don't even need to confirm that the Earth is a globe to falsify flat Earth. But you know what? When he held it up above his head, not at 22 feet or 23 feet, but at about 19 and a half feet, it was seen through the hole, which is the actual globe prediction. Globe confirmed again. So, PhD Tony, no, Jeran, we don't think you proved curve. We don't believe you're that competent. Well, not prove. I think he confirmed that the Earth is curved at the rate that has been measured. When I ran the real numbers. PhD Tony again says, why should I trust you when you call me a liar? Yeah. Jeran gets pretty feisty as his emotions bubble up. Fact base says Jeran got his brain and education from Wish. Sigh. From Wish.com. All right. Graybeard says, why muck with lasers and boards when we can just measure reciprocal zenith angles? Well, yes. And the reason why flat earthers do the experiments that they do is because they are following the anti-scientific method. And they would not want to do a measurement that might disprove them, because then they would have to work harder at step 3, right? And maybe they have, right? There are a couple FLIRF surveyors. But though most that I've seen don't actually use theodolites, and theodolites are the instrument to do reciprocal zenith angles. It's like Rayism 24B. He's a retired surveyor, so I don't think he probably doesn't have any equipment. But when he was a surveyor, all he used, to my knowledge, was an auto level and a rod, right? So I don't, he was kind of a low level basic entry surveyor that was just doing, elevations in a very short area. He wasn't doing any geodesy. He wasn't doing any rectification between different coordinate systems, right? So there's the, coordinate system of the state planar system. He talks about the state planar system. Like, yes, there is a way that there's not one state planar system for the entire state that you live in. There's multiple. Why is that? Right? Except for the Northeast, there's a couple. Northeast that just have one. The reason why is because you can't have one for the entire plane, for the entire state. Actually, if the Earth were flat, then there wouldn't need to be different coordinate systems for each state. There'd just be one for the whole country. But why all these different state planar systems? Because somebody's baking in some numbers and then teaching surveyors how to go from one coordinate system to another coordinate system and applying the radius of the Earth in the process. How is all of that baked in? There's nothing to explain that. It's just faith in claims, blind faith in the doctrine of men that was given to you by your Papa Flurf. Crashes says, can Jeran give me the angles to the sun to make a digital sundial work on flat Earth? No digital sundials work on flat. No sundials at all work on flat Earth. The sun could never set on flat Earth. The sun would do an ellipse through in the sky if the Earth were flat. It wouldn't trace a line. It wouldn't be consistent 15 degrees per hour. It would, it'd do this. This is what you'd see. It'd go far back, go slow, and then it'd come forward, and then faster, and then slow, right? That's what you would see if the Earth were flat. It's not what we see. There's no explanation for sunsets. They're like, oh, they never have it. It's never like, okay, how far away will the sun set? I don't know. Okay, you have no answer. Shut up. Greg Andrews gifted a membership. Thank you, Greg. Count Dyscalcula says, Jeran converted from ASCII to hexadecimal is 4A65-72616E. It's got 666 and 616 in it. Coincidence? Perhaps? Well, that's the hexadecimal. In decimal, does it have those? Because I don't see it in the hex. Oh, it has 666 in it. But not, 616, but it doesn't have 666 in it. I must be missing something. Anyway. Ghostly Karma says, as a member for 4 months, says, Hail Sagan, hee, thanks for the gift, Siggy, and the lovely entertainment, MC Toon. Much love all. Thank you for that. Ghostly Karma. King Crew says, Night all, Hail Sagan, may Toon be with you. You don't want me with you. I was playing Ultimate Frisbee tonight, and it's hot and humid. So I got hot and humid, and then I drove home, and all I did was change my shirt. So probably not this room that you want to be in right now. Say that. The Copper In Quarter says, we don't see you, Enrique. Lift your light way up. Enrique. Interesting. Oh, poor Jeran. Fact Base says, to anyone struggling, you are never alone. Chat. Thank you. Yeah, definitely. If you're struggling, I've had a few people talked to a few people. Come on my Discord server. There's lots of people there most of the time, all day. You can find somebody to talk to. So All right. The Sun Express said Jeran should know that we can figure out the mass of a car simply by knowing how much fuel it consumed over a distance traveled. The mass of a car simply by knowing how much fuel it consumed over a distance traveled? I don't know how you can know the mass of a car from that. You could know, because you need to know the mileage. It doesn't you need to know a lot more information about the car. I don't know what you're getting there. Jim Smith says Brian Leakey has a video up on flat earth tests on his live stream. He's on it. Who's on it? Brian Leakey is on it? Flat earth tests. He does try to do some tests. I mean, he's no good, but... Oh, there it is. Yeah. He has a 1-minute video that he did live. Poor Brian. Poor Leaky. Melodic Lyrics says, I think you can get through conservation of momentum. Okay, I can get through that. I don't know what you're talking about, but okay. Roy Liu is a new member at Newton. Thank you. Siggy Sigwald with 500 ARSs says, so Jeranism is basically saying that the fact 1 + 1 = 2 doesn't mean 1 + 1 = 2 because the values can be anything, except the values are defined and the results are accurate. What the hell is he talking about? It's that blind faith that somebody baked something in and is hiding it from everybody. And the flat earthers who can't do any math are the only ones that are smart enough to know that the math was baked in, but they can't show where the math was baked in. They can only believe that the math was baked in. That's what it is. It's this blind faith. Yep, that's what he's talking about. PhD Tony says, Jeran is claiming he can falsify this. He needs to demonstrate this is possible because it's actually mathematically impossible to do what he claims. What was the topic on that? But there was a lot of things about the mass. Oh, was that about the mass of Jupiter and Saturn? And you could just throw any numbers in, but you can't. There's only some that work, right? And when you put the others in, and when you have all this whole web of interrelated things, you can't fake one and have another. He's claiming 1 is faked and 2 is faked. Like, all of them are faked somehow, right? So the actual people with telescopes can measure the orbital time of the moons of Jupiter, right? So if all of the things were faked and the mass of Jupiter was faked and the orbital size of the moons were faked, but all of the numbers still work out, how was that all baked in somehow, baked together? You can't just chuck numbers out there. These things, there's actual verifications that people did on all of that stuff. Long before computers, too. These people. Crazy people. All right. GPS says Jeran raised thousands of Jeran does, where he was going to give money away which hasn't been done. It's been more than a year. Strange. Well, I don't know anything about that. So he was going to give money away to something, but he didn't do it. All right. Shouldn't do that. If you're gonna promise to give money away, right? Dude, with the challenges that happened with Sean Hufford and Reds and no, that's just if you're gonna do it, you're gonna do a charity or something, I'll just give you a link to something else. Say, hey, I kind of think it's worthwhile. You go make your own decision. But I don't know the context of that. But The grumpy old mechanic says every university library has hundreds of feet of shelf space devoted to astronomy and geophysics journals. Which of the 400 some papers to the foot has the king of personal incredulity approved fake? Exactly none. All it is, well, they could have baked in numbers. That's it. That's it. And then it's all based on assumptions. Which one? Point out the assumption for neutron star. Point out the assumption. That, oh no, that's based on this measurement. Oh, you got to go to that one. Oh, and no, that's based on this, right? It's this cascade of things, of measurements. It's not assumptions. It's and I tried to keep bringing it back around. Jeran actually went out in the field and did real work, right? It wasn't a ton. It was a few days. It was, some of his personal money involved, probably. Not like James Bradley, who spent how many, so much time looking out through that telescope to figure out aberration. Months and months and months, and hand doing the math. So much, it's this huge amount of work that James Bradley did to figure out aberration. So much dedication and hard work and intelligence and focus. And Jeran spent a couple days out in the field. And he calls what James Bradley did just assumptions and just calculations. No, he really was looking through a telescope. And I'm like, it was accurate to 1 arc second. Oh, really? I can't believe that. Okay, show how it's wrong. I don't have to show how it's wrong. Yes, you do. Tyler Carr, CFI here. CFI. What's CFI? Certified Flight Instructor. Probably. It says aeronautical navigation charts are made with conic projections of the globe, specifically Lambert conformal conic projections. I have reference. I have them right up here. Look at this. I have a bunch. These are the, if you're unfamiliar, these are the operational navigational charts. You look at the first three, so the second and third video on my channel, and I put these together, made a triangle out of them. They wouldn't lay flat, and I put them over a globe, semi globe, half sphere that I built up out of PVC in my kitchen, and it fit. Somehow it fit. If the Earth is flat, how are globe navigational charts so accurate? A great question that no Flurf has ever answered. The best I get is, it's flat. All maps are flat. Siggy Sigwald says, for 100 ARSs, Jeranism, you measure the apparent angular size of a planet using a telescope, then in combination with a measurement of its distance will give you the planet's actual size. There are other methods too. Yeah, and his is, well, do you actually believe that they could do that with the measure the size of the telescope? Yes, they actually could measure the angular size of Venus with a telescope. It's not, just because you don't know, you haven't seen it, you haven't done it yourself, doesn't mean other people aren't capable of doing it. It's a little bit of the hubris of flat earthers. Like, they think that if they couldn't do it, then nobody else could do it, right? They think that they're the smartest person ever, right? Like, how is it, why would it not be possible to do a 1 arc second measurement in 1725? Why not? Because you can't do a 1 arc second measurement with the non-telescope that you don't own? Fact-based says face desk 6 times. Oh, 5 times and then ouch. Yep. PhD Tony says formally the units of curvature are per mile, or mile to the -1, minus curvature equals 1 over r minus r equals circle of radius that matches the curve at the point of measurement. Dude, that math, no. You're not going to get that math? Did I do that? Yeah. And then he interrupted me, but, and there's a flat earther on they don't get math, and they're so sure of themselves, even though they know they're not good at math. They will insist that their idea about math is the only possible way. Right? So this guy, he's been trying to talk to me. He's like, well, how much curvature in 300 miles? 4 degrees. And he wants it in feet or miles. Like, that's not curvature. That's linear. Linear is not curvature. There's no curve in a straight line. And this guy who doesn't understand math wants to tell me that I'm wrong. Okay, you don't know me. I get that. You don't know me. You don't know whether or not I understand math or not. But if somebody is saying that's not the right way to measure curve, you could just maybe go try to figure out the right way to measure curve. Just see, just check, just on a whim, just check to see if maybe curve is not measured in feet. Just give it a shot. Mr. E-Man gifted 10 memberships. Man, lots of new members today. Should be enjoying it. Let's see. And then of course it jumped. There it is. All right. Mr. E-Man says, are there any measurements anywhere of the Earth being flat? No. And they think that trying to measure their incorrectly calculated prediction of the globe, trying to measure that for the globe and not having it be perfect is a measurement of flatness. And, you know, I've asked flat earthers for measurements of flatness, and they've sent me videos of bottom-up obstruction tests over water. That's not a measurement of flatness. That's an attempted falsification of the globe that was poorly done. Actually, attempted falsification of the globe's specific radius. But the fact that there's still bottom-up obstruction confirms that the Earth is a globe. The best you've done, if you did everything right, which you didn't, was that you showed that the radius was wrong. But you didn't, because you didn't do the math right. You didn't apply the model correctly. String News 1 says, I want my mechanic to use a tape measure on my car. Yeah, does your car use a tape measure to measure distances? How many miles you went? No. It's not the only way to measure things. Larry Scott says, Venus, 7,520 miles. Earth, 7,920. That's 95%. It's 5% smaller. That's a great point, right? So the distance to the sun was measured by assuming that Venus was the same size as the Earth, right? That was an assumption. Absolutely. And if it was wrong, then the measurement would be wrong. And it was only off by a small amount, we found out later. So does that mean that the previous measurement was wrong? Of course not. The measurement was close. It was within the expected margin of error based on the later measured radius of Venus. You're doing all these things backwards, flat earthers. Eric Burns. I know, Eric, you must have just been burning in when he says, Type 1A supernova is a standard candle because they always have the same light curve due to the star exploding having the same mass of 1.4x that of the sun. All right. And then the next question is, how do you know that a supernova, a type 1A supernova, has 1.4x the mass of the sun? Which, of course, has been measured. And in that measurement was an input from a previous measurement. But in that measurement, there was a previous measurement that was included as an input to it. And in that measurement, there was a measurement that was included as a previous you see, it keeps going back, right? So, yeah, if an early measurement was wrong, then it cascades to errors in the rest of them. So, yeah, find an error and then go examine all of the others. Get yourself a big Nobel Prize, maybe. Right? Kiros says, Jeran, measuring spherical excess is something you or any flurf can do yourself. You can do it without assuming a sphere and all you want. Right? Yes. Now, measuring spherical excess is a bit harder than just saying you can do it. You can. You can. You can get a theodolite. You can go to the top of a mountain, and you can measure the angles to other mountains. But getting to the top of a mountain is a chore, right? And you need to do it to really do it, unless you're really good at, measuring things, you have a precision theodolite, and you really need to know what you're doing to do a good small triangle spherical excess measurement. And flat earthers aren't good at using theodolites. They're not surveyors. So how do you do that himself? How could Jeran do that himself is a good question. So yeah, I think going to a mountaintop and measuring angles to different mountaintops could potentially be a way to do it. Or you could do reciprocal zenith angles from mountaintop to mountaintop. Somebody asked me, can you, with your phone, with the theodolite app in your phone, could you measure reciprocal zenith angles? And you could, but you have to be really far away from something, and you need to be able to see that thing that you're really far away from. Then you need to go to the other side and see where you were. So again, a high peak, or maybe a building, right? Because the precision on this is 0.1 degree, right? Not 1/3600th of a degree. So if you don't have that kind of precision, well, then you need to have a bigger thing, right? And you don't want just a 0.1 degree. You'd maybe want 1 degree. Well, that's a long. You have to be far apart from each other. So, Stiggy Sigwald says the real reason I gifted all those memberships is because I secretly derive pleasure from knowing you have to add those names to the list. I've got Siggy, because of you, I've gotten pretty good at it. And I have to figure out why. There's supposed to be a scroll going here. And it doesn't, it stopped working. So I need to fix that, because all the members should be going across the bottom. The outro roll has it. But yeah, thank you, Siggy, for that. You know what I'm gonna show something. I paused. So when I do live streams, I do where'd it go? I pause. So all right, I gotta back up. When I do a live stream, I bring up the YouTube control panel. The YouTube control panel has a little inset of the video that I'm sending out. Now, I don't need that to play to see what's happening, right? Because I have the screen, the OBS screen that I look at. It's right there, right? So I pause it. I paused it at a very good time. So I'll show you that in a second here. Pull it up. There it is. So here is the where I paused it. So this is what I've been looking at the whole time. That's where I paused it. So you can go back to 14 minutes and 2 seconds in. You can see it for yourself. All right. But anyway, it's on the screen where all the super chats are. Right below that is where the super chats are that I'm reading. So, all right, Stringer News 1 says, Flurf brings a circle to a sphere fight. Yes. Mr. E-Man says, the people may be on the mountains are still on the globe. And yes, that's the thing. And he misses that that on a sphere, on the mountain or you're on the surface. You don't need to be all at sea level to do it. You can't see each other, right? Because the obstruction of the horizon, the curve is in the way. But if you could like have a stick, this is maybe a way to explain it. I don't know, might confuse them more. But if you had a stick at each of those locations sticking way, way, way up, miles up, right? However high up you'd need to have it. So you go to one spot and you got the stick right behind you. And you measure the angle to the two sticks that are sticking out. You do the same from all three spots. You think about it on a sphere, those sticks are all pointing in different directions. They're not parallel to each other. They're not coplanar, right? But you can still, from this location, you can still measure to that stick up there, right? I don't know. Might be a. Eric Burns says you need to figure out a way so the new memberships are automatically added to the scrolling list. So OBS has a way to do a text scroll, but it has a limit to the number of characters, and there's too many members for that list. So what I do is I go in and I render a video. And so when the scroll is going down here, that's an actual video playing. That's, just a short but wide video. So, and for some reason it decided it's not going to go. Something happened. I don't know what, and it doesn't work anymore. The outro does, but that's it. So, Bauer Rat says, "How is Jeran a flat earther after he proved Earth curve?" Well, because he denies it, and he did the math wrong, and so since he did the math wrong, it gives him that little bit that he thinks. Right? He doesn't realize the scientific method that he did, where he should see through the 17-foot hole, and the fact that he didn't see it falsified flat Earth, right? He falsified flat Earth. That's the primary output of his measurement, a falsification of flat Earth. But the secondary thing is that he confirmed that the Earth is a sphere, because the hypothesis of the Earth's sphere with the specific radius was confirmed, but he did the math wrong. And so when he said maybe we should do one just on that, that's what I was really hoping for, because I want to walk him through doing the math himself, because he has 8 inches per mile squared is the correct formula, the base formula, right? It doesn't include refraction, and there's a way to get refraction into that formula. It's not 8 inches per mile squared, it's 5.6 inches per mile squared for one coefficient of refraction, and it's 7.2 inches per mile squared for a different coefficient of refraction. So, and since he didn't measure a vertical temperature gradient, we can only estimate based on previous measurements of coefficient of refraction. So, all right. Tony Ingle says, person number 1 at the North Pole, person number 2 at the equator, and person number 3 90 degrees from number 2 in the equator would measure 90 degrees spherical axis. Yes. That would sum to 270 degrees. And so the up on my wall here behind me, I found the operational navigational charts do not cover over the water. These are visual flight rule charts. And if you're a VFR a certified pilot, you're not flying over the ocean. So they don't publish over the ocean where there's no land. All it would be over the ocean would be ocean, right? It wouldn't be useful. So they don't publish over the ocean. So, but they do go from Madagascar to India. There's enough islands in there that they did publish that there is a line that goes, and you can see it. This little strip right here. That's, oh no, wait, that's, nope. That's in the closet over here. I have it in the closet. that little section. So I had to choose a triangle where each of the legs was 10,000 kilometers, and it went through that part so that all of it was on the charts. So it was a bit of a challenge to find that. I spent a lot of time figuring out exactly where it could be. So one of the points is north of around Iceland, one of them is in South Africa, and one of them is around Hong Kong. And to do that, it goes right over the correct spot. Siggy says, all we have to do is live stream a view of the sky 90 degrees at our respective locations, US and Argentina, and then try to find a star we can both see and measure the angles. Yeah, I mean, that would do it. Measuring the angle to any star would do it. Measuring the angle to the North Star. But yeah, that'd be an interesting way to do it, because when you do those numbers, right, it's essentially kind of a reciprocal zenith angles way to do it. You look at the number, get this angle, you get this angle, and can we get the radius of the Earth from that? We probably can. Be an interesting thing to do. It's tough with the Theodolite app on the phone because the stars are not very bright and it doesn't show up on the screen very well. You have to be in a really dark area to be able to see it, except for super bright stars. But yeah, that's an interesting way, an interesting thing to try. So, Binge Thinker says, this was free, so I just want to say, got a light of flurf. Thanks, Jeran. Siggy said, MC2 and you made Jeran flurf reset itself. was that about the yeah, he did. He just goes around. All right, Killa Cuts says, love ya. Sparky Steve says, Jeran can count to 22 for show. Oh, I can count to 22. Piers 77 Tampa says, according to Jeran, measurements must have psychic powers, I read this earlier, to give different results based on assumptions. Totally. Sparky Steve says, Jeran wouldn't deny space photos if they showed a flat Earth. None of these grifters are worth talking to. P.S. You missed my super chat a few minutes ago. All right, hold on a second. Sparky Steve. Jeran can count to 22 for sure. That's the only two I see from you, Sparky Steve. So why what's 22? Because he's like, all right, 5, 10, use your feet, you get to 20. You gotta drop your pants to get to 21. Where's the 22? I don't know. Anthony Fox's Dark Lift seeks its own level. Thanks for the membership, Siggy. I like that dark lift. I mean, really, what keeps the sun and moon up? Dark lift isn't a good hypothesis because it's not based on any education. It's purely just because the sun is up, something has to hold it up. I'll just say these words. It's not like neutrinos, where particles leaving a reaction have a certain mass and velocity, and so they bring a certain energy with them. Right? So it's not a guess to say maybe there is another particle with energy and mass. Right? That's not a guess. That's perfectly reasonable because we have lots and lots and lots of examples of that. It's the most obvious thing. There are other things you could potentially say. You could say, well, that energy transports to somewhere else and shows up somewhere else. That energy, I don't know, the mass of something is temporarily hidden, and then later it appears again. I don't know. There's other ways that you could hypothesize for that missing energy. Kanko 44 says, if Jeran was 5 years old, this would still be very embarrassing. Yep, if Jeran was 5 years old. Thank you, Kango, for correcting yourself. Siggy Sigwald says the real reason why I gifted all the membership is derive pleasure from me doing it. Siggy Sigwald says checkmate OBS. Yeah, I mean, I'm like, screw you, OBS. I'll just render a video, and then your text character limit is not a problem anymore. Anyway, the Sun Express says Newton, right about calculus, wrong about delusional pursuits of secret hidden Bible codes and alchemy. Yes, he was an alchemist. And I've heard Florf say, "Oh, this is embarrassing that he was an alchemist." No, it's not. He was wrong about stuff. Yep, people are wrong about stuff. So I don't know how is that a thing? It's not a thing. People are wrong. Wow, it's 2:00. We started at 8. How many hours is that? That's 6. 6 hours. Wow, that went long. People, thank you very much. There's still 400 of you. You are the troopers. Saturday, I might be talking with Terry R. Eicher. I messaged him today. He said he's got a lot of work this week and it's been a little more difficult. So, not sure about that. If not, then he's good to come some other time. It's got to be on a weekend though, so it's got to be work with my schedule and his schedule. I'm got a couple more trips coming. Eric Burns says, with Venus, you could have also brought up the fact it has phases, meaning it must be orbiting the sun, which is evidence for the heliocentric model. Actually, I took some in melodic lyrics. No, darn it. But you know what I did, melodic lyrics? I got my wallet, got my card right here. And we'll get it. I have it in here so I can do it. Eric, I got some photos of Venus with the P1000, and I haven't yet reviewed them because the P1000 screen is tiny, and so I want to see if I actually got the phase of Venus. I know you can with the P1000, but the focus on it is terrible, and the chromatic aberration in the P1000 is ridiculous. At full zoom, it's awful. Everything's just this blurry mess. It's such a hard camera to focus, to get a crisp image at full zoom. Ugh, it's gross. So yes, I did not get CC's award yet. Darn it. I gotta get that. So, all right. Next Tuesday will be something you've not yet seen, and it will be a premiere. I'll tell you that. Okay, people. Let me get this. Thank you so much for everything you guys do, for coming along, just thank you. It's been great. You guys have stuck around this whole time. Thank you to Jeran for being a good sport. So show us the cats, says Venom. Oh my gosh. They're off sleeping somewhere, which is what I'm going to be doing pretty soon. So yeah, so be looking for a video to Mark Sargent on Conspiracy Tunes and a video to Mark Steele coming up. And hey, some feedback. I did 3 videos on using flatearth.ws website. I have a bunch more prepped. Craig and I are actually working on them together. What do you think about them? They were 1.5 to 2 minutes. I don't know if I can get them into a minute long, so they officially call shorts on YouTube. Are they useful? Are they are they, I don't know. You tell me. They're super easy to do, so I like doing them. I can do them, right? So if you're like, hey, it's a small use, then I'll do it. But also, How often should I put them out? On Monday went Hateful Keating. I'm like, maybe one a week, and then we can discuss it for the week, right? We could all just say, hey, Flurfs, what about this for the whole week? You know, we can join together in unity at Flurf busting, Flurf crushing the dreams of the Flurfkin. Well, feedback on Discord. And everybody, thank you very much. We'll see you later. Not you, Gary.